Welcome to Java application development. Before we can start with creating our very first application, there's some tools that we will need. One of the tools is the Java Development Kit, or the JDK. Now this is all the libraries we will need to start developing in Java. So you'll see that in Google I just searched for JDK, and the first link that comes up is the one that I will click there. Now if you go down, you'll see that we've got the Java SE Development Kit 8U161, but there's a newer version, the 162. So get the highest version that you can get here. So you're going to accept the license, and then you can see there's the different downloads. So whether you're on a Mac or on a Windows machine or on Linux or wherever you are, you can download that specific version. And you'll also see in Windows there's a 64-bit as well as the normal 32-bit one. So just choose your specific JDK and then start downloading the JDK. Now the other tool that we'll need is the integrated development environment. And this one we will use to write our Java code. So there are many to choose from, including NetBeans, Eclipse, as well as IntelliJ. So we will focus on using IntelliJ. So on Google again, you can just go and search for IntelliJ, go to IntelliJ IDEA, the first link there. It will take you to this page where you can just go and click on download. And then when you go down, you'll see that there's options for Windows, for Mac, and for Linux again. So you're going to choose for Windows there or for Mac, depending on your specific operating system. Let's say you're on a Windows machine. You can see that there's an Ultimate Edition and there's a Community Edition. So for now, we're just going to go with the Community Edition. You can choose the exe file or just a normal zip file. So we're going to download the community version there. So you can click on download. You can also see what's the differences between the two versions. But download the community version. After downloading the community version, you can just install IntelliJ. But very important, firstly, make sure that you install the JDK. After a successful installation of the JDK, go and install the community version of IntelliJ IDEA. Now, if you want the ultimate, you can always go to buy there. So this is not a free version. The community version is for free. But you can see there's some discounted and complimentary licenses for startups, for education and training, for students and teachers, and so forth. So you can also go and have a look at trying to getting this one for free. So go and install your JDK and go and install IntelliJ IDEA, and then I'll see you for the next video. In this video, we will get you started on creating your very first Java application. So after installing your JDK, the Java Development Kit, as well as installing IntelliJ IDEA, the community version, you will get to a screen like this when you run IntelliJ for the first time. You'll see there's the version. So I'm currently using this version, which was basically the newest version when installing it. And then you've got some options there. You've got create a new project, import the project, open the project, or looking at some version control, which we will not have a look at now. So what we basically want to do is to create a new project. So creating a new project is the same as saying I'm creating a new application in IntelliJ. So I'm going to click on creating a new project. It will load the templates and then it will give you the screen. So you'll see there's a selection for Java and some other stuff there. So we're going to keep it Java there. You're going to click on Java there. And then you can see the project software development kit, which is basically the Java development kit that we downloaded. So you're just going to make sure that you've got that specific one selected here. So remember we downloaded Java Development Kit 8 Update 162. So this is the one I want to select here. You can see I've got other versions on my laptop as well, on my computer as well, but I'm going to choose that one. Also, if you need to go and search for a specific one, you can go to New there and you can browse to your specific JDK that you downloaded. There's some additional libraries and frameworks. We're not going to get into those, so you can just say next at the bottom. Also not going to create a project from a template. We're going to start from scratch, so you're going to say next. Then the next screen will be your project name. So for the project name, I'm going to call this one Hello World. Normally the first program you write in any programming language. So we're going to have Hello World as the project's name, and then your project location you can choose there using the 3 dots. If you want to put it somewhere else, mine will be fine in the default. So then I'm going to say finish at the bottom, and then your project gets created. So now the project is created. On the left hand side you can see project there, you can see packages and so forth, but we're going to keep at the project view there. So if you go into the project view, you'll see a few folders. You'll see the idea folder, which we're basically not going to do anything with. The Hello World IML file, we're not going to do anything with it. The one that we are interested in is the source file folder there. So it's the src folder. So what we want to do is to start creating our source files in this specific folder. So I'm going to right click that folder and I'm going to say new, and you can see there's a new Java class which we essentially want to create, but we're going to arrange our Java files to be in packages. So I'm going to create a package first. Now, what is a package? A package is basically a namespace that organizes a set of related classes and later on interfaces also. So conceptually, you can think of packages as being similar to different folders on your computer, and you might keep, for example, HTML pages in one folder, you can keep images in another, and whatever, your applications in another folder. So because software written in the Java programming language can be composed of hundreds or even thousands of individual classes, it makes sense to keep things organized by placing related classes and interfaces later on in packages. So for now, let's just keep the package as com.foundations. Right, so that's the package name, com.foundations, and you're going to say OK. And I can see I've got a package where I will place all my foundation type of classes. So I'm going to say new there. Again, right click on your package, say new again, and you're going to choose Java class. And we're going to keep this Java class also as Hello World. Please note that for creating new class names or classes, there cannot be any spaces. So you can use the underscore, whatever, but you cannot start with a letter or a number. Sorry, you cannot start with a number. You can start with letters of the alphabet. And then normally our classes would be all capital letters when we start creating the class with no spaces, and every subsequent word we will capitalize that word. So which means that if I want to say hello world, world will be my second word, so I'll capitalize the W. But it's just a good programming principle to do it like that. And then the kind of create class that we want to create here, you can create classes, interfaces, and so forth. So we're going to keep at a normal class and then say OK. So then our class will be created, and you can see that under your package you'll now have your Hello World class. Now the Hello World class you cannot run. You can see there's no run command anywhere here, because this class does not have a main method to run from. So when you start off, you'll see that your class will basically just have a class declaration. So now a class declaration in Java will basically start with the keyword public, and then class to say, well, this is our class name, and then your class name. So that's the one that we chose now when we created the class. So the class name is obviously up to you as programmer what the name of the class would be, but it must be public and it must be class for now. Okay, then inside of your two brackets is where everything happens now. So now inside of this, we need one method, which is the following: public static void main. And we'll talk a bit more about static and void and so forth when we get to methods. So for now, just use the main method, or see the main method as the main method where everything starts in your application. So we're going to have string as an array, args there, and that's your main method. And as soon as you've got the main method, you can see there's a play button that now appears, because now we can run our application. Every application will need the main method. So there's another shorter way to do this. Instead of typing public static void main out, there's a public static void main, PSVM, which is a shortcut or a live template that you can use. And by just clicking and selecting it, it opens up that whole piece of coding for you, and you can start coding right away. So it's up to you whether you want to type it out or just use the live template there. So again, the live template is just public static void main. Public static void main. I think it's done because I already did it. So just to do it again, public static void main, and there you can see there's the live template, and you can use that template. Okay, so now inside of my main method is where everything happens. My application starts inside of my main method. So just to look at this again, you can see at the top, we can see that this specific class that's called helloworld.java is in the package called com.foundations, and we can see it there as well. There's com.foundations and there's the Java file. Then the class declaration just after your package is public class hello world. That's the name of our class. It's publicly accessible, which means it's accessible in any of my packages. So if I've got another package with classes, it will be accessible there as well. But we'll talk about access specifiers later on. Right, and then you can see there's an opening bracket and there's a closing bracket. And then when we start and we get into our main method, there's also a closing, an opening, and a closing bracket. So that's very important to note, that it starts there, the method, and it ends there. It starts there, the class, and it ends there. Okay, so we're just going to do something simple now by just basically printing out something to the screen. So for that, we can use the system.out.println, and this will basically just print a line of text to the screen. So when you work with strings or text in Java, we use the double quotation marks. When you use characters, which is only one character, you use the single quotation marks. So for this, the println method accepts basically a double quotation mark, which is normal text. So we're going to say something like, let's just say hello world. Okay, and that's basically what we want to print out. Now, if you use system.out.println a lot, you can also just say SOP, which is a live template for system.out.println, and that just gives you system.out.println as well. Okay, so we've got hello world there. Let's run this application. So we can click on that little play button there and say run hello world.main, and it will then start running your application. Right, so you can see there, it prints out hello world to the screen and then it's finished. So let's say hello new world. If you want to run it again, you can see then the run button there appears at the top, saved that you want to run this specific main method. And you can see there changed to hello new world. So congratulations, this is your very first application. I think just before we stop with this video, very important in Java, every single line in Java must be closed down by a semicolon, except for where you've got brackets. You can see there's no semicolon, or where you have class headers or where you have method headers. But for every single line of code that you need to execute, there must be a semicolon at the end. Congratulations for running your very first application. In this video, we will look at variables, literals, and constants in Java. Let us start with variables. I will use this cabinet to try and explain how variables work. Variables are used to store information to be referenced and manipulated in a computer program. They also provide a way of labeling data with a descriptive name, so our programs can be understood more clearly by the reader and ourselves. It's helpful to think of variables as containers that hold information. Their sole purpose is to label and to store data in memory. This data can then be used throughout your program. So if we look at this cabinet, the cabinet has different drawers that we could say in programming terms are variables in the cabinet. Every drawer has a label on it. We can see labels for food storage and ovenware. Let's just take those two. The drawer for food storage has the label or name food storage. What type of items do you think will be stored in that drawer? Yes, obviously food items. If that drawer was a variable, the type of the variable would be food, and the name for the variable would be food storage. The same is true for ovenware or linens. Now, would you store food items in the ovenware drawer or cutlery in the food storage drawer? Definitely not. The same is true for Java variables. You store only the type of items that it is defined for. Now let us look at the different types of primitive data that we can get in Java. In this table, you can see the data type, the size, and the range of the specific data type. Byte, short, int, and long are all integer data types of different sizes. Note that a long data type can store 8 bytes and an int data type can store 4 bytes. Float and double are floating point numbers or real numbers and can store 4 bytes and 8 bytes respectively. Some other data types that we will work with include booleans. So the boolean data type has only 2 possible values, either true or false. Use this data type for simple flags that track true or false conditions, and this data type represents 1 bit of information, but its size isn't something that's precisely defined. We can also use the char or the character data type that can only store 1 single character and uses 2 bytes to store. One other data type that we will use is the string class as data type. The string type will be used for text. String is actually a class, but for now, see the string data type in the same light as the other primitive data types. We will get to classes and objects at a later video. Enough talking, let us see how we can use variables in coding. Right, when you open up IntelliJ, we can go and create a new project now to test out the variables. So we're going to go to Java again there, just choose Java at the top with your project SDK selected. We're going to go to next and next again, and then type in the project name. So for the project name, I'm going to say variables, literals, and constants. Okay, and then I'm going to say finish there, and that creates my project for me. Okay, then after the project has been created, we're going to go into the source folder again, right click, say new package, and I'm just going to call this package com.example. You can name it whatever you want, and then on that package you right click and you say new Java class. This class I'm going to call now variables, literals, and constants. Now you can see there that in this one there, your project name, I've said variables, comma, space, literals, and constants, and everything, there's spaces and so forth. But when you create a new class, there cannot be any spaces. So you can create a new space by basically just using the underscore there, if you want to separate the words a bit. And then I'm going to say OK there, so that's the name of my new class. And then because we need to have this class run our application, then we need the main method. So we're going to say public static void main, that's the shortcut, and then there's our main method where everything should start. Now in the main method, I'm going to create two variables. So I'm going to create a variable called first number, and I'm going to create a variable called second number. Now in Java, then when we declare variables, the int part there, the very first part there, is called the type. And in this case, it's an int or an integer. And then the second part there of the declaration would be the name or the label for your variable. Now the name for this variable is then first number. So let's look at the second one. There's the declaration. That's the type. It's going to be integer. And then the name or the label for that variable will be second number. Now just note again that there's a semicolon after every statement. If you leave out that semicolon, it's going to give you a problem there. It will say that it is expected. So let's assign some values to these two variables. So let's say first number. Now this is the assignment operators, the normal equal sign there, and we're going to set a value of 11. Well, you can set any number there. So the first number then I'm setting as 11. Now because this first number was declared as an integer, I can only save integer values into it. That's like the drawer again. The drawer's type is now integer. The label on the drawer will be first number, and what am I placing inside of the drawer will be that 11. Now if I make the 11, let's say 11.5, which is now a floating point number or a real number, then if you hover over it, you can see the error there. It found a double, which is a real value, and it requires an integer. So we can only save integers into this variable called first number. Let's go back. We can also not save any text. So you can also see there it picks up this is a string. Now remember, string in Java is basically text, and it's required an integer, but it found a string. So you can see again that it's only integer values that is allowed there. So let's just leave it at 11, and I'm going to add the second number. Let's assign the second number a value of 20. Now let's say we want to work out the average between these two values. If I set 10 there, then the average would be 20 plus 10, which will give you 30, divided by 2 equals 15. But if I make that an 11, it's 20 plus 11, which will be 31, divided by 2, which is not 15, but 15.5, which is a real number. It's a floating point value, which means that if we declare a variable to hold that answer, let's call it average, we must declare that variable then as a double, so it can hold comma values or floating point values or real numbers. So that's why we declare it as a double. And then we can work out what should we store now in this variable called average. So how do we work out the average? We need to take the 11 plus the 20 and divide it by 2. So the 11 is in the variable called first number, we're going to add the second number, and then we're going to divide by 2. But now, the same as your calculator would do, it will basically take second number divided by 2 first, and then add that answer to the first number because of operator precedence. So it's exactly the same thing, but what we want to do here is to first get the answer of those two values, first number and second number. That's the plus sign there. We add the 11 and the 10, and then that answer of 31 we divide by 2. Okay, so just remember that if you put brackets, you're forcing that part to take place first. Right, and then we can print out this by just typing a normal system.out.println. And what we want to print out here is the average. Now I can type this. Let's print out the average like that. Now if I run this, you will see that it is the word average that gets printed out because my name average or the word average there is in double quotation marks. So if I print out to the screen and it's in double quotation marks, it will print it exactly as I typed. So in order for me to print out only the variable or what is saved in the variable, there must be no double quotation marks. So now I'm printing out whatever is saved inside of the average variable, and if I run it now, you'll see it will be a number and not the word average. So you'll see we get a 15.0 there. Now 15.0 is not correct. We'll get back to that now. Okay, so before we carry on, I want to add the word average there with a colon and a space. So I can use the plus sign again to add some text with whatever is saved in the variable. So you can see there's the plus sign again. So the plus sign here and there are two different things. Here the plus sign is actually the addition operator where we add two numbers. So it will be 11 plus 20, which will give me 31. Whereas this plus sign there is adding some text to a number, or adding a number to some text, which means that this plus sign there is not an addition operator, but it is the concatenation operator, which means to the text I'm going to add some more text, but this text will come from the variable called average, which is a double. Okay, so we're going to print out, let's see this one now. So it's going to print out the word average just as it is with the colon and the space, and then whatever is saved into average. So you can see there's the printout. Average with the colon and the space, and then the value that we found in average. So now the value for the average is 15.0. So let's look at the average again. 11 plus 20 gives me 31. 31 divided by 2 is not 15, it's 15.5. So what Java did now is it threw away the decimal value. We call that integer division in Java. So basically what happens, your division operator, if both sides of your division operator is an integer, then Java will throw away the decimal part. So in order to correct this, I can just go and put a .0 after the 2, which will make this one a double and this part there an integer. So I don't have integer division anymore. One side is a double, the other one is an integer. So if we run this again, you'll see that your error will be corrected and we'll get the 15.5. Another way of doing this, remember you only need to change one of the two sides. I can also change this side, but I cannot go and say .0 there because we're working with variables here. So you can also cast this or convert it to a double, which means that the sum of first number and second number will then be converted to a double and then divided by an integer, which will also work 100%. So if you run that, you will get exactly the same output. Okay. So the easiest way is just to go and put a .0 there. Now let's look at some other variables that we can use. So this is basically the numbers. The ones we use most is integers and doubles, but remember there's different types of integers like the byte and the short and the long as well. And also with the double you can also use float instead of double. But these are the most used ones. Okay, so let's look at strings quickly. So I'm just going to work with a name and let's say a surname. So we've got two values there, or two variables. Both are declared as string, which means we're going to save only text as double quotation marks into these variables. Now, just a thing to note there, you can see that your int and your double are in blue there, which means they are primitive data types, and that's why it shows in blue. You'll also see when we do the character and the boolean now after this, it will also show blue. They are normal primitive data types. Because string is actually a class, it will not be in blue, but we'll get to classes later on. So for now, your variables of type string works exactly the same as with your double or your integer. Okay, so now we've declared the name as type string text, and the name of the variable or the label for the variable will be name. The same for the bottom one, the type is string, the label or the name is surname. Now let us assign some values to these two variables. So I'm going to say the name for this guy will be John, and the surname will be, let's say, Rambo. So now what have we done? We've declared the name variable as a string, and we've assigned a value to the name variable as John. Now just look at the assignment there. You can see that it is a double quotation mark and then whatever the text that you want to display or want to show or save into the variable. So in this case, it must be double quotation marks. If I try to add a number there, you can see that it says it has found an integer there, but it should be a string. It's required to be a string. We could also put a 10.8 there or 10.0. It will still be a number value. It will be a double in this case. And I can also put in characters there. So even a character, you can see it found a char there, which is a character, and it's not a string. It's not normal text. Okay, so it must be double quotation marks. And let me just change this back to John Rambo. Okay, and then when we print it out, I'm going to print out, let me just say name there, then the concatenation operator. Now what I want to concatenate is a space. So this is how I'll do a space, just a normal double quotation mark with a space in between, and then concatenate the surname. And then if we print this out, or we run this now, just after your average, we will have the name, which is John, then a space, and then the surname, which is Rambo. So it will print out John Rambo. Okay, so that is strings. Now let's look at another one there. Let's take the boolean quickly. So that is the boolean. Remember, boolean values are either true or false. So let me just call this one value. So this variable is called value, and the type for the variable is boolean, either true or false. So to this value, if I try to save a number now, you can see that it found an integer, but it wants a boolean. Also a 10.9, for instance, now it's just a double, but it accepts a boolean. If I add some text there, let's say the text of true, you can see it's still text, it's not boolean. So for your booleans to work, it must either be true or it must be the false value. So those are the only two values that you can have for the boolean. It's either true or false. And then we will have a look at booleans a bit later on when we do the decision structures. But for now, let's just print it out. So if we print out, and you want to just print out that value, which will be whatever is saved in the variable called value, which will be false. So if we run it now and you print it out to the screen, the value should be false. Okay, let's look at the last variable for today, or type for today, and I'm going to look at the character quickly. So for the character, it's basically just a letter of the alphabet, and we can assign, let's say, a J there for the letter of the alphabet, and you can see that characters actually accepts characters as a single quotation mark. Characters are also number based, which means that I can add a number there, which is a representation of a specific character. So which means basically we can add integer values there for a character or normal character values. But if I try to do 12.9, it will say it's a double, it should be a character. Okay, so now for this one, let's just add, even if I add normal text as a double quotation mark, it won't accept it because it accepts only one character. So I'm going to use the J there, and that is the letter that we want to print out, and let's print out without double quotation marks just the letter of the alphabet there. And if we run it, you can see that we've printed out that letter of the alphabet. Right, so now we said this example will go about, or will be about variables, literals, and constants. So what is a literal then? So we all know by now, hopefully, what is a variable. So these are variables, a place to store data of a specific data type. So now what is a literal? If I look at my variables, this would be a variable, but the value that I assign it, a number like this I'm doing now instead of a variable, we call this a literal. So a literal is basically a notation for representing a fixed value in source code. For example, 20 will be fixed. Whereas first number, I can go and change first number if I want. I can say first number should now be 30. And then when we work out the average, it will be 20 plus 30, which is 50 divided by 2, and it should be 25. So there's the value of 25.0, which means that this is a variable. So for a variable, I can change the value of a variable, but a literal stays fixed. That 11 stays an 11. This 30 stays a 30. Let's go down a bit. So you'll also see that even in the system out print line, this text that I have there as raw code, raw text will basically be my literal. The same for my name variable. That is the literal. This is the variable. That is the literal. This is the variable. For my booleans, false is the literal there, and value will be the variable. The same for my letter or my character here. That is my literal. This is my variable. Now the last thing for this example will then be constants. Let's just have a quick look at what is a constant. So a constant are like variables in their declarations and the ability to look at the values stored inside of them. However, you cannot change the values while the program is running, and the value of a constant remains, rather unsurprisingly, constant. So in order to create a constant variable in Java, we will use the final keyword. So you'll see as soon as I add the final keyword to a declaration of a variable, I cannot change the value of that variable once it is assigned a specific value. So first number you can see is assigned the value of 11. Because I'm saying first number must now be a constant by adding the final keyword there, it means that this value for first number must stay 11 and I cannot change it throughout my coding. And that's why trying to change it then in this line will then give me an error and I cannot change it at all. So that's the difference between the final and the normal variable. Okay, so I need to remove that one line of coding then, and then everything would be fine. So the constant just means that this first number is now defined a specific value of 11, and I cannot change that value of 11 throughout my coding anymore. It must remain that specific value. Well, I can change it there. I can make it a 13, and then throughout your coding, it must stay a 13. It just means that somewhere along the line, I can't go and say first number equals something else now. It will give me an error. Now, another thing about constants is normally a good programming principle would be to make all uppercase when you're referring to a constant, which means that that first number there must actually be first, and you can use the underscore there, number. So all uppercase will tell us as programmers, somebody that reads your code, that that is in fact a constant because it's all uppercase. So you can see that I changed everything there. I know now because it's final in Java, first number, that value cannot change and it will stay the same throughout the coding. And that is it for this example. See you in the next video. A program without some sort of interaction with the user is no program at all. In this video, we will see how we can get input from the user by using the scanner class and the system.out.println method. So what I've done so far is to create a new project like we did in the previous videos, and I've created in the source folder a package called com.reading.input.scanner, and then I created a new Java class called readingInput. In that class, I've created the main method. So basically nothing new. So what I want to do is to create those same two variables that we created in the previous video. So I'm going to say first number, and I'm going to also declare second number. But now instead of just assigning values to first number and second number and working out the average, we could ask the user for some input. So in order to ask the user for input, we need to use a class called the scanner class. Now the scanner class is basically a class that helps me to read input from a specific source. So in this case, we're going to read the input from the keyboard, whatever the user types. So I'm declaring a variable here, and I'm going to call this variable keyboard equals, and because we're using classes, the new keyword creates a new object of a class, but we'll do classes and objects later on. So just memorize this one line of coding as basically the line of coding that helps you to set up reading from the keyboard. So it's going to be new scanner, and then what the scanner class then accepts is system.in. So basically what we're doing here is we're saying we're creating a new scanner object, and this scanner object on this variable saved in the variable will be able to read input from the keyboard. And it's not because the name there is keyboard. Remember that name, you can name anything. We can make it a KB there for keyboard. It reads the data from the keyboard. So now in order to read something from the user or to get some input from the user, we must first ask the user to enter something. So we're going to print out to the screen, please enter the first number. Something like this. And then if we go to the new line now, so we ask the user the question, please enter the first number. Now we need to get the input back from the user. And whatever the user typed, I want to save now into the first number variable. Remember in the previous video, we just said first number was equal to 11. So instead of now saying it's equal to 11, let's let the user decide what the first number must be. So we ask the user, please enter the first number, and then as soon as we call the following, KB is now referring to that scanner variable there, the keyboard or KB dot, and you'll see that there's some next methods. There's a next int that will read an integer from the user. There's a next byte that will read a byte from the user, or a short, or a big decimal, or a boolean, or a double, or a float. And then you'll see that there's no next string method. But the next line method there, you can see returns back a string from the user. So in this case, our first number is declared as an integer. So we want to use the next int method that will return an integer from what the user entered. Now let's do the same thing again. We say, please enter the second number. And we get the second number from the user. So how do we get the second number? Into the second number variable, we're going to save KB again, which is the connection to the scanner class that will read input from the keyboard. And we're going to call, please read from us an integer from whatever the user types on the keyboard. So we're getting back an integer, and that integer will be saved into second number, the same we did there. Now let us work out the average. So again, we're going to say double average as we did in the previous video. But now I want to define this in one line. So you can see I'm declaring the variable double. The variable's type will be double. The name of the variable is average. And now I'm going to assign it in the very same line. So let's see how we're going to do this now. Because now, the same as the previous video, we need to get the first number plus the second number, and then the answer of that divided by 2.0. Remember why we have the dot zero there. It's for integer division, so that Java do not throw away the decimal part. So that's the average, and then we can just print out the average and say the average is, and then just show the value of the average, which will be 100% fine. So let's just run this one quickly. Right, so you can see then it basically gives me, please enter the first number. Now the user can type the first number, let's say 11. Please enter the second number, 20, and then it will print out the average is 15.5. If I run it again, I can use different values there. This is the one we used in the previous video. So let's take 3 and 5, which will give me 8 divided by 2, will also give me 4.0. Okay, so I think the program is working at this stage. So this is how you get input from the user by using one of the next methods. So let's just try another example, and let's work with strings a bit. So we're going to have string name, and we're going to have string surname, just like in the previous video. And again, now we want to ask the user, please enter your name. And we wait for the user to enter his name. So now while we wait for the user to enter his name, we're going to say, well, to the name variable, I want to go and save whatever the user types now. So again, going back to the keyboard, the connection to the keyboard via the scanner class, and I'm going to call one of the next methods. So in this case, it's only the next line method that returns back a string for me. So I'm going to use the next line method. That next line method will read whatever the user typed, and it will bring it back to me as a string. So now we're going to ask the user again, please enter your surname. And then we're going to say surname equals KB, connection to the keyboard, dot next line again, but because we're working with strings, and that will read whatever the user typed. And then we can just print out to the screen. Let's just say name and a space and surname. Right, so let's just see how this one works. So you can see there we ask the user, please enter your name. The user enters the name. The next line method gets the name for me and saves it into the name variable. Then we ask the user, please enter your surname. The next line method gets that surname as a string or as text, and it saves it into the surname variable. And then we print out both. So let's just see how this one runs. Okay, so we're going to enter the first number again. Let's just say 1 and 2. And then you can see there it says please enter your name, but it didn't give me chance to actually enter my name, but it moved on to the surname. So let's just say the surname will then be Rambo, and then you can see it only prints out Rambo. So the problem here is in this line, it doesn't allow me to enter my name. So this is one thing also you need to remember with working with Java and with these next methods. If you've used one of the next methods, which isn't the next line method, so it could be next int, next short, next byte, next boolean, next double, any of the primitive types, just not the string one or the next line one, then after using the next int or the next double or the next whatever method, you try to use the next line method, it will have this specific problem. But if we only worked with strings now, we wouldn't have got that problem now. So basically what happens when you call the next int method and the user clicks on enter, that enter of the keyboard actually creates a new line character in the buffer of the computer. And the next int method is designed to basically just jump over that new line character and just basically read the value. Whereas the next line method is not designed to do that. So actually what we do then, after you use next int or next double and you want to use next line, you will just call this one by saying kb.nextLine, which will consume the new line character for us, and then we can proceed as normal. So when do you do this? This extra line there, basically only when you've got a next int, next double, next short, next byte, next boolean, and then directly after that, you're using the next line method. Then just remember to add this just kb.nextLine so it consumes that character for us, and then we can actually proceed with the rest of our program. So if you run it now, you'll see by just adding that one single line, it will now work 100%. Now it asks me what's my name. My name is John. My surname is Rambo, and then it prints out John Rambo. Let's just run it again. All right, the name, Peter Pollock, and there's Peter Pollock. So now we got input from the user, and we're using that input to do something. In this case, just printing it back out to the screen. So this is reading input from the user using the scanner class. In this video, we will see how we can get input from the user by using the JOptionPane class. In the previous video, we've seen how we can get input from the user using the scanner class as well as the systemoutPrintln methods. So just before I start with this one, you can see that I created a new project called Reading Input Using JOptionPane. There's the package com.example.read.joptionpane, and then the class name read JOptionPane. And then as part of the class, you can see that I've got the main method there. Now in this example, I'm going to do things a bit differently. I'm going to start off with asking for the name and the surname instead of asking for the first number and the second number. And so we'll do that example just after this part. So now in the JOptionPane part, if I want to ask the user now, please enter your name and please enter your surname, and I want to save that, I will do it as follows. I'm going to say JOptionPane there. So if you start typing JOptionPane, you'll see there it is. It's from the java.x.swing package where you can get the class JOptionPane. So I'm going to select that one. As soon as I select it, you can see that it adds an import statement at the top that makes that whole package available to me, which includes the JOptionPaint class now. So I'm going to put the dot there, and the method I want to use there is the show input dialog. And you can see the show input dialog accepts text, and that's basically what I want to ask the user. So I'm going to ask the user, please enter your name. Now what this will do, I think I'm going to actually run this one to just make sure that we understand what this does now. You can see now it pops up this window where it asks the user, please enter your name. So now the user can enter his name or whatever you ask the user to enter in. He can choose cancel, and he can also choose OK. At this stage, it won't do anything at all because we haven't done anything with this name. So let's carry on with the rest of the program. So that's what the JOptionPaint input dialog is doing. It pops up that little pop-up window that asks for please enter your name. So then the surname would again exactly the same thing. JOptionPaint dot show input dialog. Again, we want to ask the user a question, and we're going to ask him this time, please enter your surname. And now his surname will then be saved into surname. So the thing about this show input dialog method, it returns text. In Java, we refer to text as a string. So basically, it returns a string back, and that's why we can save it into a string variable. Okay, so now at this stage, let's just print out something. Now, instead of saying system out print line, I can just use JOptionPaint again by saying JOptionPaint dot show message dialog this time. So if you just want to show something to the user and not ask him a question where you can enter something, you just go with JOptionPaint dot show message dialog. Now the first argument must be null there, and the second one is the text that you want to display to the user. So now this parent component that's null, later on when we work with graphical user interface, or when you can dig into graphical user interface a bit, the component there could be, for instance, a button on your user interface, which means that this message dialog will show above that button or on directly onto that button basically. So by supplying null there, we're essentially saying this message must be displayed in the middle of the screen. So the message will be, and let's do the message as name plus a space plus surname. And then let's run this one quickly. Right, so it asks, please enter your name. I'm going to enter the name John. Okay, please enter your surname Rambo. Okay, and then it shows me the message John Rambo. Nice in a window type of interface. Okay, so now let's try the other one. We ask the user for two numbers and we work out the average. So it's going to be first number again and second number. Now let's do the same thing. We're going to say first number equals JOptionPaint dot show input dialog, and we're going to ask the user the question, please enter the first number. But now you can see that this one gives us a problem now, because required as an integer, because we declared first number as an integer, this method is returning text, and we cannot save text into an integer variable. So there's some steps we need to follow now to convert whatever the user typed now to an integer so that we can save it back to this one. So let's do this one a bit different. I'm going to create a variable there for the string. So I'm going to call it input to get the input from the user. Now instead of saying first number there, I'm going to use input, and you can see now no problem at all, because it returns a string here and I'm saving it in a variable called input, which is of type string. No problem. But now how can I get that first number? So now I'm going to say first number equals. So what I want to do now is to convert whatever was saved in input now by the user, to convert that to an integer so that I can save it into first number. So now how do you convert it? If you want to convert from a string to integer, you're going to use the integer class, integer.parseInt. So it's one of these parse methods. And I'm going to say integer.parseInt, and I'm going to pass in the input that I got from the user as text. So the integer.parseInt method will take the input, convert the input to an integer, and then save it into first number. Let's say that this one was actually declared as a double. Then integer.parseInt should then be double.parseDouble. And then you indicate the string that you want to pass there. In this case, again, the input. Okay, so there's a few parse methods that you use with the specific class in order to convert from a string to that specific type. Right, so let's just change this one back again. I'm going to make that an integer again. And then this must be then integer.parseInt. And this method will then convert the input to an integer and save it back. Right, so now we're going to do exactly the same thing for the second number. I'm going to use input again equals JOptionPane dot show input dialog again. And this time I'm going to ask the user, please enter the second number. Okay, so now we can enter the second number. The second number is saved then as text into input, which is declared as a text. But now I want to have it as an integer. So I'm going to say second number equals, again, integer dot parseInt, which will convert that input for me to an integer. So the input is whatever the user typed. It's saved as a string, and that string we will take, convert it to an integer, and save it back into second number. So now we've got the first number and we've got the second number. Now let's work out the average. So it's going to be double average again equals, and now again the first number plus the second number, that answer divided by 2.0 to keep the decimal value, and that's the average. Now to display the average, we're going to do the exact same thing as we did there to display the name and the surname. So we're going to say JOptionPane dot show message dialog, first argument null, which means we're going to have that message pop up in the middle of the screen, and the second one is what our message will be. What do we want to say? So we're going to say there average, and then show whatever is stored in the average variable. So let's see if this one runs. Run this one quickly. It's going to ask us first for the name and the surname again. Let's say John again and Rambo. And then now to ask us, what's the first number? Let's put the 11 there. What's the second number? 20. And then the average will be 15.5. So now after these two videos, you know now how to get input from the user. And in this case, it's important to convert whatever input you got from the user, to convert it to the correct type so that you can pass it into the first number and the second number, in this case, as a specific integer, or then if you're using doubles, as doubles, or whatever type you're using. That's it for this video. See you in the next one. In this video, we will quickly talk about different comments you can use in Java. So comments are statements that are not executed by the compiler and the interpreter. Comments can be used to provide information or explanation about a variable, a method, a class, or any statement. It can also be used to hide program code for a specific time. So let's just have a look at the different types of comments that you will get in Java. So in the previous example, we had something like first number, and we had second number. And then we said, let's assign values to them. So I'm going to do it here. Let's say 11, and that one should be 12. And then we can work out the average. So we're going to say average equals the first number plus the second number, and I'm going to divide that by 2.0. So now if you want to give some more explanation to the user or somebody that's reading your code, we can say this is the average between the first and the second number. And if you ask the user to enter the numbers, you can maybe say between the first and the second number entered. So a comment is basically not read by the interpreter or by the compiler of the program, of the Java compiler. So this line of coding will be ignored when you run your program, but it is for you or for somebody else reading your code to understand what you did in this specific part. So now this is we call a single line comment. So I can add another single line comment there and type stuff there again and carry on. I can even do it at the end there. So basically after 2 forward slashes, I've got one single line comment. And that single line comment will not be read by the compiler at all. So you can give yourself some indication of what you were working with. So normally what people do is also after declaring some variables, and if the variable is not descriptive of what it does, you can give some sort of description there just after that 2 forward slashes. So the second number, you can say this is the second number entered. So now if it goes to a second line, let's say your comment is too big, then you can also use a multi-line comment. So a multi-line comment will basically be a forward slash with a star, and then you just press enter there, and it ends off with a star and a forward slash, and anything in between will be seen as comments. So hello world, how are you, whatever, you can see there, that's a multi-line comment. So instead of saying this is the second number entered, this is the first number entered, just some text that I'm typing there, instead of having 2 lines with 2 forward slashes like that, you can have them as 1 forward slash and a star, ending it off with a star and a forward slash, and anything in between those two will give you your comment, and your compiler won't read that as code, but it will take it as a comment. Okay, so that's a multi-line comment. This one is just a normal single line comment. Then there's another comment that we can use, and that we normally use with methods. So this is basically the documentation comment. So for a documentation comment, you put a forward slash and 2 stars, and you can just click on the enter. So you'll see what it does then. It creates a star and a forward slash, and anything in between, we can actually remove those 2 stars there, but everything in between them will be seen as a documentation comment. So I'm just going to do that again. If I remove that, just before my method there, I'm going to put a forward slash, 2 stars, and then you can see it picks up, there's a parameter called args, and I can declare what, or I can try and explain what this argument or what that specific variable is. This is just a variable, or whatever your explanation for that specific method. So we'll get to documentation comments again when we do methods and classes and so forth. And then also here we can just explain this is the main method of the class, or whatever you want to explain. So you're just basically giving a bit more information about this method or this main method or whatever type of method you have to explain a bit more. And that's the idea behind comments, to explain what your coding is basically saying. And now the other nice thing about documentation comments is that you can go to your tools menu and you can say generate Java doc. Now your output directory, I'm just going to leave it as the desktop, but make sure you choose one there. And I'm just going to say, just create Java documentation for the comments.java file. And I'm going to say, okay. And it will automatically open up a web page for me. And wherever you said it should save it, it will also be saved there. But it opens up an index.html file. And you can see there's my class called comments. So if I look at my class, the class is called comments. So you can see there comments. I can go into the class, and into that class I will then see all my constructors and my methods and so forth. So you can see I've got a main method, and there's the comment that I added. This is the main method of the class. It's exactly what I said there. This is the main method of the class. Okay, and then if you go down a bit, you can also see there's the whole description of the main class or the main method then. This is the main method of the class, and then there's that args explanation that I gave. This is just a variable. So you can see there where I typed this is just a variable. So it gives a nice overview of your whole class and how your methods fit together. So this basically is what we use comments for and how we can use the comments in Java. So it's basically a single line comment or a multi-line comment, or then this comment that's used for the Java documentation called the documentation comment. Decision structures are used so that your program doesn't have to do the same thing each time it is executed. They basically answer a question on the spot during execution. The decision structures need a question to answer, and this is done through Booleans. Now, as we've seen before, a Boolean is one of several primitive data types, which are essentially raw data. A Boolean represents two values. It's either yes or no, in coding terms, true or false. They can be assigned directly, but are usually constructed from a set of many operators. And these operators include, but are not limited to, relational operators and logical operators. Let's look at the relational operators. We can use the greater than, the less than, the greater than or equal to, the less than or equal to, and not equal to. So we can use these operators now in what we call Boolean expressions. So the following table gives us some expressions as examples. For example, I could ask the question, is x greater than y? Is x equal to y? Is x greater than or equal to y? So these now form the type of questions we could ask in our coding. We will look at them a bit later in the video. Now look at the table for our logical operators. We can use the AND, the OR, as well as the NOT operators to connect two Boolean expressions into one. For the AND operator, both expressions must be true for the whole expression to be true. For example, if I have the following expressions joined by the AND operator, I would ask the question, is 5 less than 4 and is 7 more than 5? Now we know 5 is not less than 4, so the first expression would be false. Even though 7 is in fact more than 5, the answer to the whole question here would be no or false. So if I change it to 5 less than 6 and 7 greater than 5, then both sides of the AND operator are true, which will make the whole question true. Now the OR operator also connects two Boolean expressions, but in this case, one or both of the expressions must be true for the overall expression to be true. Let us ask the same question as before, but now let us use the OR operator. 5 less than 4 or 7 greater than 5. In this case, 5 is not less than 4, and that expression would be false. So the left side of the OR operator is false. Now 7 is more than 5, so the expression on the right side is true. This gives us false or true, which will make the whole question true. The NOT operator reverses the truth of a Boolean expression. If the expression is true, then not true would be false. If the expression is false, then not false would be true. So let us look at some examples in coding. Right, so in IntelliJ, I'm going to declare a few variables here. So I'm going to declare an integer x, and I'm going to assign it the value of 5. I'm going to declare a y, and I'm going to assign it the value of 6. And let's use p there, and let's assign the value of 7. Now, let's also create a Boolean variable, and I'm going to call this one expression. This is the Boolean expression that we want to test, and I'm going to assign it a value. So at this stage, I'm just going to say x equal to y, and just leave it as it is. And then what I want to do is to print out to the screen whatever my expression's answer would be. So now you can see it's a normal variables. It's an x, a y, and a p. It's 5, 6, and 7 assigned to them respectively. And then I have defined an expression variable of type Boolean. It's called expression, and then on the right hand side of the equal sign there, I will place my expression. Now in this case, you can see there's one equal sign there and there's two equal signs there, so just don't get confused with the two equal signs there. So the right hand side is an expression you're testing, you're asking a question, and that's why there's two equal signs. The single equal sign is assigning a value to a variable. So in this case, that equal sign is assigning a value of 5 to the variable x. This equal sign is assigning a value of 6 to the variable y. This one is also assigning whatever the outcome of the question we ask on the right hand side will be assigned to the expression variable. Now remember, Booleans can only accept true or false, which means that when I print out this, it should either be true or false. So we can see there when we print out, it gives me a false. Okay, so what we're testing here, on the right hand side, we're basically just asking a question. We're asking the question, is x equal to y? So in our case, 5 is not equal to 6, and that's why it gives me then the answer of false. So let's change this, and let's say it should be, is x less than y? So is 5 less than 6? Yes, it is. So if we run this now, you will see that it goes to a true value there, because x is less than y. 5 is less than 6. So your expressions will then basically be a question that is asked, and then the answer of that question will be returned. It's either yes or no, or in coding terms, true or false. So let's just try another one there. Let's just say let's ask the question, is x more than p? So in this case, you will see that p is 7, x is 5. So x is not greater than p, which will give us a false value there if printed out. Right, so that is basically just looking at simple expressions. So let's try something else. I'm going to use an x. Let's make it greater than y. And we'll put the AND operator there now. And y is less than p. So let's evaluate this question quickly. Remember that for the AND operator, for the whole question that we ask to be true, both sides, both expressions on both sides of your AND operator must evaluate to true. So let's look at both sides. Is x greater than y? Is x 5 more than 6? No, it's not. So on the left hand side, we will have a false value. On the right hand side, is y less than p? Yes, 6 is less than 7. So this side of the operation will actually be true. But because this side is false, we've got a false true, and we need both to be true for the whole thing to be true. So in this case, our expression will also print out false. And you can see it prints out false. But if I change this to an OR, the OR means either one of the two sides could be true for the whole thing to be true. So if I run this now, because of the right hand side that is true, it will evaluate to true as well. So let's get back to the AND operator there. If I want both sides to be true, I could just say, is x less than y? Is x, which is 5, less than y, 6? Yes, it is. And y is also less than p, because y is 6 and 7 is p. So both sides are now true, which means the whole thing will also evaluate to true. And then let's just have a quick look at the last part there. Or let's just try the OR operator again. So I can go and say, let's say to get the whole thing false, is x equal to y and y equal to p, which means are all the values the same? So let's run this. Is x equal to y? No, they're not. Is y equal to p? Also, no, they're not. Which means both sides of this expression, we have false values now. And for the OR, that will also be false. But remember, the OR, if only one of the two sides are true, then the whole thing will be true. So let's say if x are less than y, which will be true, but y is not equal to p. But if either one of the two sides is true, the whole expression will be true. Now let's quickly look at the NOT operator. So I could have an expression there to say, well, is x less than y? That could be my expression. But then I want to negate that answer, which means I want to change the answer of that thing. If it's true, I want to have the answer as false. And if it's false, I want the answer as true. So the question here is x less than y? Yes, x 5 is less than 6, the y there. X less than y, 5 less than 6, yes, it's true. But now because I put the not operator in front of the true value there, it will go to a false value. So if we run it now, you'll see that it will be false. So the not operator basically changes a true value to false and changes a false value to true. That is it for this video. See you in the next one. In this video, we will look at how to actually ask questions in coding in a structured way by using if statements. So this is just like basically asking a question on something that you did. So I'm going to start off with declaring a number variable. So let's say int number, just call it number. You can see it's of type integer, so it can only store integer numbers. I will also have an input variable there, so I can store my strings. So I'm going to say input equals, let's just use the JOption pane again. I'm going to use JOption pane dot show input dialog. So we're going to ask the user a question, and the question will be in the double quotation marks. So I'm going to say, please enter a number. Now the user will enter a number. And now we want to do something based on whatever the user typed there as the number. So let's just use some simple testing here. So I'm going to use an if statement, and I'm going to explain the if statement now when I'm done typing it. So it will be if the number is equal, let's say 5, then we can do something. So here in the if statement, where's the number? We haven't assigned the number, sorry. So before we go to the if statement, let's just get the number quickly. So remember that the user entered the number, but the number is saved as a string. So we need to convert it. So we're going to say integer dot parse int, and then we want to convert that input. So the input, the text that the user entered, which will be a number value, so it's going to be a 5 or something, but it's saved as text, converting that 5 text to a 5 number, to a number. Then we're going to test there. If that number is equal to 5, then we want to do something. So you'll use the if keyword in Java with opening and closing brackets, and then in between will be your Boolean expression that you're testing for. Just note that there should not be a semicolon there. If the semicolon is there, it will basically do nothing, that if statement. It will never go into that if statement. So make sure that there's no semicolon after your if statement, also not after your brackets there. Okay, so that's an opening and a closing bracket, which basically says, if the number is equal to 5, I'm going to do whatever is done in between these two brackets. So in this case, let's just use a JOption pane dot show a message dialog. First argument null to get it to the middle of the screen, and then the second argument will be the text that you want to display. So we're just going to say something like the number is exactly 5. Then let's do another if statement there to test something else. If the number is then not equal to 5, but let's say if the number is greater than 5, we will print out something else. So I'm going to say JOption pane dot show message dialog, again in the middle of the screen, and then the message, the number is greater than 5. Okay, so again we're testing. If the number entered is greater than 5, we will print out the number is greater than 5. Now let's add another one there. We can also say if the number is greater than 10, then we will print out something else. So I'm going to say JOption pane dot show message dialog, null for the first argument, second argument, the number is greater than 10, for example. Okay, so this is just a few if statements there. Let's just see if it works if we run now. just one thing that I want you to add to your coding. Whenever you're using the J option pane, doesn't matter if it's the message dialog or the input dialog, just type this at the end to say system.exit 0. And that actually helps us to exit our program a bit faster when using the Java X swing components. That's an extra import there. So wherever you're using the java.x or javax.swing.star components, for example, in this case, the J option pane that comes from it, it's always best to add the system.exit there at the bottom, because system.exit exits your program, it force exits your program, but the status is 0, which means that basically no errors occur. You chose to stop the program. So this is system.exit 0. It's a normal exit from the program, but it helps you to get a bit faster exit. Okay, so let's run this application now. So basically, if the number is 5, we're going to print out it is 5. If it's bigger than 5, more than 5, then we're going to say the number is greater than 5. If it's more than 10, the number is greater than 10. So let's just check them quickly. Let's run this. Right, and let's type 5 exactly, and you can see the number is exactly 5. Right, and then you can see the program exits. Now let's test something else. Let's make it bigger than 5. So let's make it a 6. You can see the number is greater than 5. 100% correct. Now let's run it again. And let's make that number 12 now. So now it will say the number is greater than 5 because 12 is greater than 5. But it will also go to this if statement to say the number is also greater than 10. So this is just a normal if statement. And the problem we have now is that if I only wanted one message to pop up to say it's greater than 10 or greater than 5, then this way of doing it won't really work. For example, if I type 17 there, it's going to say the number is greater than 5. I don't really want to say that, but I want to say the number is greater than 10. So there's different ways of using these if statements now in order to get your desired output. So let's change this a bit. I'm going to delete those two. And instead of saying another if there, I'm going to say else if. And then I'm going to say the number is greater than 10. Right, so there's the brackets again. So what is the else if now? So the if there, if the number is 5, let's say that is true. If that is true, it will print out the number is exactly 5. And because there's an else there, not another if, just an else if, it will not go to this else if or whatever we do there. But if the number is not equal to 5, which means this part is false, then it will go, only then it will go to the else if and test something else. So in this case, we're testing, is the number now greater than 10? If it is, we're going to say J option pane, dot show message dialog again, null for the first argument, and we're going to say the number is greater than 10. So you'll see then only if the number is greater than 10 will it print out this. But if the number was exactly 5, it will just print out this J option pane and never go to this one. Now let's add another else if there. So we're going to say else if again, if the number is now greater than 5. And then we're going to say J option pane again, dot show message dialog, and null again for the first argument, second argument. The number is greater than 5. Okay, so what will happen here now? We will basically check first, is the number equal to 5? If it is, it's going to print out the number is exactly 5. If it's not, and only if it's not equal to 5, it will go to this else if and test. If the number is greater than 10, if it is greater than 10, which means that it's not equal to 5, and the number is then greater than 10, it will print out the number is greater than 10. But if that one is false, this one is also false, only then will it go to this else if statement and check, is the number greater than 5, yes or no? If it is, the number is greater than 5. Now the last thing that I want to show you here is to basically add an else statement there. So basically, if this one is false, and this one is false, and this one is false, and all your else ifs and the ifs at the top is false, then and only then will your else part run. So if the number is not equal to 5, it's not bigger than 10 and it's not bigger than 5, it means that it must be less than 5. So I'm just going to print out JOptionPane.show message dialog, and the first argument null, second argument, the number is less than 5. Okay, so then the number is less than 5. Right, so this is basically the if statements now. So the if on its own will check it no matter what the previous values were. But then if you have the if type of structure with an else at the end, then remember, then only if this one is true, it will print out the number is exactly 5. If that one is false, only then will it go to this one. And if this one is true, it will print out this. If this one is also false, only then, which means that this one is false and that one is false, only then it will go to this else if statement, and so forth. And then the last else statement is if all of these tests that you've done at the top, if every one of them is false, it will do the default one, which will print out the number is less than 5. Let's just quickly check this one. Right, so let's make the number exactly 5. So it will say the number is exactly 5. And you can see the program exits without any other messages. Now let's check the first or the second one then. The value of 10, greater than 10. So let's type 12 in there. It will say the number is greater than 10. And you can see it never goes to the bigger than 5 one, because it's already bigger than 10. So because that one was true, it will not run the rest of the else if statements. So let's run it again for greater than 5. So if it's not equal to 5 and it's not greater than 10, then it must be a value between 5 and 10. So let's make it a 7 there. And you can see then the number is greater than 5. But it won't tell us the number is greater than 10. And then if I type anything else, which is not equal to 5, and it's also not bigger than 10, and it's also not bigger than 5, which means it should be something less than 5, a 3 or even a minus number. So let's say minus 120 and say OK. And you can see the number is less than 5. Now for the next part, let's do something a bit more interesting. So what I want to do now is to just comment out this part. So I'm going to put a / star, so it's a multi-line comment, and I'm going to put it there, end off with a star and a /, which means that this whole part that we now did with the if statements will be commented out. The compiler cannot read it. But we're going to still have the number variable. We're still going to get the input from the user. Please enter. And now we're going to say, please enter your mark. And then we save the mark. Now we're just assuming it's going to be integer numbers there. Let's leave it as integers. Please enter your mark. The mark is saved and the mark is then converted to an integer. And now we want to do something else. Let's look at a few if statements again. So I'm going to firstly check if that number is less than 50, then we know that this guy failed. So we want to print out a message and say JOptionPane.show message dialog. And we're going to tell the user, you failed. Right, so the user failed then if the number is less than 50. But now we want to have an else part there, and not an else if there. I'm just going to keep a normal else. So what will the else be? If the number is less than 50, this is this if statement then. So what would be the else? It's when the number is equal to 50 or greater than 50, which means that this guy actually passed. But now I want to check also, I don't only want to check if he passed, but I want to check if he's got a distinction. So this is where nested ifs come in. So you can see in the else, I'm using another if again. So I'm going to check there, if then, because I know if we get into this else, I'd put a comment there, the user passed. So now we want to check how did the user pass. So now I'm using a nested if to check. If that number then is greater than or equal an 80%, which is normally a pass, or let's take it as 75 then, or is normally a distinction. So if the number is greater than or equal 75, then we know he's got a distinction. So we're going to say JOptionPane.show message dialog, null for the first argument, second argument, your message. Let's say you have a distinction. Right, so if the number is greater than or equal 75, we will say you have a distinction. And then the else part here will be then if the number is not greater than or equal 75. But because we are in this else, we already know it's more than 50, or at least 50. So this else then, we can print out show message dialog. What do you think we should print out there? Yes, you're correct. We must print out you passed. Right, so now if he passed, that's the else. We first check if he's got a distinction. We say yes, it's a distinction. But if it's not a distinction, we can just say you passed. Let's just run this one and check if it works. Right, enter your mark. Let's make 50 there. So it will just say you passed, 100% correct. Now let's carry on. Let's try a number that's 75 or higher. So let's make it 95. It will say you have a distinction. And let's try something else again. Let's say less than 50. So 45. And it will say that you failed. So let's try another if statement, or another nested if statement here. So let's say we want this guy to go and write a reassessment in an exam or whatever. So we're going to say there, if then this number, we know now the number is less than 50. But what if this number is less than 50, but it's more than or equal 45, which means that this guy's actually got between 45 and 50, 45 included. So then we'll print out jOptionPane.showMessageDialog. And we're going to have null there, and then we're going to say you can write reassessment. Right, and then what will be the else part there? The else part will just be if the number is less than 50, we know already he failed. But if the number is more than 45, you can write reassessment. The else will be, if it's not more than 45, it's less than 45, so this guy actually failed miserably, so we will just say, you failed. Okay, so let me just remove these extra space there. Okay, so this is basically our whole structure now. If I make this one a bit smaller there, you can see there that we start off, if the number is less than 50, then it means failed. But how did the guy fail? So we say, if the number then is greater than or equal 45, you can write the reassessment, because then it's 45, between 45 and 50, but not 50. 45 included because of that equal sign there. Then the else will be, if it's not bigger than or equal 45, which means it must be less than 45, and then he failed. The else part here is for this if. So if he didn't fail, then we go to this else and we test. If it's more than or equal 75, it's a distinction. What is the else? The guy passed, he didn't fail, but he didn't get a distinction, so we just say, you passed. Right, then for the last part of this video, let's see how we can add some logical operators in here as well. So instead now of saying if the number is less than 50, and then having a nested if statement to check the number less than or greater than or equal 45, we can do the following. We can say if the number is less than 5, and at the same time that number is also greater than or equal 45. So then I can remove this part. Let me just remove that. And we have the J-option pane. You can write reassessment. I'm going to remove this else also. Let's just look at this if statement quickly. So we're saying if the number is less than 50, we know the guy failed. And the number is also greater than or equal 45. So what does the AND do? The AND basically says both sides of this operator must be true for the whole thing to be true. So we're testing now. If the number is less than 50, so let's take a number. Let's take a number of 46. So if 46 is less than 50, yes it is. And the number, which is 46, is also greater than or equal 45. So you can see both sides will be true. Then we print out, you can write reassessment. So then we can put an else if here again. Let's just put some brackets there. Else if the number is greater than 50, Sorry, that's when the number is less than 50. So let's just leave it as this. That will be the second else if. So we'll basically check first. If the number is less than 50 and the number is greater than or equal 45, then we know it's between 45 and 50. We print out, we can write reassessment. But then if that thing is false, which means either one of the two sides is false, we're going to test again. If the number is then just less than 50, or we can even say if it's less than 45, then we know he failed. So I'm just going to copy this one quickly. And I'm going to paste it there, and we're going to say you failed. Exactly the same thing. Else, if number is greater than or equal 75, you have a distinction. Otherwise, you just passed. Okay, so this is basically just using the AND operator there. We could also use OR operators and so forth. We'll get a bit more into the logical operators later on when we're checking if something is inside or outside a range. But at this stage, this is just checking whether you can do the normal if statements, else if statements, and some nested if statements. Okay, so let's run this application quickly and just see whether it actually works correctly. Right, so let's enter the mark. Let's enter a 50 there. You passed. Right, 100%. Let's try again. A value between 45 and 50. Let's say 46. You can write reassessment. 100%. Let's just run it again. Now let's put in a fail value there. So let's say a 44. You failed. 100%. And then the last one, let's try for a distinction there. So let's make it 98. You have a distinction. Our program is running 100%. That's the net for this video. See you in the next one. In this video, we will look at how to determine whether a number is inside a range or outside a range of values. When determining whether a number is inside a range, we use the AND operator. Now look at the following example. To check whether a number is inside the range of 30 to 60, and that's now 30 and 60 included also, let us first examine the values to understand the logic behind it. Inside the range means between 30 and 60. So it would be 30, 31, 32, up until 58, 59, 60. So you will agree that it is all values greater than 30, but also less than 60. So how will we then use an if statement to check for this? Now evaluate the following statement. So the question here is, if the value is greater than or equal to 30, and at the same time the value is also less than or equal to 60. Both sides of the AND operator must be true. So let us take the value of 40 as an example. Is 40 greater than or equal to 30? Yes, it is. It's greater than 30. Is 40 at the same time also less than or equal to 60? Yes, so the AND operator works for us in this case. Let us now take the value of 20. Now 20 is in fact outside of the range, and we want our if statement to actually evaluate to false. So is 20 greater than or equal to 30? No. Is 20 less than or equal to 60? Yes, but because both sides must be true for the AND operator, this expression would result in a false value. Exactly what we want. Now what about the OR operator? Can we use the OR operator as well, or can we just use the AND? So let's evaluate the OR operator quickly. Remember that for the OR operator, only one side of the operator must be true for the whole expression to be true. So here we ask, is x greater than or equal to 30? Or is x less than or equal to 60? So a value of 100 would make the left side true, and the value of 10 would make the right side true. Can you see that we cannot use the OR to check for values inside a range? Now, how do we check for values outside a specific range? Let us take 30 and 60 again. Outside the range of 30 to 60 would mean less than 30 or greater than 60. Now let us evaluate using the AND operator again. This would read, if x are less than 30 and at the same time greater than 60. So do you think this is possible for a value to be both less than 30 and greater than 60 at the very same time? Remember, both sides of the AND must be true for the whole expression to be true. So let us take the value of 20. 20 is outside the range of 30 to 60. Can 20 be less than 30? Yes. Can 20 also be more than 60 at the same time? Definitely not. So it's clear that we cannot use the AND operator now again to check for values outside of a range. We can use it to check values for inside a specific range. So we must use the OR operator. Now evaluate the following statement. The question in this case is x less than 30 or is x greater than 60? Only one of the two needs to be true for the OR operator to evaluate to true. So let us take the value of 20 again. 20 is less than 30, so the left side would be true. Is 20 greater than 60? No, so the right side would be false. This expression would then return true. Let's take the value of 40, which would be inside the range and not outside of the range. Is 40 less than 30? Definitely no. Is 40 greater than 60? Also no. Both sides evaluate to false, which would make the whole expression false. That's it for this video. See you in the next one. In this video, we will discuss comparing string objects or text in Java. Before we start to compare strings, we need to have some basic understanding of what a string is in Java. It's not the same as the other primitive data types. A string is created from the string class. Now, for every piece of string or text that we create, we are creating an object of the string class. We will look at classes and objects in more depth later on. For now, consider the following example. String name1 equals Peter. String name2 equals Peter as well. You can see the spelling for the two is exactly the same. So what happens in memory when we create these two strings or these two objects of text? Firstly, the string object with the text Peter will be created in memory. Then the name1 variable will be created and can store only the memory location of an object of type string or text. In this case, it will store the memory location of the text Peter, not the text itself. This is where the catch comes in comparing strings. Let us look at another example. Firstly, the string object with the text Peter will be created in memory. Then the name2 variable will be created and can store only the memory location of an object of type string or text. In this case, it will store the memory location of the text Peter. Again, not the text itself. In most cases, you cannot use relational operators to compare string objects. These string variables contain the address of the object they represent and not the object itself. If I have the following if statement, if name1 equals name2, but note the double equal sign there, I'm essentially testing whether the memory locations of the two objects or the two text parts are the same. I'm not testing the values itself. Thus, I'm not testing whether Peter and Peter are the same. This if statement will then evaluate to false. So how then do we compare strings? Because strings are objects, we have some useful methods that we can use to compare strings. The first method is the equals method. Now look at the following example. If name1 dot equals name2 in brackets. Here we use the equals method on the string called name1, and we compare name1 with name2. In this case, the equals method compares every single character of the text in name1 with the text in name2. If every single character is the same, the equals method will return true. In this case, the if statement will return true. So this is one way of comparing strings. The other way of comparing strings is to use the compare_to method. This method returns an integer value that can be used as follows. If the value is 0, name1 will be equal to name2. If the value is a negative value smaller than 0, then name1 will be first in the alphabet and name2 will be second in the alphabet. Or in short, name1 will be smaller than name2. If the value is positive, more than 0, name2 will be the first in the alphabet and name2 will be second. Or, in short, name1 will be more than name2. So let's see this working in coding. Right, back in IntelliJ, we're going to create two variables. I'm going to call one of the variables name1, and will be of type string because we are looking into comparing string values. So what I'm going to do here is to ask the user to enter the value for me. So I'm going to say JOptionPane.show an input dialog for me, and we're going to say please enter name1, and then let the user enter name1. Then the same for name2. We're going to ask the user JOptionPane .show input dialog, and we're going to ask the user please enter name2. Right, so now we have name1 and name2, and let's see how we can compare these two strings now. So I'm going to say if name1 is the same as name2 with a double equal sign. Now remember from the explanations now that we should not compare strings like this, but let me just show you the output here. So we will have name1 is equal to name2 if they are the same. And then we'll have an else part there that will basically say, well, the two are not the same. So we just say not the same. And let's see how this one runs. Okay, let me just check the output at the bottom after this. So we're going to say please enter name1, and I'm going to type Peter there. So look at the spelling of Peter there, capital P, all the rest lowercase, it's Peter, and I'm going to type Peter again. So it's exactly the same name that I'm typing. And if I say OK there and I open up here at the bottom, you will see it says it's not the same, because essentially we're comparing now two different memory locations for the first name and the second name that was entered. So it actually doesn't matter which names I type there. Let me just try it. Peter and Paul, which is in any case not the same, but it will say it's not the same. It's not testing the text itself, it's testing the memory location. So how should we compare then two strings? So we need to use the equals method, and the equals method accepts one of or some type of string object there. So we're saying if name1 equals name2, then print out it's equal, otherwise they're not the same. So let's see if we print out this one now. So the name there, let's type Peter again, and the same name Peter again, and if we compare them now, you can see that it says name1 is equal to name2, and you can see how long it takes for my output to actually stop and to give me the end of my application there. So remember, when using JOptionPane, just use system.exit, pass in the 0 there to exit a bit faster there. So if I now type let's say another name there, Peter and Paul, it will say it's not the same. But if they are the same, Peter and Peter, it will give me name1 is equal to name2. Okay, so that's basically how we test for, or how we compare strings, by using either the equals method or the compare to method. So now the compare to method, quickly, instead of using equals there, I can say compare to. So name1 compared to name2 equals 0. That's the one that gives us an integer value. So I'm testing if name1 compared to name2 is equal to 0. It means that they are the same, they're equal. So this statement is essentially the same as using the equals method. So if I run this again, this will check whether they are the same. So let's say Peter again, and Peter, and it will also print out the names are the same. Now, instead of using an else here, let us use some other if statement. So I'm going to say if name1 dot compare to name2 again, but in this case not equals 0, but say less than 0. So what I'm essentially testing here is testing whether name1 is first in the alphabet and then name2. So if it is like this, we will say name1 is first and name2 is second. And then we can have another if statement there that tests for the other way around. So we're going to say if name1 dot compare to name2, if we compare the two, and the value is greater than 0, then it means name2 is first in the alphabet and then name1. So then we will print out name2 is first and name1 is second. Okay, so let's just quickly test this one out. So if we run it now, all right, so let's take Peter and Peter again. That will be the first if statement. So it will say name1 is equal to name2. Right, let's run it again. Let's try the second if statement. Let's just use Adam and Eve there. So Adam obviously comes first in the alphabet and then Eve. So it will say name1, which was Adam, is first and Eve is second. Name2 is second. So let's try the last one there. So let's make this one now Eve and Adam, and obviously Adam must come first, which is name2. So it will say name2 is first and name1 is second. And that is how we compare strings in Java. So it's either the equals method, or you can use the compare to method with the 3 different values. If you want to check if something is the same, the equals method is the easiest one to use, but you can also use the compare to method. But if you want to check or sort data, for instance, where you want to get a specific value before another one, then you can use the less than or the greater than with the compare to method. Now, just one comment before we stop this video. If I take away these now and I replace them with, let's say, Peter there, and there also Peter. Let's run this quickly now. So if I run this now, you will see it says that name1 is equal to name2. Okay, so which is 100% correct. But what if I now use just the double equal sign and say name2 there? Let me just delete these now so we don't use them at all. All right, we remove them. So we only have this if statement. You can see there's string name1 equals Peter, string name2 is Peter. Both of them are exactly the same. Using the double equal sign should actually not print out anything. So let's put the else there again. And we're going to say system out print 9 not the same. And maybe we can just say the same. Now let's run this quickly. And you can see that it says the same. Whereas we just said these two should not actually work with the double equal sign. Because if I take away this Peter now and I use the J option pane again, let's try that again, it will say that they are not the same, even if we type in the two names. So let's type that again. I'm going to say Peter again, and again Peter, exactly the same spelling, but it will tell me they are not the same. And that's the thing, or the problem we have here now. Okay, so if I do not use the J option pane or input from the user, but I use a string literal like this, by just hard coding the text. Just do the same for Peter there. Okay, just comment out the rest. Right, so now we've got two string literals, hard-coded strings there. If I run them now, you can see that it will say they are exactly the same. So that is the strange thing that happens here, that if you get input from the user, you can't check for strings using the double equal sign. But if it's hard-coded text, it will work. So why is that? So strings constructed with string literals like we're doing now with Peter and Peter, they are part of the string constant pool, and the same string literal will always be the same memory address from the pool, which means that if you're using string literals and they've got the exact same spelling, they are also at the exact same location. And that's why it works. So just remember this one. We do not use hard-coded strings that much at all. So normally just use the normal equals method or the compare to method to compare two strings, because normally we get input from the user and then save it into a variable. And when you do it that way, the double equal sign will not work. So please use the equal sign, the equals method or the compare to method in order to compare strings. That's it for this video. In this video, we will use another way of making decisions in your program. The switch statement allows you to use an ordinal value to determine how a program will branch, and the switch statement can evaluate an integer type or a character type variable and make decisions based on that value. In IntelliJ, we've got the following coding. So just quickly evaluate this coding. We've started off with declaring a variable called number. It is of type integer. Then we get an input from the user. Please enter 1, 2, or 3. And then the user type 1, 2, or 3. As text, it will be saved into input because it's declared as a string. Then we convert that text to a number, which is an integer, and save it back to the number variable. And then we can test that variable. We can check. If the number is 1, we print out you entered 1. Else, if the number is 2, we print out you entered 2. If the number is 3, it's going to say you entered 3. If you didn't type 1, 2, or 3, it will go to the else and it will print out you did not enter 1, 2, or 3. And because we are using JOptionPane, we just add this one line of coding, system.exit, to make sure that our program exits a bit faster. So let's just run this one quickly. So I'm going to enter a 1 there, and then it will just tell me you entered 1. If I run it again, and I enter a 2 there, it will say you entered 2. If I say a 3 there, it will say that you entered 3. But if I do not type a 1, a 2, or a 3, let's just type something else there, like a 6, for example, it will tell me you did not enter 1, 2, or 3. So let's replace this whole part there with something else now, which we call the switch statement. So the switch statement, basically you start off with the word switch there, the keyword in Java called switch, and then you pass in either a number variable, so like for example an integer, that could be a byte or a short or a long or a normal int like we've got here, and then you can also pass in characters to test. So we'll look at another example where we place in some characters there. So now if I want to do the exact same thing as the if statements there, I could say, let me use the keyword case there, and I'm going to say case 1, which means that if the user enters a 1, or if the number is a 1, it will go to whatever I do here directly after that colon. So in this case, we're just going to use a JOptionPane again and show a message dialog. First argument, the null. Second argument, what is your text that you want to display? So we want to do the same as the example that we just basically executed. So that would be you entered 1. Right, and that is case 1. And then after a case, we will need to use the break statement. If you don't add a break statement, it will just carry on to the next case. So now I'm going to say case 2. That's basically the same as saying if it's a 2, what are we going to do then? Then again, we're going to use the JOptionPane dot show message dialog, and we're going to say you entered 2, and then we place the break statement again. Right, so after that one, we will have case 3. That's the same as asking if it is a 3 that was entered there in the number variable. Then we're going to show the message dialog again, null, and we're going to say you entered 3. And then we break again. Right, so now we've got case 1, 2, and 3. If it's a 1, we're going to print out you entered 1. If it's a 2, we're going to print out you entered 2, and if it's a 3, we're going to print out you entered 3. So now the default one, that is basically the else, the last else at the bottom will be default. So if it's not a 1, a 2, or a 3, it will go to the default one, and we will print out show message dialog, and we're going to say you did not enter. Let me just go to a new line for this one. You did not enter a 1, 2, or a 3. And then that is basically our switch statement. So the switch statement starts off with the keyword switch. You pass in either an integer data type, which is short, long, byte, or integer, or you can pass in a character variable there. So it basically uses an ordinal value, which is a number value, so it's either characters or it is integers. Then you test for your specific case. In this case, we're testing for a 1, and then after the 1, the colon. Everything between the colon and your break statement there basically will be executed for case 1. Now, if we do not add a break statement there, so if I leave out the break statement, it will basically go, let's say you entered a 1, it will go to the 1 there and says, okay, it should print out you entered 1. But then if it doesn't break, it will automatically execute case 2 as well. So it will continue executing the cases until it gets the break statement. So that's why it's important for you to add a break statement. We'll see an example now when working with characters where we can actually leave out the break statement and it still works. So now let's quickly run this switch statement. So that's where we ask, please enter 1, 2, or 3. So I'm going to enter 1 there, and you can see it says you entered 1. The same as the if statements that we just had. And then for the second one, case 2, we can enter a 2 there, and it will print out you entered 2. For case 3, we will use 3 there, and you can see you entered 3. Now let's try the last one for the default option there, where we do not enter a 1, a 2, or a 3. So we're going to pass in a 6 there, and it says you did not enter a 1, a 2, or a 3. So the default there will be like the else in the if statements, and these are the conditions that you test for. So we're testing for a 1, a 2, or a 3. If it's not a 1, a 2, or a 3, we will go to the default one and just print out. So you can also do a break statement at the end of the default, but because default is the last option that you've got in your switch, it will actually exit the switch after that. So you don't need to put a break statement after your default statement. So let's try another example now here, where we're working a bit with characters. So I'm going to declare a character called letter. And then we're going to ask the user, so I'm going to use that same input that we declared at the top. So we declared string input there at the top to get whatever the user types. So we're going to say, or replace that input now by asking the user dot show input dialog. And we're going to ask the user, please enter A, B, or C. So we ask the user to enter a letter of the alphabet to make a specific choice. Now, if we want to convert now, because if we ask the user, please enter A, B, or C, and that gets saved now as a string, that's not a character. So again, we can't just say letter equals whatever the user typed. We need to convert that letter now, or that input from the user now, to a letter. So how do we convert that? Basically, we don't convert, but we take a specific character inside of the string that the user typed. So obviously, if the user is going to type just an A, a B, or a C, it will be the very first character from the whole string called input that we want to get there. So we're going to basically say input dot, and there's a character at method, char at method, that accepts an index value in your string to extract. So we're going to say character at 0 there, which means that, let's take an example. Let's say the user typed Peter. In this case, he won't type Peter. He will type an A, a B, or a C, or maybe something else. But if he types Peter and I'm saying input dot character at 0, it means it's the very first character. If I say, well, in this case, it will extract the P then. If I say character at 1, it's going to go from 0 to 1, which will extract the E. So the way that your strings are basically constructed are from characters counting from 0 up until wherever your characters go. So it's going to go 0, 1, 2, 3, and 4. So if I say 4 there, it will extract 0, 1, 2, 3, 4. It will extract the R there. So in this case, we do not have a whole word that the user entered there, but he types just an A, a B, or a C. So it will be the very first character, or character at position 0. Right, so we've got the letter then that the user typed. That will be saved now, coming from input, whatever the user typed, at the position 0. And now we've got the letter. Let's go into the switch statement quickly. We can pass in the letter. And now we can start with the first case. So the first case will be a character A. If I test for the character A, then I'm going to say JOptionPane dot show message dialog. And in this case, first null. and then the second argument, you entered A. And then we're going to break. Okay, so the first case there, I'm testing for a character. So remember, it's not the double quotation mark, it's the single quotation mark. Then if you go to case B there, let's use the J option pane again there. We're going to say show a message dialog there, null again for the first argument, and the second argument, you entered or let's say just B. You entered B, and then we break again, and then for the last case there, we will say case C, and then for case C, it's also going to be J option pane, show message dialog, null for the first argument, and the second argument will be you entered C. Right, and then we can add the default there. So just before the default, let's add a break statement there, and then have the default. And for the default, we will just print out null for the first argument. Second argument will be you did not. Let me just take that also to a new line. You did not enter let's say correct value. Okay, so this is the case then. We accept the letter of the alphabet. We test it for the A, the B, or the C, and then we print out you entered A, you entered B, or you entered C. And then we will print out you did not enter a correct value. So I'm going to run this quickly now. I'm not going to test every single value there. So remember, the first one will still run. So I'm going to say a 1, and then it says you entered 1. And now it asks me for enter a B or C. So let me enter a B there, and it will print out you entered B. Okay, so let's try something else there. If we don't enter a B or a C, let's enter, okay, just a 1 there again. Let's enter a D there, for example. You did not enter a correct value. So it seems as if the switch statement is working correctly. But what if the user enter, let's just use a 1 again there. Let's say the user enters the capital letter A or the uppercase letter A, and I'm saying, okay, there it says you did not enter a correct value. So this is where it comes in, where we can actually use the break statement to help us a bit to get the correct value that we want. So in this case, I'm going to say case, and then I'm going to add an uppercase A there as well. But you can see after that case, I do not use a break statement. I just leave it as it is, which means that if it's an uppercase A, it will go into it. There's no break statement. So it will go into the lowercase a, then print out you entered an A, and then break. So this is a way where we can use or check for uppercase or a lowercase. So I'm going to use the uppercase B there as well. And for C, I'm going to use the uppercase C as well. So now whether it's an uppercase A or a lowercase a, it will print out you entered A. If it's a lowercase or an uppercase B, it will print out you entered B and then break. And if it's a lowercase or an uppercase C, it will print out you entered C and then break. So let's just test it out quickly. So I'm just going to enter a 1 there again. Now let's try a capital letter A or an uppercase A, and it will still say you entered A, which is fine. So this is how we can use then the switch statement with all its different cases and break statements. And remember, wherever you put the break statement, it will go out of that option and it will basically exit your switch. So sometimes it makes sense to have your case without a break, and sometimes it must be there. For example, if we just take out this break statement there, what will happen if I enter the 1? Because there's no break there, it will print out you entered 1 and go directly to case 2 and also say you entered 2 before it breaks. So let's just test this one out quickly. So if I enter a 1 now without the break, it will print out you entered 1 and directly after that you entered 2. And then it gives me the choice for the A, B or C. So remember, most of the cases we will use the break statement. For some specific cases like this one, you can leave out your break statement and it will still work exactly like you want. That is it for this video. See you in the next one. In this video, we will have a look at the 3 different loop structures that we can use in Java. Now, what is a loop? A loop is a sequence of instructions that is continually repeated until a certain condition is reached or met. Now, we get 3 loops in Java. We get the while loop, we get the do while loop, and we get the for loop that we can use. So let us do a slight example here. So the first thing that you need to know is that for every loop that you use, you need a loop control variable. So I'm going to call this X will be my loop control variable. The next part, you need to actually use your loop. So the second part will be to type the keyword while. If you were busy with the while loop, in this case we are busy now with the while loop, we'll look at the do while and the for loop as well. So we start off with the loop control variable. So that's the very first step. You need to declare the loop control variable and initialize it, give it a value. In this case, we're setting it to 0. Then in the while loop, we need to have some condition that we can test for. So in this case, we're going to test for while x is less than 5. We will keep on doing something in the loop. And now you can see for the while loop, there's no semicolon at the end. So whatever we want to loop then now must be in these 2 brackets. So we're going to have a simple system out print line there that just says hello world. So up until this stage, we've got the loop control variable declared and initialized, in this case to 0. Then we test the loop control variable using a specific value. And then the last step will be we need to change the loop control variable. So in this case, I want to say something like x equals x plus 1, which means I'm going to replace whatever x's value are at this stage, which is 0, and I'm going to add 1 to it. So it's basically the 0 there plus the 1, which will replace it with a 1. And then the loop will execute again, and we try and test. Is x still less than 5? Yes or no? So you can see by every time adding 1 to the loop control variable, we will get at a point where x is not less than 5 anymore. And then the while loop will stop executing. So let's just go through this again. There's a loop control variable. It must be declared and initialized. So that's step number 1. Loop control variable initialized. Step number 2, in your while loop, you must test using that loop control variable. In this case, we're testing. We're going to run this loop while the x value is still less than 5. At this stage, it's 0, so you can see it will go into the loop because 0 is less than 5. So it will print out hello world every time it runs. And inside of the loop, when we're done, we will make sure that we change that variable so that x becomes then 1. Is 1 still less than 5? Yes, print out hello world. Then we increment it again. Is it now 2? So is 2 less than 5? Then 3 less than 5, 4 less than 5. And when we get to 5 there, is 5 less than 5? No. And then it will exit the loop. So let's just run this quickly and see how many times it will actually run this loop. So you can see there's the loop now. It basically went for x equals 0. There's the first one. Then we incremented x equals 1. Then x equals 2, then x equals 3, and then x equals 4, because 4 will be the last value that is still less than 5. So your loop executed exactly 5 times. Okay, now another way of saying x equals x plus 1 would be just to go and say, I'm just going to do it at the bottom, x plus equals 1. So that's the same as saying x equals x plus 1. So if I say x equals x plus 2, I can make that a 2 as well. So x plus equals 2. But if you're going to keep at only incrementing, adding 1 to the variable, the shorthand code for that will just be x plus plus. So x plus plus will be adding 1 to your variable. So I'm going to keep it at x plus plus, which means that I'm going to just take x there and I'm going to add 1 to x the whole time. Okay, so if we run it again, you'll see it's only still those 5 times it prints out hello world. Right, so now that's the while loop, and that's how the while loop works. But if I remove one of the steps there, for example, this step there where we increment it, you can see there it says it will always be true, which means that this loop will never end. So if I run it now, we get to something that we call an infinite loop. You can see there my program is still running. You can see it going berserk there at the side. It's keeping on printing out hello world, and it will never ever stop because I didn't tell it when to stop. I said, well, stop when x is less than 5, but x stays 0. We're not changing it at all. So it will have an infinite loop. So I can stop it there using the stop button on the left-hand side, but there's no other way for me to stop that. Okay, so let me just use an x++ there, which means that we're going to keep on adding 1 to that 0 until it's not less than 5 anymore, and then it will stop the loop. Okay, so that's basically how the while loop, the basics for the while loop. So let's try and do the same thing for the do while loop. So just before all of these, I'm just going to print out a system out print line, which will just add a new line between the two loops. Okay, so now let's try the exact same thing, but now we're going to use a do while loop. So I'm going to say int, let's use the y variable now, integer y equals 0. So again, we will, step number 1 will be to initialize, or first declare and then initialize the loop control variable. So there's the loop control variable again. And then the next step will be to actually use your loop. So in this case, the do while loop looks like this. Now you can see that here we did not have a semicolon at the end of while, but when you're using a do while, there's your brackets, and it's the same brackets that we would use there in the while loop. Let me just get to, okay, let me just leave it as that. So there's the do while loop. There's your opening bracket and your closing bracket, which will be the same as your opening and closing bracket there. Okay, so we're going to have do. What do you want to do? First thing that we want to do is we want to print out hello world. I'm going to use the same example again. So we print out hello world. And then we must test for something. So in this case, when we're testing, we're going to test the same as what we did there with the while loop. I'm going to say while the x, no, not x in this case, the y, while the y is still less than 5, we will keep on doing something. But now we must also remember to do step number 3 there, which will be your loop control variable needs to be adjusted. Okay, so how does the do while loop work? First, there's a loop control variable. We initialize it to 0. Then we get into it and we print out hello world. We increment or we change the y variable, and then we test for the y. Okay, so it's a bit different than you did in the while loop. So the while loop, we call the while loop a pre-test. Let's call it pre-test loop, which means that we first test before we execute anything, which means that a while loop can execute 0 or more times. Because if we make x 5 there, it will never execute because x is not less than 5. Or 5 is not less than 5 in that case. So we test right at the beginning, so we call this a pre-test loop. Now for the while loop, we call this a post-test loop, which means that we will first do something and then test. So you can see that we start with y as 0, then we print out hello world. So how many times will the do while loop run? At least once. So it will be 1 or more times. So we're going to first print out hello world, then increment, make the 0 a 1, and then test. Is y, which will then be 1, is it less than 5? Yes, it is. So we print out hello world again, increment it again, y becomes 2. Is 2 still less than 5? Yes, and so it carries on until the y value there is incremented up to the value of 5, where 5 is not less than 5 anymore, and the loop will stop executing. Okay, so let's run this program again. So you'll see that this while loop will now print out 5 times hello world, and this one should also now print out 5 times hello world. So there you can see there's the first loop, hello world for 5 times, and then 5 times again. So it's basically doing the same thing for both loops here. So you'll use a while loop when you do not want the statements to be executed if a condition is false right at the beginning, that we call a pre-test loop. But for the do while loop, you'll use this when you want statements to execute at least one time. Now let's look at the basics for the for loop. So the for loop has got the following form. Basically looks just like that. That's the most basic form for a for loop. And you'll see there that it's got 3 parts. And it's the same as the 3 parts that we had with the while loop. We've got a loop control variable, that's the first part. We need to test it, and then we need to increment it or decrement it, basically change it. So there's the loop control variable where you initialize it, you test it, and then you change it. And that's the exact same thing for the 3 parts for the for loop there. If I leave the for loop like it is now, I'm going to print out hello world again. This is the most basic form of a for loop, is just this form that we've got there. So if I run this now, you can see that it will still print out the first, well, I can't see it because that for loop now is in an infinite loop again. But those 2 for loops would have, the 2 loops at the top would have still printed out 5 hello worlds, and the other one also 5 hello worlds. And then we will get into this part where it's an infinite loop again. So this is the most basic form for a for loop, is like this, where you just have the 2 semicolons. But it needs the 3 parts. So the first part will be where we declare our loop control variable. So I'm going to use an I there, and I'm going to start at 0. So that's the first part. You can see it's the same as the while loop. We first declare and initialize your loop control variable. So that's the first part. The second part is testing it, like we did in the while loop, x less than 5. So let's just make it I less than 5 here because we're working with the variable I. And then the last part of your for loop will be what we said here in the while loop also. We need to change the loop control variable. So in this case, I'm going to use I++. And then we've got exactly the same thing as we did with that while loop. So if I run this now, well, before we run it, let's just add another system out print line there. So we've got 5 hello worlds, 5 hello worlds, and another 5 hello worlds, hopefully. So let's just run it quickly. So you'll see there we've got 5 hello worlds, 5 hello worlds, and 5 hello worlds. So this is the 3 loops then that you get in Java. So again, the while loop is a pre-test loop, the do while loop is a post-test loop, and your for loop is also a pre-test loop, just like your while loop. And now you can also see that there's no semicolon at the end of the for loop. It's only in the do while where we have a semicolon at the end. So please make sure about that. So that's the 3 different loops that we've got. So just as a summary, when do we use the while loop? Use the while loop when you do not want the statements to be executed if a condition is false right at the beginning. When do you use the do loop or the do while loop? You use that when you want statements to execute at least once, because it executes first and then it tests. It's a post-test loop. So when will we use the for loop? Because the for loop and the while loop is basically the same thing. Both of them are pre-test loops. So when do we use the for loop then? You use this where there's some type of counting variable that can be evaluated. So most of the times, if you know exactly how many times you want to execute your loop, then you can use the for loop. If you don't really know how many times you're going to execute your loop, then the while or the do while loop will be a better one to use. Just one last thing that you need to note here with the for loop. Please do not add an I++ there at the end. This just means that we are incrementing 2 times. So the for loop starts with initializing the control variable, then testing it, then doing whatever is inside of the brackets, and then increment or changing the variable. So by adding another I++ there, we're basically saying increment it 2 times. So remember to not put your increment or your change inside of the brackets. Your change should be the last part of your for loop statement. In this video, we're going to have a look at a few useful loop calculations. So you will see that I created a new project. I created a package called com.example.calculations, and then I created 4 different Java files. So how do you create a Java file again? I just right click and say new, and then you go to Java class. So right click new Java class, and then you create your new class. So I created the class for input validation, running totals, sentinel values, and user control loops. So we're going to go through every one of them. First one, input validation, and then some running totals or user controlled loop, then running totals, and then sentinel values. So for all of them, I just created the public static void main method there. You can see all of them has just got the main method, and we will start coding from there. So the first example that we're going to have a look at is input validation. So we're validating the input that the user will give us. So in this case, we're just going to ask the user for a specific question. So I'm going to have a string to get whatever the user types. So I'm going to say string input equals JOptionPane dot show input dialog, and we're going to ask the user, please enter a number. And I'm going to go to a new line here. Yours can fit into one line, that's fine. Please enter a number in the range of 1 through 100. Let's say that's the question that we ask. The user must enter a number in the range of 1 to 100. And then whatever the user typed, we're going to save that into the input variable. But now we want to have that number. So I'm going to say integer number equals. So we need to convert whatever the user typed now to an integer. So I'm going to say integer dot parseInt, and we're going to pass in that input, which means it's going to convert the input that the user typed to an integer and save it into the variable called number. So now we want to validate this input that the user has given us, because we're asking enter a number in the range of 1 to 100. This could be a date of birth or whatever you want to check so that the months don't go over 12 or whatever. So in this case, it must not go less than 1, also not higher than 100. So we can use a simple while loop to check this now. So I'm going to say while the number variable is less than 1, or remember, if we're checking for outside a range, we use the OR operator. So we're checking whether while the number is less than 1 or the number is greater than 100. So let's say the guy enters 2000 there. Then the number is not less than 1, but the number is more than 100. And remember, for the OR operator to be true, either one of the two sides needs to be true. So I'm testing now whether this number that the user entered is less than 1 outside of the range or more than 100 also outside of the range. So if it is, then we need to do something. So I'm going to print out, just using a normal JOptionPane.show message dialog. Let's say null there for the first argument, and we'll say something like that number is, just go to a new line again, that number is not valid. And then directly after that, we're going to have the user enter that same thing again. So we're going to ask the user, again, please enter a number from 1 to 100. We're not going to declare the variable again, but just use it. And then we're also going to use that same variable there again to get that input as an integer. So what happens here? We're basically saying, if that number is less than 1 or more than 100, we print out the number is not valid. And then we ask the user, please enter a number in the range of 1 through 100. He enters it, we convert it again to a number, and then the loop runs again. It tests again. Is that number less than 1 or greater than 100? If it's again outside of the range, we will say again the number is not valid, and please enter new value. Can you see it's working the same as an if statement by testing? But now we're testing it over and over and over again until the user gives us the number that we actually want, which is a number in the range of 1 to 100. Okay, so let's look at the loop control variable here. Can you see this is the loop control variable? The number variable is initialized to whatever the user's input is. So that's the loop control variable. It's been initialized. Then we test the loop control variable. There's number again. And then somewhere we must change the loop control variable again. So here we get a new input again. We're changing the value and then testing again, to make sure that we do not get into an infinite loop. So let's test out this program quickly. Okay, so now it asks, please enter a number in the range of 1 to 100. So let's say 101. It says that number is not valid. Please enter a number in the range of 1 to 100. Let's say 200. Still bigger than 100. That number is not valid. Can you see it will keep on popping up this JOptionPane? Keep on asking me. That's because we're in a loop now. It will keep on asking me until I give the correct number. So if I put a 0 there, which is less than 1, it's also not valid, and it asks me again. But if I type the value of 50 now, that is a number between 1 and 100, and the loop will exit, nothing else will happen. So after the loop, we can just say joption.pane.show message dialog. Let's say null there. Correct. Okay, so if we run that again, and it is correct, it will go outside of the loop and basically gives us that JOption pane. So let's say 40 now, which is inside of the range, correct, and we're done. But if we're not correct, it will keep on asking us using that loop to enter the correct value. So if I say 2000 again, it's going to keep on asking me, please enter a number that's correct, and it will keep on asking until I give a number that's correct. Right, so for the next example, we will be looking at a user-controlled loop. So the input validation example that we just did is actually also a user-controlled loop, because the loop runs basically how many times the user chose to not enter the valid number. But this one is a bit more direct to user-controlled loops. So this is basically how we ask the user to say, okay, how many times do you want this loop to run? And then we run the loop that specific number of times. So this is a user-controlled loop. So I'm just going to use a simple example, and I'm going to use a maximum value, and we're going to ask the maximum value from the user. So I'm going to use a JOption pane, let's say string input again, input, and get the input from the user. So we're going to say JOption pane dot show input dialog, get input from the user. And now what do we want to ask the user? So for this example, we're just basically going to ask the user, how high should I go? So we ask the user to type a number there, and we're going to square the number. How should I go to square the number? How high should I go to square the number? Okay, so that's basically the input. And now the maximum value we will set to let's just convert that one, integer.parseInt, and we're going to convert that integer value, or that string value, to an integer. So now we have the maximum value to say how high should we go in squaring numbers. Now for this example, I'm just going to use a normal system out print line to print out the results. I'm going to have something like number at the top, and then let's put some 1, 2, maybe 3 tabs there, and then I'm going to have number squared. So we're going to have the number and the number squared printed out to the screen. So let's just have a system out print line there again, and we will just have a line there to underline that part, and then we'll have our for loop. Now remember, for a for loop, we basically use a for loop if you know exactly how many times to execute the for loop. Do we know how many times to execute the for loop? Yes, it's that max value. So we want to execute, let's say the users say, I want to go as high as 5, which means I want to print out 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. Okay, so that also makes a difference on where do I start my for loop. So my for loop will obviously start at 1. So I'm going to say integer, and let's call it I, and that's the number that we want to square. So maybe let's call it number, equals 1 instead of 0 in the previous examples, because we want to have not 0 squared, but 1 squared, 2 squared, and so forth. And then I'm going to go to number less than or equal to the maximum value. So that's how many times I want to run this thing, and then we need to say number plus plus. So we're going to start off at 1, and then check if the number is less than the maximum value. So let's say the user enters here. Let's say the user enters a 4. So if he enters the 4, then our number will start at a 1. We will check, is that number less than or equal 4? Yes, it is. And then we will square the number. Then we increment the number, make it 1 more, so then number becomes 2, and we square the 2. Then number becomes a 3, and we square the 3. And when it gets to 4, is the number less than or equal 4? Yes, it is, so it will square 4 as well. But then when we go to 5, 5 is not less than or equal the 4, and then it will stop running. So that's essentially what we want to do here. So I'm just going to print out here number, sorry, that's without double quotation marks. It's whatever is in the number at that stage. Remember, the user maybe typed a 4, so right at the beginning that number, the maximum value would be 4, but the number starts at 1 and then gets incremented the whole time. So that number we're going to use plus, and now to simulate those tabs that I used there, you can just use a backslash T and a backslash T again. That's 2 tabs. So let's try 3 tabs there as well. And then after that, we'll have number squared. So it's number times number, and that will be the number. So let's see how this one prints out now. I'm going to run it. And I'm going to ask the user, okay, please enter. Okay, sorry, that one is still running, the input validation one. So let's click the run button there. We run the user controlled loop. How high should I go? Let's say 4. And you can see there's the number and the number squared. So let's make a bit more tabs there. One more tab. Let's see again. Let's say 4 again, and that's okay. So we've got the number 1, 2, 3, and 4, and the number squared is 1 squared, 2 squared, 3 squared, and 4 squared. Okay, so this is just a user control loop where we ask the user basically, how many times do we want to use or to run the loop? And I'm using that value as the maximum value in my loop as the value that I need to test for. And now we know, well, while that number is less than that one, we will keep on executing, so we know exactly how many times we want to run this. So if I wanted to run this loop also 4 times again, I could have started at 0 there, but 0 squared is not a value that we want. And then if I start at 0, I must leave out the equal sign there. So that's another way of doing it, and then I must add 1 to the number the whole time. So this is a better way of just saying, let's start at 1, but then we include the equal sign there in order to run it that amount of times that the user said we should run it. In the previous video, we looked at input validation and user-controlled loops. In this video, we will look at running totals and sentinel values in Java. Now, a running total is the summation of a sequence of numbers which is updated each time a new number is added to the sequence by adding the value of the new number to the previous running total. And I think this will become clear when we look at an actual example. So I'm going to start with an example where I'm declaring the number of days there. We also have a variable for the sales per day, which will be double. And then I'll also have a running total, which will be my total sales. And then we will need a string input to get the user's input on how many days do we want to have sales. So basically what the example is that I want to do there is to ask the user first off, for how many days do you have sale figures, or for how many days should we get sales from you? And then the user will say, well, let's say 5 days, and we will save that value into days. And then we were going to ask him, right, for day 1, give me the sales. And then I'm going to save day 1's sale into sales. And then after he's given me the sale, I will add that sale to total sales. And then I ask him again. Let's say he said 5 days. So I'm going to ask him for 5 days sales. So then for every day, I'm going to save that day's sale into the sales variable and then add that to my running total, which will be total sales. So this is my running total. And your running total should normally be initialized to a value. In this case, we're going to start with 0 and then keep on adding to it. Okay, so we're going to ask the user there. And that's why I use the string input there, because we're going to use the JOption pane again. So we're going to say JOption pane.show input dialog, and we're going to ask the user the question. For how many days, just get that away, for how many days do you have sales? Let me just go to new line, figures. Right, so that's the question we ask. For how many days should we basically run the loop and get the total sales? And then that number is whatever the user types is then as a string into input. And now we need to convert that. So I'm going to use the days variable and I'm going to convert that to an integer. What am I going to convert? Whatever the user typed. So that's in input. So I'm converting the input that the user gave me to an integer, and now we can use it. So I'm going to run the for loop the amount of times that the user indicated now. So I'm going to start with, let's call it count. I'm going to start with a counter starting at position 1 or 1, and then I'm going to say count less than or equal the amount of days that the user indicated. And then I must increment my count variable. Now in our previous examples, we actually started, most of the times we start at a 0 there. If I start at 0, I can leave out the equal sign there, and then it will run the same amount of times. So let's say I'm saying I want to run this loop 2 times, which is the number of days is 2. Then it will go for 0 and 1. Those will be the 2 days. And then less than days, which would be 2. Now 0 and the 1 will still be less than 2. So those are the two values that we will get, is the 0 and the 1. But if I change that to a 1, then I need to put the equal sign there to get the same number of times for the for loop to execute. So for instance, again, if we say 2 days, then it's going to be 1. And if it increments, it's going to go to 2. Is 2 still less than days? No, it's not less than 2, but it's equal to 2. So it will work exactly the same way. We will have it then for 1 and 2 instead of for 0 and for 1. And why do I want to start at the 1 there? Because I want to say, please enter the data for day 1. So I don't want to say day 0. Right, so in the for loop, we're going to ask the user a question again. We want to get the sale for that specific day. So we're going to use the input variable again and use the J option pane again to get some input from the user. And this time we'll ask enter the sales for day, and then we're going to ask him or her, the user, which day. In this case it is count. So basically what's going to happen is we're going to say enter the sales for day, and then it's going to show me the value where the loop is currently at. So the very first time the loop runs, it will show me enter the sales for day 1. Then we increment, and it will go and say the 1 becomes a 2, and then we'll say enter the sales for day 2. And so we'll carry on day 3, day 4, day 5, depending on what the user gave me there for the input of how many days should we run this loop. Okay, so that we got the sales for the day, and now that input should be converted to a double again. So now you can see that one is a double. We needed an int for the number of days there. We needed an int, but for the sales figures, the guy could tell me what for day 1 there was 34.50. So we need to work with floating point values here. So I'm going to basically convert that input that the user gave me. Just go back there. So it is double dot parse double, and we're going to pass in the input there, and that input what the user typed will then be converted to a double, so we can save it in sales. So now after these two lines, we have a double value that is the sales for that specific day. And this is now where the running total comes in. So I'm going to say now total sales will be the previous value of total sales plus this new sales value that we just got from the user. So obviously the previous value for total sales will be 0 the very first time you run it. So 0 plus whatever the user said for the sales will then become the new value for total sales. So in this way, every time the loop runs, we'll be adding to this specific total called total sales, and that we call a running total. Okay, so an easier way to do this to get exactly the same result is not to say total sales equals total sales plus sales, but just to say plus equals sales. Now what will that do? It's exactly the same thing. It will be total sales equals total sales plus sales. So we're adding to total sales, which is currently 0. Then when we're done with the for loop, we can just show a message dialog there again. Show message dialog, null for the first argument. And I'm going to go to a new line for the second argument. And now we need to give the message to the user. So I'm going to say the total sales is, or the sales are, and we're going to give him the sales value. Let's say working with dollars there or whatever. So it's going to say the total sales are, and then we're going to show the amount for the user. So we're going to use a plus there, and then it's going to be that total sales variable. And then because we are working with the J option pane, we're going to say system.exit, passing in the 0 there, just to make sure it exits a bit faster. Okay, so what have we done here? We've asked the user for how many days should we have sales. Then the user types, let's say, 5. That 5 will be converted to an integer and saved into the days variable, which is declared as an integer. Now we go into the for loop. We will start at position 1 or at number 1. So we declare a new variable. This is our loop control variable, and it's initialized not to 0 but to 1, because we want to say enter the sales for day 1, day 2, day 3. We don't want to start with 0. Because we don't start with 0, I need to add the equal sign there. Okay, so now in this case, we will start from 1 up until the number of days that the user indicated. So let's say the user indicated 5 there, that it will be from 1 up until 5, but 5 will be included. So that will run the loop 5 times. And then we're going to ask, enter the sales for day 1, enter the sales for day 2, day 3, day 4, and day 5 every time the loop runs. We get that value as a string, convert it to a double, save it into sales. And then we take our total sales variable, which is currently 0 right at the beginning, and we keep on adding that sales value to total sales. And after that, we'll get a total for all of the days sales. And that we call a running total. So let's quickly run this and see how it prints out. Right, so it asks us for how many days do we have sale figures. So let's say for 3 days, to make it easy. The sale for day 1, let's make it 10.50. Let's make day 2 20.50. And let's make day 3 30.50. And then it gives us the sales for $61.50. But now you can see it's a .5 there. So is it now 5 cents or is it 50 cents? So just another thing for this video is how do we print out decimal values or floating point values in a nice way? So for this, we can use the decimal format class. And I'm going to declare this one as, let's just call it, $. Right, decimal format $, equals new decimal format. Now, what you place inside of, well, this one accepts a specific pattern as a string. So the way that you assign this value will depend on your output. What do you want for your output? So in this string, we can use hashes and we can use zeros. So let's say I'm going to have some text here directly underneath that. So basically what this means, the hash means that if there is something in this digit's position, show it. If there's nothing, don't show anything. What does the 0 mean? If there's something in that position, show it. But if there's nothing, place a 0. Okay, so in this way, when we say hash 0.00, it will format it on the other side of the dot. If there's 2 zeros, it will round it off to 2 decimal places. If I put 3 zeros there, it will round it off to 3 decimal places. So you can go and play around with this pattern a bit, but the hash basically means if there's a digit in that position where you place the hash, then show it. Otherwise, don't show anything. And then the 0 means if there's something in that position, show it, but if there's nothing, put a 0 there. Okay, so let's see how we can format this one now. So a nice way of doing this is maybe adding more hashes there and putting a comma there, so you can show the thousands as well, comma separated. So this one will basically be something like, if I can place that again directly underneath it, we could have something like 2,000, let's say 2,000 Rand, like that. Okay, so that's basically the notation. The hash will just place something there, but after the 1, 2, 3, fourth one, just after the fourth one, it will place a comma there, so we can see the thousands. Okay, so I'm going to leave that pattern as this, and then the way you apply it then will be to go to the value that you want to print out, which is total sales. And I'm just going to say $.format, and then in brackets, I need to place the value that I want to format. So I'll put in total sales. So it's $, the one that you defined there at the top, .format, and then placing in total sales. So basically this one should give us 2 decimals rounded now. So if we run that again, so how many days do you have sales figures? So let's say 3 again, 1050, 2050, 3050. And you can see it's nicely rounded now to 2 decimal places. A sentinel value can be used to notify the program to stop acquiring input. So I'm going to explain this in an example as well. So basically what I want to do is to ask the user to enter a value. So I'm going to have a variable called value, and that value we will double for the user. So I'm going to also have an integer there and call it double value. So let's say the user enters a 2, then we will double the 2 to a 4. And if he enters a 3, we will double the 3 to a 6 and so forth. So we're just multiplying it by 2. Okay, and then we must allow the user to keep on asking the question or giving us a value for the question that we're asking. So we're going to ask, please enter a value to double, and then he will keep on adding or entering numbers to double until he chooses to stop. And this is what we call then a sentinel value. So let's get input from the user quickly. So I'm going to ask the user, let's say JOptionPane.show input dialog, and we're going to ask the user the following question. Please enter a value to double. But we're going to add to that. So I'm going to add some text there as a bracket, and I'm going to say 0 to stop. So if you don't want to double another number anymore, then you can just add a 0 that you can stop this program from running. So we will keep on allowing the user to enter a value to double and double it for him until he enters 0. So I chose my sentinel value here to be a 0. That's the one value that will stop my loop from executing. Now, why did I choose 0 there? Because I think everyone can double a 0. So nobody would usually ask that question, please double a 0 for me. It will just be a 0 again. So that's why I chose that one. So normally choose your sentinel value as one that will basically never be asked or never be used unless they want to stop. Right, so now we need to convert that value. So we've got value declared there at the top, and we want that one as an integer. So I'm going to say integer.parseInt. Convert that integer now, or that string, to an integer. So there's the string. Please enter value to double. The user enters 2, for example. We save that into input. We convert input to an integer, and we save it into value. Now we can use a while loop to help us to keep on asking the user to enter a value to double until he enters a 0. So we're going to keep on repeating what we're going to do in the while loop while the value is not equal to 0. So while the value that the user enters is not a 0, we will keep on doubling it for him. So we will say double the value, or double value, that's the variable that we declared at the top, should be the value that the user entered, but we're going to multiply that by 2. And then let's just give the answer to the user. So we're going to say JOptionPane.show message dialog, null for the first argument. For the second argument, the message. So we're going to say, okay, let's just have a string there, and then we're going to say plus the value plus, and we'll have another string there. So we're going to have the value that the user entered, let's say 2, and then 2 squared, or 2 not squared, multiplied by 2 will be then the answer that we give him. So we're going to say value, the value that you entered, doubled is, and then we're going to show him that doubled value. So it's going to be double value, the one that we doubled for him. So we're going to enter first what he typed, that value that you typed, doubled is double value, which is your value multiplied by 2. Okay, so that's the JOptionPane. And then this loop, if the loop runs again, we will keep on doing the same thing over and over again. So it's very important again to remember your rules for a loop. First things first, there's a loop control variable. So the loop control variable is the value. So there's the value that the user entered. Remember, we first get it from input and then we convert it to a value. So that is my loop control variable, and it is initialized there by the user's input. Then we check the loop control variable. But for this loop to exit somewhere, we must change that loop control variable. So in the loop, I will ask this very same question again. So I'm going to copy that and paste it there. We're going to ask the user again, let's just remove the string declaration there. You cannot declare something twice. So input will then be, again, we're going to ask the user again, please enter value to double, 0 to stop. He enters the value again. Then it goes to the loop. It checks if the value is not a 0, double the value, print out the result to the user. Then we ask again, please enter value to double, 0 to stop. Get the value. If the value is not a 0, double it again and give the result to the user. So you can see this will carry on and on and on until the user types a 0, then value not equal to 0 will return false and your loop will exit. Now, because we are using JavaScript pane, let's just add the system.exit at the bottom. So let's run this one quickly and see how it works. Okay, so we're still running the previous program. Let's just go to that play button there and run it. Please enter value to double. So I'm going to enter 2 there. 2 doubled is 4. And then you can see it keeps on asking me. If I place a 3 there, 2 times 3 equals 6. If I place a 4, it will give me 8. A 5 will give me 10. And so I can keep on adding values there and it will double it for me. Unless I type a 0, which is my sentinel value, the value that will stop the loop from executing, and then everything stops. In this video, we're going to look at how to write to files and how to read from files in Java. So the first class that we're going to work with, we call the print writer class. So the print writer class is part of the java.io package. So we're going to import that one. So just by selecting it, it automatically imports at the top. And the print writer class will help us to create a new file and then write to a file. So I'm going to call this one the output file. And I'm going to say new print writer. And then what it accepts is basically the file name or the name for the file. And in this case, we're just going to call it output file. But remember, we're working with text files. So when we're working with text files, we need to add the extension .txt right at the end. So in Java, we can work with text files. You can work with data files as well. So for this example, just normal text files that you can open up with a text editor. Now it gives us a problem here that we can fix with a simple try catch block, but we haven't done exceptions yet. So for now, we're just going to add throws IO exception. So IO exception. That's also part of java.io. And that exception there, we're basically just telling this, or telling the compiler that this method, the main method, are able to throw an IO or input-output exception. So just add that at the top of your methods wherever you're using files. So in this case, we say print writer output file equals new print writer, and then the name of the file. So this essentially opens up the file. It opens the file, or create, let's say create the file and open the file. So if the file does not exist, it will create the file. If the file exists, it will replace the file. Okay, so that's basically what this one line of coding is doing. Now if we want to write to the file, we can just use the object, so that's called output file, dot, and you can use either print or the print line method. So in this case, I'm going to use the print line method and I'm going to write one line of text to the file. So I will say something like this is line 1. Go to the next line and we say output file dot print line again, and we can say this is line 2. We can go to the next one, output file dot print line, and we can say this is line 3. So here we've basically created the new file called output file, and we've written 3 lines to that file of text. So this is line 1, line 2, and line 3. Then the last step here is you must remember to close your file. So I'm going to say output file.close, and that basically saves then the data and closes my file for me. So there's basically 3 steps there. This is step number 1. Create the file if it doesn't exist yet. If it exists, it will replace the file, and that's the name for the file. Then also you can use one of the print or the print line methods on that object in order to write to your specific file. And then you can close the file when you're done working with the file. So let's quickly run this and see what happens if I run this now. So you'll see at the bottom we did not print anything in the console. So obviously don't go and have a look at the console. But what happened now is we created an output file.txt file there. So you'll see as part of your project, you've now got output file.txt. And if I open it up, you can see that's exactly what was written into it. This is line 1, line 2, and line 3. And you can see it there. I can add another line there, output file.println, and I can say this is line 4, and then run it again. And now running it again, if I go back to the file, you can see there's 4 lines now. Okay, so this is basically how you create a new file and how you write to that file. Right, let's take this same file now and let's try to read the data now from this file. So now I'm going to go to my next class there that's called reading from files, and I'm going to go into the main method there and see if we can read from this file that was created now. So for me to read from a file, I'm going to use the file class that's part of the java.io package. And I'm going to call this one file as well. And we're going to say equals new file. And then in brackets, I need to give the name of the file again. So the name of my file is output file. So I'm going to say output file.txt. And because Java is case sensitive, make sure that you use output file exactly the same spelling. So this is the file I want to connect to. Now before we start reading from the file, we must first check if that file does exist. So we're going to use an exists method on the file object, and this method tells me whether the file that we're currently trying to connect to, if it actually exists or not. So if it exists, we're going to read from it. The else part there will be it does not exist, so we can just display a JOption pane. Let's say the message dialog there, second argument, the file does not exist. Okay, so we can display that to the user. So now if the file exists, we're going to go into the if statement. So this is the first line. This line basically just makes a connection to the file so that we can start reading from it, but we cannot read by just using the file class there. So what we need is the scanner class. So remember that we used the scanner class a few videos back to actually read input from the keyboard, directly from the user, and what the user types on the keyboard. So now we're going to use the same scanner class with its same methods to actually read from a file. So we're going to say scanner, and I'm going to call this one input file now, equals new scanner. And now instead of saying system.in, if you remember correctly, if we try to read from the keyboard, we said it's system.in there that we need to pass in there. But now we're not going to pass in system.in. I'm going to pass the file object there. So this file object has got a connection to this file. It does exist if it enters this if statement, and now we make a connection using the scanner class. And after this line of coding, we can actually now start reading data from the file. So again, it gives you a problem there that it talks about the file not found exception. So just for now, at the top of your main method, just at the end, we're going to add throws IO exception again. Exactly the same that we did there. Throws IO exception, we will do there as well. This is just telling the method that it could be that this specific class, the scanner class, when trying to read from the file, that file does not exist and it could throw an input-output exception. In this specific case, it could be a file not found exception. Okay, so now all the errors are gone. So we've made the connection there with the file, output file.txt. We connected that to the scanner class so that we can start using the methods of the scanner class in order to read from the file. Okay, so now we know there's 4 lines of coding or 4 lines of text inside of that file. So we can say input file let me just use a system out print line here. So we're going to say system.out.println, and we're going to say input file. Now the input file object there, we can use one of the next methods again. So if you're reading let's say a double from the file, if there's doubles in the file, you can use next double. If there's integers in the file, you can use next int. And remember then for text, it's the next line method. So by using the next line method here, I'm actually now reading the very first value from the file. So as soon as you open up the file by using file and scanner, we will have a file pointer that will point to the very first line. So what happens is, as soon as you call the next line method on that object, it will extract the data from that line it's currently at, and pass it back. In this case, we're just printing it out. And then what this next line method then do, it moves the pointer to the next line. So now that whenever you call next line again, it will again extract this one line and move to the next line. If you call it again, it will extract this line and move to the next line until it reaches the end of the file. So there's 4 lines of coding, or 4 lines of text there. So I'm just going to use system out print line again. Let me just copy them. Going to do the exact same thing all over again. So we're using one of the next methods to actually extract the data of that one line and then move the pointer to the next line so that we can keep on extracting each value. So you agree then that we've got all 4 lines extracted here, and it will be printed out to the console. So then just before we exit here, before we stop here, we must remember to also close the file. So I'm going to say input file, which is the scanner object, and we're going to say input file.close, which closes the file for us. Now let's run this quickly. Now this one will print out to the console. So at the bottom we will see those lines of coding now if it gets it. Let me just run it again. I think it was still the previous one running. Okay, there we go. So you can see there, this is line 1, this is line 2, this is line 3, this is line 4. So basically what we did there, we made a connection to output file.txt, this one, and we started reading from it by using the scanner class and one of the methods of the scanner class. So it's either one of the next methods, it's either next line, next double, next int, and you can read data from a file using that next method. Now one important thing, if I add one other line there to extract another line, so we've got 1, 2, 3, 4, 5 times we're extracting data from there, but there isn't 5 lines there to extract, then that will give us a problem. So if we run this now, you will see that it gives us an exception that says no such element exception, no line found. So basically what happened now, when it reached the end of this and we call next line again, then there's nothing in that line to read anymore. It's an empty line, or basically the end of the file. And that's why it gives us this exception, because we're trying to read data where no data exists. So that could be problematic for us in our program. So basically, we should not do it like I've done it here. The best way to do this is to use a while loop to run through every element in the file until we get to the very last line in the file. So to do this, we've got the scanner class that's got a method called hasNext. So this hasNext method will check whether you reach the end of the file or not. So now again I can go and say system.out.println, and I will print out input file.nextLine again. So I'm extracting one line from the file and I'm printing it out. But now what's going to happen here? Remember there we make the connection to the file and we open up the file. Now it goes into the while loop. It checks where the pointer is currently at. So right at the start, when you open up the file, your pointer will be at line 1. So then the hasNext method checks, it sees that the pointer is at line 1. There is data to read, so it allows you to go into the while loop. And we print out input file.nextLine. Input file.nextLine will go, it will extract, this is line 1, and it will move the pointer to the next line. Now if the pointer is at the next line, it goes back to the loop again. The hasNext method sees that there is still data in that line, so it allows you to go into the loop. We print again input file.nextLine. Input file.nextLine will read the second line there and move the pointer to the third line. Now it goes back to the loop again. hasNext method sees, okay, there is still data in that one line, so it will allow you to go into the loop, and we call next line again. When calling next line again, it extracts this line and it goes to the next one. Now again, in the loop, hasNext method sees, okay, there is some data in that line. It allows us back again. Input file.nextLine runs again. It extracts this one line that says this is line 4, and it moves to the end of the file. So now when the hasNext method tests again, it will see that we are at the end of the file, and it will stop the loop from executing, which means this last part will not run again, which will give us that exception. So this is a way to actually skip that exception of getting to the end of the file and you don't know that you're at the end of the file. So this is a nice way of extracting data from a file where you do not know how many lines of text or numbers or whatever is in that file. So that's the while loop. Remember, a while loop needs 3 parts. Basically, you need to initialize the loop control variable. So the loop control variable here could be the pointer. So these 2 lines will move the pointer, open up the file and move the pointer there. And then we're testing there in the hasNext method, we're testing for that pointer. Where's the pointer? It's at a line with data, yes or no. And then how do we increment? By using one of the next methods. So it's either next line or next int or next double. That will move the pointer to the next line, to the next line, to the next line, until it reaches the end of the file, and then the loop will stop. Okay, so let's run this application quickly and see if it gives us the same output that we had previously. And you can see there it gives us all 5 lines, or all 4 lines. I can also add some more lines there. This is line 5. I can also say this is line 6 and carry on. And every time I run it, it should basically read those lines also from the file and show me the results. Okay, so let's try another example. So I'm going to remove, let's remove this part there where we print out. And let's try and work with a different type of file. So instead of using text there, let's just use numbers. So I'm going to use 5, 10, 15, 20, 25, 30. And we can carry on entering numbers here. We could have 1,000 numbers here if you want to. Okay, so what I want to do in this example is to work out the average of these numbers in the file. Now, there could be 1,000 numbers in this file. I'm just taking an example of taking 6 of the values. So what we can do then is to also read from the file. So we make the connection to the file, output file.txt. We will use the scanner class and its methods to read the data. But now, because we're going to use or work out the average, I will need some variables. So let's have an integer as a sum, which will start the sum at 0. So just to add all those numbers, because to get the average, you need to sum all the values and then divide by the number of values. So we will need some sort of a counter there as well that we will need to keep track of to count how many values are in the file. That's the counter. And then we can work out the average by using an average variable there. Okay, so what we want to do then, in the file, we open up the file, that's the file name, we connect it to the scanner class, and now in the while loop we can start reading. So I'm going to say sum equals the previous value of sum plus now a line from the file. So I want to get the 5 and then the 10 and then the 15 and so forth. And because these are integer values, I can then go and say take input file dot next int instead of next line. So now I'm reading an integer from the file. That integer will be added to the sum and saved back to sum. So the sum is currently at 0. So the very first time this loop runs, 0 plus the first value will be 5, and the sum will then be 5. The next time the loop runs, it will be 5 plus whatever is the next one, the 10. So that will be 15 then saved in sum, and so it will continue and continue and continue until we are done with the while loop and we are at the end of the file and we cannot read anymore. Okay, so that will be the sum. Now, after we have the sum, we also need to somewhere just count how many times we are running this loop, because counting every time the loop runs will basically be counting how many values there are. So we can see now, obviously, there's 6 values, but you won't know how many values there are if there's more than 1,000, for example, in a file. You can't go and count them. So by using this counter inside of the loop, we will actually get the sum of all the values and how many values there are. And then we can work out the average. So the average will basically be the sum of all the values divided by the number of values, which will be the count. Just remember that we are dealing with 2 integers here, both of them declared as integers, so we could get a problem here with integer division. So just cast one of the 2 or change one of the 2 to a double. Right, and now we can display this to the user. So I'm going to use a JOption pane, and we're going to say show message dialog. First argument, the null, to be in the middle of the screen. Let's go to a new line for the message. And we will say something like, let's say sum of all values. And then we can display the sum. Then I'll have a new line character there, which is just a backslash in, and then we're going to go to a new line in the JOption pane, and then the next line we will say the number of values, and the number of values will be the count. Then a new line again, and then we will say the average is, and then show the average. Okay, so that's how we can do one printout, but 3 different lines in your message dialog. So let's run this one quickly. Right, and you can see it gives me the sum of all the values is 105, the number of the values is 6, and the average is 17.5. So there were 6 values there. Let's change it. Let's add a 35 there as well and run it again. So it will then read the 35 as part of the data, and it will tell me the sum of all the values is now 140, and this number of values 7, and the average is 140 divided by 7, which will give me 20. In this video, we will look at methods in Java. Methods are commonly used to break a problem down into small manageable pieces. Methods simplify programs. If a specific task is performed in several places in the program, a method can be written once to perform that task and then be executed anytime it is needed. And this is known as code reuse. So we get 2 types of methods. There's a void method and a value returning method. So a void method is one that simply performs a task and then terminates. For example, your system.out.println. So your println method doesn't return a value, but it just does something. So in this case, this is a void method will be printed to the screen. So a void method is one that simply performs a task and then terminates. Now a value returning method not only performs a task, but also sends a value back to the code that called it. And an example of that would be the parseInt method, where we convert a string to an integer. So this is the method parseInt. It accepts a value, and taking that value, it converts the value and it sends back the value, and we can save that value in the number variable. So this is an example of a value returning method, and this is an example of a void method. So a void method is one that does not return a value. So for now, let's just comment out these lines, and then we can look at some methods. So we're going to do some examples on methods. The first method, or the first type of method that we will look at, is the void method. So with methods, you can see that it is still inside of the class, but it's at the same level as this method called the main method. So the main method is the very first method that will execute in your application. And then from there, we can call other methods. So for this specific method, I'm going to have static keyword there. And remember that public is an access specifier. Public is an access specifier. It tells me where can I access this specific method. So if I'm declaring it as public, it means I can use that method basically inside of my own packages as well as inside of other packages. So we will talk about access specifiers a bit later when we start working with classes and objects. So this is an access specifier public, and then static means that this method belongs to the class methods. It doesn't belong to objects of the class methods. And as soon as we start with classes and objects, we'll get into that also a bit more. So for now, we will make our methods public and static, and then you can name, or first your return type in this case. So we're going to have a void method, and then we can give our method a name. Now let's call this method print average. So for this method now, you can see that we've got the access specifier, we've got the static keyword, and then this is the return type. So if I indicate a void there, it means that this method will not return a value. And then the last part there is the name of your method. And then it's your choice on how many values to accept inside of a specific method. In this case, we can have an average of 2 values. So I can say, let's use an integer value 1, and we will have an integer value 2, which now means that this method called print average will accept 2 values, and those 2 values we will use in order to create our average. So we can have a variable in here, let's say double average, and the average will be value 1 plus value 2 that was passed in, and those values summed, the answer that we get there, will be divided by 2. Just remember to put a 2.0 there so that you don't have integer division. So in this case, the average will be whatever you pass into the method, value 1, plus the value 2 that you passed in, and the answer of that will be divided by 2 to give you the average. Now we said this is a void method, which means that we're not going to return anything, so we will just use the system out print line there and print out and say something like average and give the average. So this method basically just works out the average and then prints out the average to the screen. So how do we call this method? By just calling print average. Now print average, you can see it wants now an integer value for the first argument and an integer value for the second one. So you can see there also. Right, so now we're going to pass in, let's say we pass in 20 and we pass in 30. And now after passing in 20 and 30, that is calling the method. So what will the method do then? It's going to take that 20, put it into value 1. It's going to take the 30 and put it into value 2. So now when we work out the average, it will be value 1, which is 20, plus the 30 will give you 50, divided by 2 will give you 15. Sorry, not 15, 25. Right, so let's run this quickly. And you will see it prints out the average as 25. So let's create another method, and this method will now be a value returning method. So I can also declare it as public and static. And now instead of saying void, let us return this average instead of just printing it out on the screen. So which means that if I want an average to be returned, which is a double, the return type will be a double as well. So it's going to be public static double instead of public static void. And now let's call this one get average instead of print average. And we will also do the same thing. Let's pass in value 1 and we'll pass in value 2. And then we want to return the average. So we can do that variable again. Double average equals the same thing as we had there. So it will be value 1 plus value 2. And then we're going to divide that by 2.0. So we work out the average exactly the same way. And you can see that it picks up an error here because it's missing a return statement. Remember, this is a value returning method, so we must return something. So that's where the return statement now comes in. We must return then the average. So now we're going to return the average for the user. The user just gives us, or the programmer just pass in the value 1 and the value 2. And the method will work out the average and return the average for me. So how will we do this method? Obviously, because we return something, we can have a variable here called average, and that average will be getting the value from this method. So I'm going to call get average there. That's the method. I'm going to pass in the value 20 and 30. And then the get average method will run, passing in 20, passing in the 30, and then double average will be worked out as 20 plus 30 again, divided by 2 gives you 25, and that value of 25 will be returned, and that will be saved into average here. So if we want to print it out now, I can just print out there, average again, and I can say plus the average there. So let's just make this two different values. Let's make it 30, 30. So it's not the same as that one. And 30 plus 30 gives me 60, divided by 2 gives you 30 again. Okay, so that will be this average that's printed out. So if we run this again, let's just see if the answer is correct. So you can see there the average of 25.0 and the average of 30. Those are the two methods that we actually executed. Now, you can see there's an average variable that we declared as double average. And here we've got double average as well. So these two variables are not the same. This is not the same average that we're referring to. It is allowed for the same variable to declare it if it's in different methods. However, I cannot declare double average here again in the same method. Then it will give me a problem. It will say that it's already defined inside of the scope of this method, and that's not allowed. But it is allowed for me to declare the variable called average there, and I can also declare the average there as well as there. So this one and this one and this one are different averages that was declared. Okay, so these were methods that we worked with number values. Let's try something when we work with strings. So I'm just going to comment these out here so that we don't have them the whole time. And then we just look at some more methods there. So we're going to create another method here. It's also going to be public and static. And then I'm going to call this method, or this method will be a value returning method. It will be returning a string. And let's call this one full name. And we let this method accept a string name and a string surname. And then we will concatenate the name and the surname. So this could be a useful method, or maybe not. So let's just create a string variable there called name, or let's call it full name. And the full name will be the name that was passed in there, that name, plus, let's put a space in between the two, and then the surname. So now we can use this method then to return back the full name there. So I can say return full name, and now that will return whatever the user typed, or whatever we got into this method. So the full name method will return a string, but it accepts a name and a surname. The name will be first, then a space, and then surname, and that new string will be saved into the full name variable. And then we will say return full name, which will return that concatenated string. Right, and this is just a long way to do this, and this is why they give us this this problem there. So we can look at doing it in a shorter way in a few moments. Right, so how do we call this method now? So obviously, because it's returning a string, I must be able to have a variable this side where we will actually get back the full name. So I'm going to call that one also full name equals, how do we call this method now? I'm going to call full name, and then I need to pass in a name and a surname. So let's pass in John and Rambo. Right, so those are the two values that we pass in, the name and the surname, John and Rambo, and then it will be concatenated as John and a space and Rambo, and it will be returned back. Where will it be returned back? Into the full name there. And now we can just print out the full name. So let's just print out full name. Let's see if this one runs. This is now working with strings, and you can see there it prints out John Rambo. So we pass John and Rambo to the full name method. The full name method concatenates the two, return it back, and we print it out. Okay, now let's just look at a shorter way of doing this. It's not necessary for us to actually have this variable declared there. I can actually just say return this whole thing for me and then remove that return statement. This will do exactly the same thing. It's because if I say return, what do I need to return? This part there, which concatenates the two. So if I run this again, it will return in any case the concatenation and place it in full name there. So let's just look at the printout. You can see it's still John Rambo. So that's the shorter way of doing it. It's exactly the same what we did here. Instead of having that whole declaration, we can just say return that whole thing there at that, or this whole line, and that will do exactly the same thing. Okay, so let's look at one last method that we can use. Let's try working with booleans a bit. You can see that this one gives us a hint there that we can make the access private here, and private means that I can access this method only inside of this class. But let's say I've got another class here that you can define, and I can actually call this method, and if I want to do that, this method must be public. So it doesn't pick up any other classes that's using this method, and that's why it gives us the hint there that we can actually make this one not public but private. But for now, just keep your methods public unless you only want them in this one class. So we're going to create another method, and I'm going to call this one public static boolean, and we're going to call it isValid. So you can see that I'm going to pass in, or I'm going to return a boolean, and the method name is isValid. And we're going to pass in a number value here, and we will check the number if it's in a specific range. So let's just have this a range between let's say 1 and 100. Okay, and then if it is in that specific range, we will pass in, or we will send back a true value there. So we pass in a number. If the number is in the range of 1 to 100, we return false. Otherwise, we return true. So we'll have a Boolean variable here, and we're going to have that one as the status. And then we can check with an if statement if the number, the one that was passed in now, if that number is greater than or equal to 1, and at the same time that number is also less than or equal 100. Then we know it's inside of the range. Remember, if we want to check for something inside a range, we use the AND operator. And then we can set the status to true. And then the else part there, if it's not between the two values, we will set the status to false. And then at the end, we can just return the status. So this is another way of how to use a method by using Booleans. So in this case, we're sending back a Boolean. The method's name is valid, and we're checking for a specific number. So we pass in that number. That number is checked. If it's greater than 1, and at the same time it's also less than 100, we know it's inside or less than or equal 100, which means that it's inside the range of 1 to 100. Then we set the status to true. Else, it's not in the range, so the status will be set to false, and then we return the status. So how can we use this method then? So right at the top, I'm going to remove those two statements again, so that we just work with the Boolean one now. So basically what we can do then is to get a value. So I'm going to declare a value equals, let's say the value is 20. And now I can use an if statement to use this method, because if statements needs a Boolean value in order to be true or false. It's some sort of expression. So I'm going to pass in the isValid method here, because the isValid method returns a Boolean. And I'm going to pass in that value that is now a 20. Right, so basically now the isValid method will accept the value of 20. There's the 20. Then we check, is 20 more than or equal 1? Yes, it's more than 1. Is it less than 100? Yes, it is. So status will be set to true, and at the bottom we return then the true value. That true value will be returned to the if statement. The whole if statement will be true, and then we can print out to the screen the value is in range. What will be the else there? That will be if the value is not in range. So we will say the value is not in range. So let's just run this one quickly. This one should actually tell us now that the value is in range, and you can see the value is in range. So if I put something like a -10 there, -10 is not in between 1 and 100, so it should give me the other else statement, or the else statement that says the value is not in range. And you can see the output. Now also a faster way of doing that method would be to actually return this part. So if I remove everything else there, I can actually just return this whole part there and remove all the return statements and even the declaration of the variable. Because what we're doing now is saying return whatever this whole thing evaluates to. So if the number is greater than or equal 1 and the number is less than or equal 100, it will either give me a true or a false. And that's the exact same value that we will be returning. So that's just a very much shorter one, or a shorter statement to use than having that whole big if statement structure. So let's run it again. Remember, the value is at -10, so it should actually return a false, and it should say the value is not in range. If I have a 10 there, for example, which is in the range, it should tell me the value is in range. So that's just working with Booleans. Now the last thing for this video that I want to quickly get to is documentation comments. So you remember the comments that we said we get 3 types of comments. It's a single line comment, there's a multi-line comment, and then there's a documentation comment. So for the documentation comment, you put a / and a star, and then you just click on enter. Sorry. Let's just do that again. It's a / and 2 stars, and you just click on enter. And then it opens up this part for you. So the first part there is where the cursor is at. You need to explain what your method does. So in this case, we will just say this method prints the average of 2 numbers. And then you see that there's an @param tag, which refers to these 2 parameters that you have indicated. So you can see it picks up val1 and val2. So now you can explain that variable. So val1, the first value, and then you can say val2 is the second value. Okay, so that's a documentation comment. And now if you go to the getAverage method, you'll see that this method is a void method, so it doesn't return anything. But this one returns something. So look at this documentation comment quickly. You'll see that it also have the 2 values, but it's got a return at return tag as well. So the first part there is describing the method. This method calculates the average and return it. So value 1, you can still say that is the first value. So I'm just basically comments here. And that one is the second value. And then for the documentation tag, at return, what are you returning? The average of the 2 values. Okay, so these are our documentation comments. So if there's a return value, if it's a void method, you won't have an @return tag. But if it's a value returning method, you will have the @return tag. And basically, you just need to describe what's happening. The very first part, describe your method. Your @param tags, you can describe what every one of those 2 values that you accept, what do they do, or what are they for, and then the return tag, what are you returning. So that's how we can use documentation comments with our methods. An array is a container object that holds a fixed number of values of a single type. An array is used to store a collection of data, but it's often more useful to think of an array as a collection of variables of the same type. Instead of declaring individual variables, such as for this example, if I'm going to say integer numbers 0, numbers 1, numbers 2, numbers 3, up until numbers 9, and I'm assigning values, instead of doing that, I can declare one array like I'm doing there, and then I can use numbers at a specific index value, in this case numbers 0, numbers 1, numbers 2, numbers 3, numbers 4, and assigning values to those index values to represent individual variables. And the length of an array is established when the array is created. After creation, the length is fixed. So if we quickly have a look at this picture then, if I declare an array, you can see that the declaration basically is just int, or you can have different types. Obviously, you can have any primitive data type. So you'll start off with the type, and then two brackets there, and then the name of your array, and then you must say new int, because to create a new object in Java, we use the new keyword, but we'll get that in the next set of videos. So the new keyword creates a new object in memory, and this object will basically be an array of integer values that can accept 10 or store 10 values. So it's basically the same as what we're doing here. We're declaring there 10 variables and setting those values to 10 specific variables. So instead of doing that, we declare one array, and an array looks like this when declared in memory. So I'm essentially declaring 10 spaces in memory where I can save integer values, and you can see that they are indexed. So to get to the very first value in the array, we'll start at position number 0, 1, 2, 3 up until 9. So if the length of the array is 10 like we've declared there, then it can hold 10 integer values, but it will be indexed from position 0, 1, 2, 3 up until position 9. And you can see that's how we will then assign values. We will say number 0 equals 5, numbers 1 equals 10, and so it carries on until you get to numbers 9. Unfortunately, if your array is declared as a size 10 there, you cannot try to access the 11th value, which will be numbers 10. So now that we have a slight idea of what an array is, let's just close that picture. Let's see how we can declare it. So I'm going to delete all of these and just stop with the declaration of the array. Okay, so there's the declaration of our array. Another way to declare the exact same array would be to say int. I'm just going to call it something else. So let's say numbers. Instead of having the brackets there, we can say numbers 2 and then have the 2 brackets at the end equals new int and have it the 10 values. So declaring these two in this specific way, we are essentially creating two of the same arrays that can hold 10 integer values. But if you declare more than one array at a time, so if I'm going to say int numbers 3, comma numbers 4, comma numbers 5. In this case, numbers 3, numbers 4, and numbers 5 is declared as arrays. They're not initialized like we did in those two. And the other way of then declaring them would be to say, let's say this one should be numbers 6 with the block brackets at the end, and then numbers 7, numbers 8. So now the difference here is, you can see there I've placed the brackets at the front, and then we've got numbers 3, numbers 4, and numbers 5. If I do it this way, it means that only this one called numbers 6 will be an array. These two will be normal ints. So if I want to have these two also as arrays, then I would have to add the block brackets to both of them. So if you want to declare 3 arrays of the same type, then I can easily do it by just basically doing that first one, to have the block brackets at the beginning and then declaring them. All 3 of them will be integer arrays. But if I declare it with the block brackets at the end, then every array that you declare must have the block brackets at the end. So just some information that could be useful for you in the future. Right, so let's delete all of these and stick with that first one again. Integer numbers equals new int 10. So how do we assign values to the array? We've seen that now in the previous example, but you can basically go to your numbers array and switch to the specific index where you want to go and save a value. So in this case, in index number 0, I'm going to save a value of 10. In index, let's go to just another one there, index number 2, I will assign a value of 15. And let's say numbers at position 3 equals, let's make it a 20 there. So this is how I'll assign values to the specific elements inside of an array. Let's start with 0, 1, and 2 there. So let's just create, instead of saying 10 there, let's use 4 values there just to keep this simple. So I'm going to say numbers, let's do the last one there, 3 equals 25. So you can see then that we've assigned values to every single index value for that array. Now another way of doing this a bit short, if you know the values right from the start, I could say numbers, let's say 2 now, equals new int, and let's use that same values. So I'm going to say 4 again. So this is the declaration to say that I want to have 4 values stored in it. But instead of doing this, we could use the curly brackets and give the values right from the start. So I could say I want 10 there, then 15, then 20, and then 25. So this is essentially doing the exact same thing as what we did there. We're basically saying go and create a new array of size 1, 2, 3, 4, exactly like we had there, and into position 0, 1, 2, and 3, go and place those values. So these 5 lines of coding is doing essentially the same as this 1 line of coding. Okay, so there we have initialized it, we've declared the array, we've set the size to 4, and we set the values already in the array. So let's just quickly print out one of these values. So I'm going to say system.out.println, and let's print out numbers, which is the top array there, and let's go to, let's say what is in numbers 0. If you run this quickly, just to print out to see what is in numbers 0, and you can see there that it's the 10. So number 0, we placed a 10. If I change that to a 1 and run it quickly again, you can see the value prints out as 15, and that's what's saved into 15, or into position 1. So I can also change this to numbers 2 and go to position 1, and numbers 2 is this one, and position 1 is 0, 1 should be the 15. So now let's run this quickly again to see how it prints out, but that should be the 15 there, so you can see it prints out 15. Okay, so now an easier way to print out all the specific values of an array is to use a for loop. So with a for loop, I'll start at an index, and that's why normally we use an I when we're working with arrays, but it's up to you. It's just a variable name, but I stands basically for index there. So I will normally start my I variable there at a 0 because of our arrays starting at position 0 as the index value. And then we're going to test for the length of the array. So I'm going to say I less than, and the array, let's take the first one, numbers there. I'll use numbers, and there's a useful variable we can use there as part of the array class there, and that's called the length. And I'm going to use the length in there in order to indicate or to see how long that specific array is, or how many values can it store. In this case, you can see it's 4. So numbers.length will return a 4. If I say numbers2.length, it will return also 1, 2, 3, 4. It will return a 4. So we're essentially saying go from the index value 0 up until the index value of numbers.length, but less than numbers.length. So if I use a comment here, you're going to start at 0, and it should be less than numbers.length, in this case is 4. So what will happen is we're going to start at position 0, then it increments. Is 0 less than 4? Yes, it increments. Is 1 less than 4? It goes to 1 there. Yes, it is. So then we're going to go increment 2 less than 4. Yes, it is. And then the third one, is 3 still less than 4? Yes, it is. But as soon as we increment again, then 4 is not less than 4. So you can see that we're not going to go to numbers 4 there at all. Okay, so this is very important. You will go 1 less than the length of that specific array. So if it can hold 4 values, I will go to index number 3 as the last value. You see it's also 1 less, or always 1 less than the size of your specific array. So in this case, we're going to say numbers.length, which is 4. So we're going to go from 0 to 3 basically. And then we can print it out. So we're going to say system.out.println, and then we can print out that specific array. So we're going to say numbers at a specific index, and the index will be I in this case. And we know that I will start from 0, then go to 1, then go to 2, then go to 3, and then it will stop. So if we run this quickly, you'll see it prints out now all the values for me in a new line. So we've got 10, 15, 20, and 25. And even for this one, if we add another value of 30 there, and I say let's go to numbers2.length, and I print out numbers2, then it should print out 10, 15, 20, 25, and 30. And there you can see it. So now the length of this array changed now to 1, 2, 3, 4, 5. Remember, after you declared it, you cannot change it again. It will stay these values, or it will stay only 4 values that you can assign. Obviously, I can go and change it there afterwards, but after I had this one line in my coding, afterwards I cannot change the size. It will stay that specific size. Now let's just quickly have a look at the enhanced for loop. So there's a better for loop to do this. And this for loop, let me just add a system.out.println here so that you can see a little space between the two. Okay, so we're going to have another for loop here, and the enhanced for loop will basically be something where we declare a value or variable there that's called value, or whatever you want to call it, and then we pass in numbers, or well, you can use either numbers, this array if you want to print that one out, or this one. So let's print out the top one, which will just have 10, 15, 20, and 25. So this is the enhanced for loop then, and I'm going to have a system.out.println there, but instead now of printing out numbers I, there's no I in this for loop. So what we print out is that variable called val. So basically what happens in this for loop, it will take, you can see there's the name of the array, and there's a variable. So this variable val will, when the first time the loop runs, it's going to get numbers 0 into val, and then we print it out. Second time the loop runs, numbers 1 will be saved into value, and then we print out the value. Then the next time it runs, numbers 2 will be saved. Then numbers 3 will be saved and print out to the screen. Okay, so if we run this quickly, you can see there's the space between the two, but you can see that the bottom one is 10, 15, 20, and 25, which is this one that we printed out, numbers. We can also say, let's print out numbers 2 there, run it again, and you can see the 2 for loops will now do exactly the same thing. 10, 15, 20, 25, and 30. In this video, we will see how we can compare two arrays to see if two arrays are exactly the same thing. So in this case, you can see I've declared two arrays, numbers 1 and numbers 2, and you can see that they've got exactly the same values at the same positions. Okay, so in this case, we could go and say if numbers 1 is the same as numbers 2, and then print out, if they are the same, we're going to print out they are the same. And if they're not the same, we're going to go to the else, and we print out they are not the same. Okay, so let's look at the logic of this one quickly. If we print it out and we run it now, let's just run this one. Otherwise still running the previous example. So if I run this one now, you can see it says they are not the same. So the thing here is you can see the two arrays are exactly the same. It's 2, 4, 6, 8, 10. But when we test using the double equal sign operator there, it will say they are not the same. So remember, the same as with strings, if you try to compare objects with a double equal sign, then it means that you're comparing the memory locations of these two objects, and that's why you cannot compare using the double equal sign. So essentially, in memory, this object gets created somewhere, and the memory location of it will be stored into numbers 1. This one gets created somewhere, and the memory location of it will be stored in numbers 2. But where they get created is two different places, although the values they have is exactly the same way. So that's why we cannot compare using a double equal sign there, because the double equal sign is comparing whether their memory locations are exactly the same thing. So if I do this now, if I say that one is equal to numbers 1, then it means that I'm essentially copying the memory location of numbers 1 into numbers 2. So if I run this now, it will say they are the same. So why are they now the same? Because I've copied the memory location of the two. Okay, so numbers 1 will point to this, and numbers 2 will point to what number 1 is pointing, and that's also the exact same object. So I'm pointing both now. Numbers 1 and numbers 2 is now essentially pointing to the exact same object. So if I change something in numbers 2 or change something in numbers 1, it will go and make the change to the same array. Just go back and get back to that value. Right, so there we've got the two arrays again. So this is the wrong way of doing it. You cannot compare two arrays by using the double equal sign. So how then do we compare two arrays? So in order to do this, I'm going to use a Boolean variable, and I'm going to start this, or call it arrays equal. And let's set this one to true. So we're going to assume that the two are true. Unless we can prove otherwise, then we'll set the value to false. And I'm also going to need a counter there, or a variable, my loop control variable, where we're going to use later on to test for the values. Okay, so I'll need two variables, arrays equal, and then an index value to basically check every value inside of the arrays. Right, so step number 1 is, let's test if the two arrays are of the same size, because if this one can only store 3 values and that one can store 5 values, then we already know that the two are not the same. And remember, when we're testing two arrays, you're not going to always see what values are inside of them, because then it's easy to just decide whether they're the same or not. So we first need to go and test then if the length of the two arrays are the same. So in this case, we're going to say if numbers 1 dot length, that will give me, numbers 1 dot length will give me 1, 2, 3, 4, 5. That will give me a length of 5. If numbers dot length is the same as numbers 2 dot length. Okay, so in this case, we're testing whether the two lengths of the arrays are the same. But because we've got this arrays equal variable to true, let's make this test not equal. So if they're not equal, we're going to set arrays equal to false. So this is step number 1. Step number 1, checking whether the two lengths are the same. Now it's going to give us this condition is always false because we've got two hard-coded arrays. But let's say you got this arrays from somewhere else, from a file or wherever, then this is the way you're going to test this. So we check first whether the lengths of the two are the same. If they are the same, then we can carry on. We're going to go to a while loop, and we're going to test for this arrays equal. So if the arrays equal then was set false here, we will never enter this while loop at all. So I'm going to use an AND operator here. So I can step through the array, but also not get into the array if the arrays equal are set to false. Okay, so in this case, I'm going to say while arrays equal is basically true, and also the I is less than one of the length of the two arrays. So I'm going to say numbers 1 dot length, because at this stage, if arrays equal is still true and it enters the loop, we also know that numbers 1 dot length and numbers 2 dot length is exactly the same. So whether you use numbers 1 dot length here or numbers 2 dot length, it's the exact same thing. So let's look at the loop control variable here. You can see there we set the index value to 0. So that's where we're going to start in the arrays to compare values. So what we want to do in this while loop now is to compare, to check, is the 2 equal to the 2? Is the 4 equal to the 4? Is the 6 equal to the 6? And so forth. So we're comparing positions here, or index values. So I'm going to start the index off at 0. And then I'm going to test to make sure it's less than numbers.length. This is essentially the same that we're doing in this for loop here in the previous video. We start at 0 and we go up until numbers 2.length. So this is also what we're doing here. We start at 0 and we go to I less than numbers.length. And then somewhere at the bottom, we must say I++. So then you can see we're essentially doing the same as this for loop that says we start at 0, we test for that value, and then we increment again. And that's exactly what we did here. We're just using a while loop. And now why am I using the while loop? Because I also need to test for this array equal. So this while loop will run while array equal in the first place is still set to true. If it's false, it will never enter this while loop because of the AND operator there. The AND operator says both sides must be true. So this must still be true. It's still equal. And at the same time, it must be less than the length of the array. Okay, so what do we do then inside of this while loop? I'm just going to do a simple test there to say if numbers, let's start with 1 there, and then we're going to go to that specific, numbers 1, go to that specific index value and test both of them. So obviously the index is going to start at 0. So I'm testing now if numbers 1's value is not equal to numbers 2 at the same index. And if they're not the same at that specific positions, we will set arrays equal to false again. And then this will also cause the array to stop then, because then the next time not the array, the while loop to stop. When it goes back to the while loop and it tests for array equal, it will see it's false now and stop the loop from executing. So this while loop then, it enters while the arrays equal is still true, and it runs through every element. So it's going to start at 0 and compare numbers at position 0, numbers 1 at position 0, if it's the same or not the same as numbers 2 at position 0. So if the 2 is not the same as the 2, we'll set arrays equal to false. Then the loop runs again. If the 4 is not equal to the 4, we will set it to false. If the 6 is not equals to the 6 and 8 and 8 and 10 and 10, we're going to compare them the whole time. And if just one of these values are not the same, we set arrays equal to false, and it will exit this loop. And then at the end of the loop, we can just go and test this arrays equal variable. So I'm going to say if arrays equal, and remember by saying if arrays equal, it's essentially the same as saying equals true there. But because it already gives you a true or a false value, you don't need to do that. So I'm going to say if arrays equal, I'm going to print out they are the same. And the else there will be when they're not the same. So there's something wrong there. They are definitely not the same. We're going to print out they are not the same. So let's run this quickly. And after running it, you can see then that it says they are the same. And obviously they are the same. We've got the values there. So let's just change one of them there. And I'm going to set that one to a 5, which will make them not the same. So the first test, you can see there they are not the same printed out. The first test there of checking whether the lengths are the same will be true. So it will enter the while loop, check first the 2's, see it's the same. But when it checks the 4 and the 5 there, it will see, they are not the same. So we're going to set arrays equal to false. When it tries to enter the loop again, that part is false. The loop will exit. And then this one will not be true. So it will go to the else part and that will print out they are not the same. So obviously if you've got two arrays there and the two arrays are are not sorted, you will need to sort them first before doing this specific test. But this is how you can compare two arrays to see if the two values are the same or not. In this video, we're going to see another useful operation, and that is to copy two arrays, or copy one array into another array. So let's say we've got this array. We're going to say integer array, and call it array 1, equals, and let's initialize it with a few values. So I'm going to say 2, 4, 6, 8, and 10 again, like the previous example. And now we've got an array with values 2, 4, 6, 8, 10. So it's of size 1, 2, 3, 4, 5 again. That's the size 5. And we've got the values 2, 4, 6, 8, 10 in positions 0, 1, 2, 3, and 4. Now let's declare a second array, and we want to have that array have the exact same values as the one at the top. So you agree that I can just say array 1, or can we? If you remember, when comparing arrays, we talked about memory locations here. So if I say int array 2 equals array 1, what am I copying? Am I copying the values there? Or am I just saying that array 1 and array 2 should point to the exact same object? I didn't make a copy of the object, I'm pointing to the exact same object. So this is a way of not copying two arrays. And let me just show you when we print this out. So let's say system out print line. Well, let's, instead of just having a print line method, let's just create our own method quickly here. So I'm going to say public static void, and let's call this one print array. And for this print array, I'm going to pass in, and now we can just quickly have a look at methods also when we're passing in array. So we can say int array and call this one, let's just call it array there. And then we're going to take this array, the value that was passed in the array, and we print it out. So you remember that enhanced for loop, where we just get the value from the specific array that was passed in, and it will print out those values for us. So I'm going to say system out print line, and I will just print out the value there. So now by calling this method print array, and I pass in an array of type int, it will go and say, well, let's take from this array position 0 and place it into value, and then we print it out. The next time it runs, it will take position 1 of the array and place it into value, and so forth. That's just the enhanced for loop. So now, if I want to print out my array, I can just call print array and pass in, let's pass in array 1 there. And then let's use a system out print line to put a gap between the two printouts. And then I'm going to use the same method again, and let's print out array 2 now. So if we do that, let's run it from here. So you'll see the values are exactly the same. It's 2, 4, 6, 8, 10 and 2, 4, 6, 8, 10. It's because essentially these two are pointing to the exact same array. So let's say I'm going to say array 1 at position, let's say 1, should not be, you can see that array 1, this one at position 1 is the 4. So let's change the 4 to a 5 there and see how it prints out now. So if I run this now, array 1 should now be a 5 at position 1. So let's see the printout. You can see, yeah, it changed to a 5. But look at the bottom one, it also changed to a 5. So this is again just confirming what I said, that both array 1 and array 2 is pointing to the exact same object. So if I change something in array 1, it will be essentially changed for array 2 as well. And that's not what we want. Okay, so this is the way of not copying two arrays. Right, so let's take that away. So step number 1, what we want to do is to create an array of the exact same size as the one we want to copy. So I can see that the size here is 5 by just counting them 1, 2, 3, 4, 5 values. But in coding, normally you can't see the size, and your sizes could be fixed or not. Could be a size of 10 or 15 or whatever that you know, but it can also be a size that you don't know. So the best way of doing this is to say new int, create a new array, but we're going to set this size. Instead of passing in 5 there, if you don't know the size, we'll just passing array1.length. And that will give us the same size. So now the two arrays, there's array 1 already declared and initialized. This one, array 2, is now initialized with a length of 5. And now if I don't set any values, then at position Essentially, this array will now look like this. If I don't set values, it will just have zeros there. 0, 0, 0, 0, 0, 0. That will be how the array looks if I don't assign any value. So this one, after this one line, I will have 1, 2, 3, 4, 5 zeros saved in the array. Okay, now we get to step number 2. After setting the array the exact same size as that one, we can now use a for loop. So I'm going to use a normal for loop. There you've got the enhanced one. So I'm just going to use a normal for loop here. So integer I equals 0, I less than, and I can take array 1 or array 2 because they are now of the same length. But let's just take array 1, and then we need to increment using I++ to run through every element. So essentially what we want to do for step number 2 is to take every single value of array 1 and place it into this exact same position in array 2. So we're going to say array 2 at that specific position should be what array 1 is at that same position, which we call I. So now after this for loop, let's just print out these two arrays again. So I'm going to print out array 1. Let's say array 1 there. I'm going to have a simple system out print line to just separate the two with one line. And let's print out array 2 the same way again. So if I run this, obviously it's the same as the previous example. Both will have the 2, 4, 6, 8, 10. But now the difference is I can now go to array 1 and go to, let's say, position 1 now and change the 4 there to a 5. And let's run this again, and you can see then that array 1's 4 has been changed, but not the one for array 2. And you can see there, the 4 has been changed to a 5, but that one is still a 4. And in this way, you can see that the two arrays are not pointing to the same object or the same array. We are working with different arrays. In this video, we will see how we can get the highest and the lowest value in an array. Okay, so in this array, we've declared integer numbers equals 2, 6, 10, 12, 15, 17, 1. So we can check this values. You can see the last one is the lowest one actually. So there's the highest value, 17, and the lowest one will be the 1. But let's say it's an array that you won't see in front of you. So you need to be able to do this in coding to run through every value and check the value and get the lowest or the highest value. So let's start with the highest quickly, and basically the logic behind it both works exactly the same way. So in order for me to get the highest value, I'm going to declare a variable called highest, and you can see it's the same type as the array, in this case an integer. And I'm going to set numbers at position 0 to the highest value. So I'm going to assume 2 here, or the value in that position, not necessarily a 2. In this case, it is a 2. So the 2 will basically then be set to the highest value. And now I can use a for loop, and I'm going to start the I now at 1. Because the reason for that is to check highest, which is 2, with the 2 itself there doesn't make sense. So instead of starting the loop at 0, I will start comparing from the 6. So I'm going to take the first value as being the highest. Then I'm going to check, is 6 higher than this highest number that I had, which is the 2? And yes, it is. So I will change or put the 6 into highest. And then I'm going to compare the 6 with the 10 and say, okay, 10 is now higher than 6. So I'm going to put the 6 into highest. And then I'm going to put the 12 into highest, and then to 15 into highest. And at the end, we're going to say 17 should be placed in highest. And when I compare the 17 with the 1, I will not replace it, and you will have the highest value. Okay, so essentially, same thing. We're going to go to numbers dot length there, which will give me the length, and then I++. Okay, so this is very important. This for loop, we start at 1. You can start it at 0, but it's senseless to actually compare the 2 with the 2 itself. Okay, so we're going to start at I equals 1, and then what we do inside of this loop is just to go and compare if numbers at position I is greater than the highest value that we saved, then that one which is greater than the highest should become the highest. So we're going to say equals numbers at position I. And now after this, it will run through every element, check every element with what you saved in highest. If it's greater than the one that you saved in highest, then we will save it in highest again before we compare the rest. So this is the way how you compare to get the highest value in your specific array. So let's just print out the highest value. The highest value is and let's print out the variable there called highest. So let's change, or let's run this one quickly. We'll actually run it from here. So you can see there, still running the other one. Let's run it from here. It will say the highest value is 17. So the highest value, 17, is that correct? Yes, it is. Let's change that 10 there to a 20. So it will then tell us, well, the highest value is 20. So it doesn't matter which value you put there or which position you put the highest value, it will pick up the highest value. Now the exact same thing for the lowest one. Let's use the same array again, numbers. And now instead of declaring highest there, we're going to declare lowest. And we're going to set the lowest to numbers at position 0. So you can see it's essentially doing the same thing. It's just another variable there. So now we use the same for loop again, also integer I starting from 1, I less than numbers.length, same as the other for loop, exactly the same way. And now instead of having the if statement where I'm comparing where numbers is higher than highest, I'll just compare saying where numbers is less than the lowest. So we're going to say if numbers at the specific position is less than lowest, then lowest should get this new numbers at position I. So it's essentially saying the same thing there, but now I'm comparing for lower than lowest instead of higher than highest. Okay, and then lowest will get the new value, and we can print it out again by just saying system out print line, the lowest value is, and then we print out the variable called lowest. Okay, so if we run this again, we'll get the highest and the lowest value. You can see the highest value there is 20 and the lowest value is 1. Now let's go back to the array, and you can see there that the lowest value is in fact a 1 and the highest one is 20. So let's just change it again. Let's make this one a 35 and we make this one a -1 and run it again. And you'll see that your new values will be 35 and -1. Okay, so this is getting the highest and the lowest values from an array. Another very useful calculation that we can use on arrays is to get the sum and the average of values. So obviously by getting the average of a value you need the sum, because the average would be the sum of all values, divided by the number of values. That's essentially the average. So in order for you to get the average, you need to get the sum of all the values. And the sum of all the values divided by the number of values will give you your average. Okay, so now in this case, let's just take it easy values 1, 2, and 3, and we're going to work out what is the sum of these divided by the number of to get the average. So this one is easy. It's 3 plus 2 is 5 plus 1 is 6. 6 divided by 3 values will give you an average of 2. So now, in order for us to work out the sum here, we will need a sum variable. So I'm going to say sum equals 0, just to start off the sum at 0, and then I'm going to add to the sum the 1, the 2, and the 3 to get the sum of all. So I'm going to use the for loop again, integer I equals 0, because now we're going to start at, and we want to read every single value. So I'm going to start at 0, I less than values, that's the name of the array, dot length, and that will give me a loop that will go through every single element in that array. And now every time we run through the array, we want to add to the sum variable. So I will say sum equals sum plus the value that we're going to read from the array. So it will be values at the specific position called I. So what we're going to do, the first time the loop runs, values I will return there the 1 because I will be at 0. So the 1 will be taken as 0, what it is at the beginning, plus 1, and that will be saved to sum. So now sum will be 1. Then when it runs again, values I will be now going to position 1, which is 2. And now the previous value of sum, which was a 1 plus 2, gives me a 3. And then we add the 3. 3 plus 3 gives me 6. So you can see that we have a running total here again, and this running total is called sum. So a shorter way of doing this whole thing will just be to say plus equals values. That's the same as saying sum equals sum plus values I. So now we've got the sum after this for loop. Do we know how many values there are? The values will be, or the number of values will be just the length of the array. So that's easy one. So let's work out the average quickly. So I'm going to say double average equals, now the average will be the sum divided by the number of values. And the number of values will be values.length. Okay, now just remember this again. We've got integer division here because sum is declared as an integer and values.length returns an integer, which means that we've got integer division here again. So if you have integer division, make sure that you cast one of the sides to a double. So let's say the sum in this case is 6. By casting it to a double, it will become 6.0, and then we don't have integer division anymore, where it throws away the decimal part. So now we can print out to the screen the sum is, and then show the sum. And we can also print out the average is, and then just print out the average. Okay, so let's run this quickly and see what's the output. Actually, I should run it from here again. So I'm going to run it there. Let's just run it quickly and see what's the output there. And you can see there that the sum is 6. 3 plus 2 plus 1 equals 6. And the average is 2. So it's 6 divided by 3, which will give you an average of 2. And this is how you work out the sum and the average. Right, in this video, we're going to see how we can read data from a file into an array. So for this, let's just create a quick file there. So you're going to click on your top project, and you're going to right click and say new file. So go to new file and you give your file a name. So I'm just going to call my file values.txt and say OK, and you can see that it creates this values.txt for you. Let's just place a few values there: 10, 20, 30, 40, 50, 60, 70, 80. So let's just have, we've got 8 now. Let's make it 90, 100, 110. Let's stop at 11 values. Okay, and now if I go to my file, so let's say we want to read from this file and we want to read all of these integers now into our array. So we're going to declare an array, and I'm going to call it values equals new int. And then let's set the size of this array to be 10, because normally you won't know how many values are in a specific file. So when we read data from a file, it's very important that you know that you shouldn't go over the amount of values that you can actually save into your array. We'll do that part now. So you'll see there we've got 11 values, but we can only save 10 of them. Okay, so that's my array. And what I need to do here is to just have some sort of a counter here, because we're not going to use a normal for loop. So I'm going to use a while loop again. So that's going to be my loop control variable starting at I. So the first thing we'll need to do from here is to make a connection to the file. So I'm going to say file, call it file, equals new file. And that file name will then be saved as a text, or will be passed in as text there. And the file name is called values.txt. So I'm going to say values.txt. That's the text file I want to read from now. So we can use that simple if statement that says if this file exists, if the file exists, then we can start reading from it. So if it exists, then I can make a connection to the scanner class again. So I'm going to say scanner input file equals new scanner. Now instead of reading from the keyboard using system.in, we will pass in the file object. Now because this can throw an exception called the file not found exception, we need to have at the top of our method say throws IO exception. Okay, so there we've got throws IO exception. There we've got our integer array. We start at position 0, which we'll do now in the loop. We make a connection to the file, or try to make a connection to the file. If the file exists, we pass that file to the scanner class so that we can start reading from it. Now the while loop. Let's get into the while loop quickly. And you remember that there's a method called hasNext that will help me to read through every element in the file, but not read over the amount of elements that I actually have. So there's 11 lines in this file, or 11 integer values. I cannot read the 12th one. It will throw me an exception or an error. So it's very important here that you use the input file.hasNext method. But now we've got another limitation. We've got a limitation where we don't know the size of the actual values that we're going to have here. So there could be 1,000 values in this file. We won't know. Okay, unless you know the file, obviously. But if you don't know the size of the values or the number of values in your file, and you need to declare an array, so you'll set it to a specific size. In this case, let's say you know that the file there will be more than 1,000 values there, and so let's say you can make it 2,000 then there, which will make it 2,000 values that you can save into that array. But in this example, let's keep it at 10 because now we know there's 11 there, so I cannot read all of them into the array. Okay, so this is the limitation. Only 10 there, and I need to also check for the end of the file. Okay, so that's the two limitations we need to check for. So then the AND operator here, so this one checks for that we don't go over the limit of the file, and the second part here is that we do not go over the limit of your array. So in this case, we're going to say I less than, and again the name of the array, which is called values.length. So we don't go over the length of your specific array. So both of them needs to be true for us to keep reading from the file or keep saving to the array. Okay, so now in this case, we're just going to say values at the specific position I should be whatever we read from the file. So we're going to say input file dot next int, because there's integers in the file. I want to read integers. So this part there is reading an integer from the file. So the first time it runs, it's going to read the 10. It's going to place the 10 into values I, so which will be I starting off at 0, which will get the first index value. Right, so after this one line, we will then basically get every single line in the file, read from it, and placing it into the position in the array. But you'll see somewhere along the line, we'll get to the length of 10, and there's still values to read there. But because of the AND operator there, both sides needs to be true for it to actually keep on reading from the file and placing in values. So whenever you're at the end of the file or you're at the end of your array, this loop will stop and you cannot enter any more values. Okay, and then just remember to also add your I++. This is your loop control variable, I equals 0. Then we test the loop control variable there, and we increment the loop control variable. So just remember about your loop control variable. After this, we can close our file, input file.close. When you're done working with it, close your file. And now after this while loop, we can print out what we saved into that array. So let's just use the enhanced for loop here again. So I'm going to say integer value, and then use the values array, and we print out every single value there. So we're going to say system out print line, and we print out value. So remember, value is the name of the variable where we save every single value. Okay, so let's run this quickly. And you can see there it printed out. But it printed out from 10 up until 100. You can see we left out the last value there. Why? Because our array can only store 10 values. If I made that one 12, which means our array can store 12 values, then the limitation will come into the file there where it can only read 11 values. So it will show all 11 but still not throw an error for me or an exception for me because we tested that out on the loop. Okay, so you'll remember that after this line, all 12 values is saved as a 0. And then when we try reading from the file, we read actually all 11 values, but the 12th value we didn't read. So that will stay as a 0. Okay, and that's it for arrays and files. Right, so in this part, let's just quickly have a talk about string arrays. Before we start creating an array, I want to quickly create a method here. So I'm going to say public static. And let's say this method will return a string array. And we're going to call this one get names. And this one will basically populate our array for us. Okay, so we're going to do the following. We're going to create a string array here. And we're going to say names equals new string. And we're going to say, let's say the size should be 6 in this case. Now in names, I'm going to say names at position 0 should be, let's say, John. and we're going to say names at position 1 should be Peter. And we'll say names at position 2 should be Paul. We can also say names at position 3, so that's the first 4 now, equals, let's say, Simon. Okay, so let's say we've got these values, John, Peter, Paul, Simon. Let's just add one more there. So names at position 4 equals Chuck. Right, so there we go. We've got 6 spaces to store string objects, and we've got 1, 2, 3, 4, 5 of them saved. So a very important thing to notice here is that after creating this one line, every single index value of mine will contain the special value. So actually in names 5, there will be a special value called null. And null just means there's no object at all linked to that variable. Okay, so that's essentially what will be saved in every single index value after just this one line. All of them will contain a null value. Okay, remember when we were working with integer arrays, all of them contain zeros. So with strings or any other object type, we will get a reference of null there. Okay, so this is very important. And notice here, we've only set 0, 1, 2, 3 up until 4, where actually it goes to position 5. And then we're going to say return this names array of ours. Okay, so this return statement then returns the array called names with the first 5 values set, and the last value is not set. Okay, so let's create our array at the top. Let's call it names as well, equals, and now instead of assigning my array, I can actually just go and call get names, which will create a new array for me of size 6 with a few values set, and then return it to me. Okay, so now this names variable as well as this names variable there will point to the exact same array. Now let's print out this one quickly. So I'm going to say for integer I equals 0, I less than names.length, same way as we do with the integers, I++. Now let's say I want to print out now every element in this array. So if I print this out, we can just say names and at a specific value or a specific index value of I. Okay, so that will basically print out every element in that array for me. Let's just see the printout there, and there you can see clearly. There's the array. It's John, Peter, Paul, Simon, Chuck, but you can see the last value there is in fact a null. Now let's say that we do not want to print out just the names, but I want to go to a name and I want to print out just a specific character. So I can use the character at method, and the character at method also needs an index. So let's just say a 0 there, which means that names I, if the loop runs for the first time, position 0, then it's names 0, which will be John. I'm going to go to John and I'm going to get the character at position 0. So it will actually just return the J and the P and the P and the S and the C. Okay, so let's run this one quickly. If I run this now, you can see a very, very nice exception error message that we get there. And we call that a null pointer exception. So the problem here is the first 5 values there, to get the character position at position 0 is easy because we've got values there. But the last one is at position 5 is a null value. And you cannot get on a null value a character at position 0 because it's not a string. It's a special value called null. So we can't do that. So this is very important to realize when you're working with strings, that you first need to test whether that value is not a null value. If you want to do some calculations or use some operators on your specific string or whatever object you're using. So in this case, I'm just going to say if names at that specific position where we are in the loop is not equal to null, then I know I can get these values. So I'm just going to cut this one. You can use Control X to cut it and then paste again. Right, there we go. So now instead of just printing out, I'm just first going to test if it's not a null value. Yes, then print it out for me. So now if we print it out again, you'll see that error is gone and we've we only have the first characters, JPPSC, of those that's not null. And now it works 100%. So you can see that we only printed out 1, 2, 3, 4, 5. The sixth one is ignored because that one will have a null value. Right, in this video, we're going to quickly have a look at the ArrayList class in Java. So let me just read through these comments here. Standard Java arrays are of fixed length. We've seen that in all of our examples. When you set a length to it, you cannot change that length. That will be the number of elements that your specific array will have. After arrays are created, they cannot grow or shrink, which means that you must know in advance how many elements in an array will hold. So you need to decide how many numbers or string values or whatever your specific array must hold. Array lists are created with an initial size, and that's normally, I think, a size of 10. And when the size is exceeded, the collection is automatically enlarged, and when objects are removed, the array may always also be shrunk. So similar to an array list allows object storage, but unlike an array list object automatically expands when a new item is added and automatically shrinks when items are removed. So let's just see how we declare an array list. So you can see you start typing array list there, and it will pick it up in the java.util package. So let's just work with strings. Remember, you can only work with object types. So if you want to use integers, there's a class called integer, which you can use, but you cannot use the primitive data types, for example, int there. So if you want to use integers, you'll use the integer class there. Okay, so that's just the class that wraps itself around the normal primitive data type of integer. So for this example, we're going to use strings. So I'm going to say string names equals new array list, and that's all you need to do. That array list will now basically work exactly the same as a normal array, but the difference here is this one will shrink and make itself bigger as you add or remove values. Okay, so in this case, in order to add something, remember in our previous examples, what we did was to say, go to names at position 0 and go and add John. So now the difference here is not going to a specific index value like this using the block brackets there, but we'll say names. We're going to use some variables, some methods there, and we're going to use the add method to add something to it. So if I want to add James there, that is basically the same as saying names at position 0 equals John. So if I just say names.add James, then it will add at position 0 the value James at this case. If I say names.add, in the sequence that I'm adding my values, it will go into the specific index values. So if I say Peter there, Peter will then go into index position 2. Sorry, this one will be 0, that one will be 1. So let's just add a few more. I'm going to say names.add. Let's add those other values also. Let's use John again. And then go to names.add, and we add Jake again. Okay, so now you can see this one will obviously go to position 2, that one will go to position 3, and I can add as many values as I want here, and the array list will automatically increase its size if it's going over the default size, and it will shrink if you start removing elements. So you can only have the number of values that you've actually got in it. So in this case, it's James, Peter, John, and Jake that's inside of my array. Then or my array list. Now I can also add using a different method there, where I can say, go to index number 4 and add to me the following value called Paul. So there's another way of adding where you can say, put it in a specific position. That's like doing the same thing here. Go to name 0 and put John there. Now we're just saying, go to index number 4 and then place Paul there, and you can see that will obviously then be position number 4. So if there's already something in position number 4, it will just move the rest down. So if I said this names.add 3 Paul, it means Paul will go in between John and Jake, and that one will now become 4, this one will become 3. So it will shift up the rest if you add it at a specific position. But if you use this one to say .set, that will replace a value at a specific position. So let's say the index will be 1. I'm going to replace what's currently saved as Peter there, and let's change that to Peters, which means that Peter will not exist anymore, but it will be replaced by Peters. Then you can also use another method called remove, which will remove an object at a specific position. So if I say remove 0 there, it will basically remove James totally from my array list, and it will not be there anymore. So let's see how we can create a for loop now to run through every element. The same thing again. I'm going to say integer I equals 0. And now remember your for loop. You can see the for loop here. We started at 0, and then we said I less than names.length. So now we're going to say I less than. So it's again names, but you can't use the length method here. There's no length, or no, sorry, not length method, a length variable there. There's no length, which means that we need to use something else called size. So essentially size is saying the same as what we used with length there. But remember, size will actually give you the exact number of values that's currently stored, not the size of your array list. It's the size of the values that's currently stored. So it's essentially doing the same as what we had with our array. There we go. Right, so after this for loop, or inside of this for loop now, how do we print it out? So inside of the for loop, we just printed out names I, and that prints out the specific value. So now we can't say names I with an array list, the same as we couldn't have said names with the block brackets 0 there. So how do we print out values here? Let's just use a system out print line, and I'm going to say names. So instead of saying names I with an array, we're going to say names.get, and then you indicate the index value. So that's essentially doing the same thing. So saying get I will then get that specific object at that position and print it out. So if we run this quickly, let's run this one from there. You can see that we've got first one, Peters. Remember, we changed it there, set 1 to Peters. So the one at position 1 should be Peters, then John, then Paul. Why Paul? Because you can see that we basically removed at position 0, we removed James there. So now obviously Peters will move up. Peters will be first, then John. You can see that we placed Paul into position 3, so then it will be Paul, and then Jake, and then we're done. And that is basically setting the value. So if we did not change anything here, so let's just keep this at... let's just not use the set method there, and we use add there. So then if we do not remove also anything there, let's just take it away, then this one will be 1, 2, that one will be at position 3, this one will be 4, and this one will be at position 5. So if we run this one now, you can see that when we go down, it will be James, Peter, John, Jake, Paul, and Peters. James, Peter, John, Jake, Paul, and Peters. Okay, so with the previous examples, we just moved the things around, removed some of them, but that's basically how it gets printed out. So this is the basics of the array list. In videos to come, we'll use the array list a lot, and that's it for the array list. In our world, we have classes and objects for those classes. Everything in our world is considered to be an object. For example, people are objects, animals are objects too, minerals are objects. Everything in the world is an object. But what about classes? In our world, we have to differentiate between objects that we are living with. So we must understand that there are classifications, and this is how they get the name and the concept of a class, classification. So we must understand that there are classifications for all of those objects. In our world, we have classifications for objects, and every object must be from some classification. So a class is a way for describing some properties and functionalities or behaviors of a group of objects. In other words, the class is considered to be a template or a blueprint for some objects. Let's look at a house as an example. We can identify some properties that will make a house a house. Just as an example, let us try and define 4 properties. A house will have windows, doors, a roof, and walls. So we can create properties for the house classification that will indicate the number of windows and doors, as well as the type of the roof and the type of the walls for the house. Ultimately, we can then take that blueprint or classification and build as many different objects or houses of that same classification called house. Look at some other house objects we can create. You can clearly see that all house objects will have the same properties, but the value of the properties will be different. We can then go to Java and create the classification called house and have the following properties as variables in the class. As in this picture, you can have some very weird objects of classification house, as long as they have the same properties. Let's go to IntelliJ. Right, back in IntelliJ, I've created a new project called Classes and Objects Example. In my source folder, I created a new package, and the package name is com.example.classes, and I've created one Java file, and this Java file will be my driver class where my main method is. So this is where my application will start. So now let's look at the concept of classes in Java. So in order for me to create a new class, I'm going to go to my package and I'm going to say new Java class. So on the package, so just right click on your package and then say new Java class. So then when we create a new class, you give your class a name, and normally we make our classes all capital letters or uppercase letters of the alphabet. You start with a capital, and then each subsequent word we will also capitalize it. So in our example, we talked about the house object or the house class. So in this case, the house class we said should have 4 properties: number of windows, number of doors, type of roof, and type of wall. So let's quickly create them, and I think you will agree with me that the number of windows as well as the number of doors we can take as normal integers, whereas the type of roof and the type of wall we will look at strings or normal text. So I'm going to say private int number of windows, and I'll also have a private, and I'll explain the private now, private int number of doors, and then I'll also have private string now for the type, sorry, private spelling there, private string, and that will be the type of roof, and we'll also have a private string type of wall. So now when we create a new house object, this object will have the number of windows, the number of doors, the type of the roof, and the type of the wall. Now it's just good programming principle in Java to say that let's go in every class that we create all fields or properties must be private, and then we'll have methods to access them or to change them. So the private keyword here as well as the public keyword there, we call them access specifiers. So that's how do we have access, or how does other classes have access to this class. So in this case, if one of my variables, in this case the properties or the variables, or one of my methods is listed as private, then we will only have access to these members, in this case these variables, in this class. So the private access specifier says nowhere else can you use this variable but in this class where you defined it. Now the class is public, which means that we can use this class in any package outside of this package or inside of this package. Any class will have access to it. It's basically publicly available. So the class will be publicly available, but the variables inside it will only be available in the class that we're currently working with. So you'll see the next part that we'll do now is providing the methods, and all of the methods should be public, which means that the class as well as the methods in the class will be available publicly everywhere. So let's start off with some methods that we can have inside of a class. So when we create an object of this class, the object will have these 4 values. So every object that you create will have these exact 4 values, but it could be unique values stored inside of them. So in order for us to create this object, we need what we call a constructor. Constructors will always be public, and it will never return a value, not even void. So you'll say public, and then the constructor will have the exact same name as the class. So this could be the method header, for a constructor. So the constructor is the method in your class that's got the same name as your class. And then normally what a constructor does, it sets those 4 values that you've got at the top. If you've got 10 at the top, normally it sets all 10 of them. But we have specific examples where we do not set all of them inside of the constructor, but we can later on use setter methods to set them. So in this case, if you do not provide a constructor at all, so let's say you've got an empty class like this, and you create a new object of type house, then they will automatically, or Java will automatically create a constructor for you. And the constructor will look like the one that we're going to build now. So basically the default constructor, that's the one that Java will provide for you automatically if you do not create a constructor at all. And the default constructor is a constructor that does not accept any arguments like the one we've just defined there. And then basically what it will do, it will make the number of doors equal to 0. So all of your number variables will be set to 0, and all of your object type variables will be set to null. Also your Boolean variables will be set to false. So let's set number of doors and number of windows to 0. We will also set the type of roof to null, and we'll set the type of wall to null. So this is basically what your default constructor will look like. So you can also then basically provide your own version of a default constructor, which we call a no argument constructor. So it's a constructor that accepts no arguments, and then you can set the values to something default there. So this is just an example of how the default constructor of Java would look if we do not provide a constructor at all. So in this case, we provided now a constructor, so the default constructor will not exist, but we'll use the constructor that we created here. Now let's look at another constructor that we can create, and this is a constructor that's used often. And you can see then if I try to create the exact same method again, we'll have a problem. But in Java it is allowed that you can have 2 methods with the exact same name, but different parameter types or parameter lists. So in this case, we're going to say we're going to accept the number of windows in this method, number of windows. The second argument, we will also accept the number of doors. As the third argument, we'll accept the type of the roof. And as the last argument there, we will accept the type of the wall. So you'll see this is also a constructor because it's got the same name as the class. That one accepts nothing, and this one accepts an int, string, string. So it's 2 different constructors. So if you've got 2 methods with the exact same name, but different parameter types or different parameter lists, then Java will allow this, and this is called method overloading. So it's the same method name, but different parameter lists. Then we've got method overloading. So in this case, I'm overloading the constructor here, and the constructor, remember the constructor method, is the method that will construct your object. So in this case, we can then set number of windows and number of doors not to 0, but to the values that was passed in here. So I'm going to say number of windows, let's start with doors first, equals number of doors that was passed there. But now you can see this is a bit confusing, because am I talking now about number of doors there, or am I talking of the number of doors there? So just to refer to the object that we will be building here, I'm going to refer to it as using the this keyword. So this dot number of doors refer to the object that will be created, that object's number of doors. And then this number of doors will refer to the one that was passed in to the method. So if you see, if I click on that one, you can see it's selected at the top. Where if I click on this one, it's selected only here. So we're going to set the number of doors to the number of doors, and we're going to say, using the this keyword again, this dot number of windows should be the number of windows that was passed in there. And there you can see the number of windows was passed in. So I'm creating the object now by setting the different properties. All right, so let's set the type of roof as well. So we're going to say this dot type of roof should be the type of roof that was passed in there, and it's this one there. Then also we can say this dot type of wall should be the type of wall that was passed in. So this is then creating a new object of type house or classification house by accepting the number of windows, the number of doors, the type of the roof, and the type of the wall, and then taking all four of those values and setting those values to my variables for my object at the top. So there's two types of constructors then there. There's a no argument constructor that will just set some default values, or you can have a parameterized constructor that accepts, in this case, 4 parameters there of type int, string, and string, and then we set those values as the properties for my new house object. So in your class, there must always be a constructor that constructs your object. So in this case, there's no default constructor here because the default constructor will only be supplied when you do not supply a constructor at all. And the default constructor will look exactly like this one. But now we've provided one, so there's no default constructor. This we call then the no argument constructor, and I can choose what to set the values to. And then the second constructor here, which is an overloaded constructor now, 2 methods having the same name but different parameter lists, method overloading. So this constructor accepts the 4 values and set them to my object. Now let's look at a few other handy methods that we can use inside of a class, and that we call getter methods and setter methods. So because we defined all of our fields private there, we need to have a public method to change or to get these values out of the object. So in this case, let's start with the getter methods. So the getter methods is basically a method that just returns the value for the specific property. So I'm going to start off, and all of these methods must be public. I'm going to start off with the first one, which is the number of windows. So because number of windows is of type int, that's exactly the value that we will return. We will be returning an integer. And then we'll also start with, and you can see it gives you an indication of how it could look like. And this is actually the one that I want you to use also. So it's, let's say the first one, number of windows. So you'll say get number of windows. Now look at the spelling. We'll normally start off with a get or lowercase, and then the first value or the first letter of the alphabet of your variable will be capitalized, and then each subsequent word. So I'm going to use it as it is here. This is the correct way of doing it. So I'm going to say public int get number of windows, and then just have nothing in the brackets. Okay, so we're going to say then public int get number of windows. So on my object, I can go and call get number of windows, and it will return the number of windows as I set it. Okay, so in this case, we will just say return number of windows. So it will return the field number of windows. So to get the rest of your getters, it's actually very easy in IntelliJ. So you're going to say right click there, generate, and you're going to say getter. And now you can see there's 3 getters left. There's a getter left for the number of doors, the type of roof, and the type of wall. And all of them work exactly the same way. So you're just going to say OK there, and you can see there's my getter methods. So it just looks a bit different, the layout for your methods, but for the rest it's still the same. Okay, so there's get number of windows that will return the number of windows, which is the first one. There will be a get number of doors, which will return the number of doors. There's also a get type of roof, and you can see now the return type here is of type string because the type of roof was declared as a string. So it's string type of roof, and that's what this getter method will return back. Also for the type of wall, we'll return a string, but we'll get back the type of wall as a string there. Right, so those are the getter methods, and normally my getter method starts with a get, but remember your name of your method is up to you as programmer. You can choose what your method's name should be, but it's good Java convention to basically use the methods as it is generated here. So you can see it starts with the word get, and then afterwards the first letter of your variable will be capitalized, and then all the subsequent words will also be, or the start of the subsequent words will also be capitalized. So let's start with the setters next. So this is how you get a value. But what if you want to change one of these values inside of an object? For that we use the mutator methods or the setter methods. So setter methods look something like this. Public void, we don't return something because we're changing it. So we're going to say public void, then you start with set, and you can already see it gives you those 4 values of what we've got in this class. So let's start with number of windows. So I'll say set, and then you can see number of windows. So I'll start the N again capitalized. So it's set number of windows, it gives it to you. And then normally what you accept as a value in the parameter list there will be what you want to set your new number of windows to. Now because the number of windows is an integer there, I will use an integer to be set, and you can call the value or the variable there exactly what you want to call it. So we can also call it number of windows if we want to. So we're setting the number of windows. So we're going to take the object that was created. This number of windows will be set to the number of windows that was passed in. So I'm going to say number of windows there. So you can see your setter methods work a lot like your constructor, and what your constructor is doing, it's taking in a specific value and setting that value to the object's value. So we're basically just having them in separate methods now. Separate setter methods. So I can then go again for the rest of them. I can just right click and say generate. I want the setters this time. Choose the 3 remaining setters and say OK. And you can see it was generated exactly the same way as I did the very first one. So let's just quickly look at them. There's set number of windows. It accepts the number of windows. Set that number of windows to the number of windows of my object. And then you'll see set number of doors will accept the number of doors as an integer and set my number of doors of the object to the number of doors that was passed in. Also set type of roof. Type of roof is actually a string, so we're going to accept a string as well, type of roof, and then this dot type of roof, which is the object, should be set to the type of roof that was actually passed in. And then the type of wall, which is also a string, will be set to the type of wall of my object. So these are all the setters and the getters methods, as well as the constructors. And that's basically a basic class in Java and how you can create a basic class. So now this class has been created. It's called house, classification house. How do we classify a house? By these 4 properties. And then the main thing of these 4 properties is we need to be able to create an object using those 4 properties. We also need to get every single value of that properties, and also you need to be able to change every single property. And then you've got a basic class. So very important here then, you must have private fields and then public methods to set, change, or to get back the values. So you will not directly refer to the variables at the top or your properties for your class, but you'll refer to the properties by using either a getter or a setter method, or you can use a constructor to set the values right at the start. So remember, always private fields, but we have public methods to access or change those fields. So let's go to the driver class now and see how we can create a new house object. So there's 2 ways of creating this house object now, because we have 2 constructors. We've got a constructor that accepts nothing, and we've got a constructor that accepts 4 values. So let's start with the one that accepts nothing. So we're going to say house equals new house. So remember, in Java, after the new keyword, you are creating a new object. What gets saved into this house variable now? This house variable will hold the memory location of this house object. Okay, so now the house object was created. So let's just use a simple system out print line there, and we can go on that house object, and we're going to call get, let's say, the number of doors, just to print it out to see if it works. So let's run this quickly. And you can see the number of doors will be 0. Why is it 0? Because we said with the constructor that accepts nothing, we will set the number of doors to 0, the number of windows to 0, the type of roof and the type of wall, both of them should go to a null. So on the object, which is, well, basically the reference variable holds a link to the object or an address to the object. So on that object, I'm calling get the number of doors. And the get number of doors there, where's my getters? Get number of doors will return the number of doors that's currently set in the object. So you can see that using this constructor, we've basically set everything to either 0 or to null or to false if it's a Boolean. So then working with it afterwards, you must go and use one of the setters. So I'm going to say house.set the number of doors, and let's set the number of doors to 10. So now if I print it out, calling get number of doors will then get the value of 10. Right, so there you can see it printed out. Okay, so let's not use it like this. Let's go and add some values inside of this house constructor to set the number of windows, the number of doors, the type of the roof, and the type of the wall. So let's first set the number of windows. So let's say this house object will have 10 windows. The second one, the number of doors. Let's say 2 doors, one at the front, one at the back. The type of roof, let's set the type of roof as tiles. And then the last one is the type of wall. And let's set the type of wall to be of type brick. So let me just make this a bit bigger there. So you can see now we used the constructor that accepts 4 values to create the object. So this object will now have 10 windows, 2 doors, tiles as roof, and brick as the type of wall. Right, so now after this object has been created, we can now go to the house object there and put the dot. And you can see there's all the methods that we've got access to. We've got get number of doors, set number of doors, get number of windows. There will also be a set number of windows somewhere. Let's call it set number of doors, set number of windows, set the type of the roof, and set the type of the wall. We can also have the getters there, which will get the number of doors, get the number of windows, get the type of the roof, or get the type of the wall. So let's just do a few of these methods. I'm going to go and say on the house object, go and let's set the number of doors to 3. So we're changing it from a 2 to a 3. And we'll also set, let's just use 2 of the sets. Let's set the type of wall to be plaster. So instead of having a brick wall there, we will now say the type should be plaster. Now when we print it out to the screen, we can then say, let's print out this whole object by saying house. Let's start off with some string first. This is the house object. And then after that, we print out the details for the house. So let's say number of windows. And then we can go use the concatenation operator there, the plus sign there. And we're going to go to the object house again and use the getters now. So the number of windows will be get number of windows. And that will show me the number of windows. So on a new line again, let's get the number of doors. And the number of doors will also be house.get number of doors. Let's use the next one, and then the number or the type of the roof, type of roof. And then the type of the roof you can get by saying house.get type of roof. And then the last one there, the type of wall. And then we're going to use house.get type of wall. And then if we run this, it should be exactly as we have them there. So remember, the object started off with the number of windows 10, the number of doors 2, the type of the roof tiles, and the type of the wall brick. But we changed and set the number of doors to 3 now instead of 2, and we changed the type of wall to be plaster. So you can see the number of windows will still be 10, we didn't change it. The number of doors will be 3 because we changed it. The type of the roof will still be tiles, we didn't change it, but the type of wall, we changed the type of wall to plaster. And this is then how we print out an object. So we'll look at some other methods in the next videos where we can actually use a better way of printing out the whole information about the object and so forth, but we'll get to that in a later video. In this video, I will talk a bit more about classes and objects. We will talk about copy constructors, the equals method to compare objects of the same class, as well as aggregation. What is a copy constructor? A copy constructor is a constructor that creates a copy of an existing object of the same class. Have a look at this piece of coding. We have 2 fields for the subject class, subject code and subject name. So every subject object will have a subject name and a subject code. Let's have a look at the first constructor. This is the normal constructor. So if we create a new object using this constructor, we set the subject code as TPG10, AB as passed into the constructor. We set the subject name as Technical Programming 1 to create this green subject object in memory. If we then use the copy constructor call to create a new object, we pass in the existing green subject object in order to make a copy of it as the new object. So how do we make a copy of an object? We need to copy all the fields of the object we want to copy to the fields of the new object that will be constructed. So now for our blue object, we set the subject code the same as the subject code of the green passed-in object, and we set the subject name of the blue object to the subject name of the green object. And now we made a copy of the green object. It is very important to realize that although these objects are now identical, they exist in memory at two different locations. The subject variable will hold the memory location of the green object, and the copy of subject variable will hold the memory location of the blue object. So if we have the following statement, if subject with two equal signs copy subject, it means that we are testing to see if the memory locations of the objects are the same. In this example, they exist at two different memory locations, so this if statement will result in a false value, even though the two objects are exactly the same. So how can we then test if two objects of the same class are in fact identical? We need to write the equals method. Your equals method will need to return a Boolean value as we are testing to see if two objects are equal or not. You will also need to pass in a subject object that's an object of the same class to compare this to. It is very important now to realize that by calling this equals method, we have a subject object that calls the method and a subject object that was passed into the method. Our green object in this statement is the object that calls the equals method, and the blue object is the object that was passed into the method. In order to compare objects to see if they are the same, we need to compare all the fields of the one object with all the fields of the other object. So we will compare the subject code of the green object with the subject code of the blue object. The this keyword here refers to the object that called the method. In this case, it's the green object. Then we also compare the subject name of the green object with the subject name of the blue object. Only when all fields of the green object are equal to all of the fields of the blue object will they be exactly the same, and will the equals method return true. Right, so let's look at these concepts quickly in IntelliJ or in the Java coding. So in this project, you can see that I've got a driver class, which has got my main method. I've got an exam paper class, I've got a student class, and a subject class. So we'll get to the exam paper and the subject class, the exam paper and the student class later on. Let's first look at the subject class that we just did. So in the subject class, you can again see that we've got two fields right at the top, and those two fields make up the object. We've got a normal constructor that accepts the subject code and the subject name, and we set the subject code and the subject name to our object's values. So remember here in the constructor that this keyword refers to the object that you're currently constructing. So which means that the one that I'm currently constructing subject code should be the subject code that was passed in, and the one I'm currently creating, that one's subject name will be equal to the one that was passed in. Then if we look at the copy constructor quickly again, the copy constructor is always the same name as the class because it's a constructor. Also no return value, not even void. And then if we go to what it accepts in brackets, it will basically be the same object of the class. So you can see it's the same name as the class, subject, and then you can call your object whatever you want there. In this case, we call it subject again. So now what happens in the copy constructor is that the object that will be made or that's currently being constructed is referred to with the this keyword again. So we're saying the one that you're constructing now, that one's subject code should be the object that was passed in's subject code. And the subject name of the one that you're currently constructing should be the subject name of the object that was passed in. So that's the copy constructor. If we quickly have a look at the equals method again, all equals methods normally, well, most of the time, we return back a Boolean value, either true or false, yes, they're the same, or no, they're not the same. And then we also accept an object of the same class, because that's what the whole idea behind the equals method is, to compare two objects of the same type. So now in this if statement, we basically just say this dot subject name. So remember, with the equals method, there's a calling object and there's an object that was passed in. So if we go to the driver class quickly, you can see that I've created two subjects there. Can you see both of them are exactly the same? So how do we use this equals method? We will say subject1 dot equals subject2. So always there's an object, subject1, that calls the equals method. That's the one with the dot. So it calls the equals method, and then there's an object that was passed in, which is subject2. So if we go back there, the this keyword refers to the one calling the equals method, and then obviously object is the one that was passed in there. So I refer to it by just saying object.subjectName or .subjectCode. So the idea behind the equals method is to compare both fields in the one object with both fields in the other object. So if we look at this quickly, we're saying the calling object's subject name, if it's equal to the object that was passed in's subject name. Now, because subject name and subject name at the top, you can see all of them are strings. Remember that you compare strings with also the string classes equals method. So this equals method here is not referring to our equals method, but it refers to the string class equals method in order to compare two strings. So I'm checking if the calling object's subject name is equal to the one that was passed in subject name. And at the same time, the calling object's subject code is the same as the object that was passed in's subject code. So if both the values are this of the one object is the same as both the values of the other object, then we return true, because then they're exactly the same. The else one will be to return false. So remember that you can do this in only one line of coding. I can remove all of that, and I can just say the return and then add my semicolon there. So whatever this whole Boolean expression returns, I will return as well as the equals method. Okay, and then we've got get the normal getters and setters there. And then one other method that I quickly want to introduce is the toString method. So if you look at this one quickly, in the driver class, we've created two objects there. There's object 1 and object 2, or subject 1 and subject 2. We check if they are the same. They should be the same if we run it now. So let's run it. It should print out they are the same, because they are exactly the same. So you can see they are the same. Now look at this printout at the bottom, this line there. You can see I'm just printing out the object called subject1. And you can see the way it prints out. It gives me basically my package name there, and then my class name inside of the package, and then it's a hash code of the memory location of this object. So it's actually something that doesn't make sense for the user if printed out at all. So what we need to do is to go back to our subject class and override the default toString method that comes with every class. So I'm going to go down to the subject class, and at the bottom I'm going to add a method called public string toString. Now the toString method is used to basically explain what is happening in your specific object. So because we're going to look at in the few next videos that's coming, we're going to have a look at inheritance, and we'll talk a bit more about the add override tag there. But basically what happens here is that we are overriding a toString method of the class that inherits, or the main class of all classes has got a toString method. But that main class of all classes is basically printing out this, and that's not what we want. So we're going to create our own toString method. So it must be exactly like this. It must be public string toString, exactly like that. Then we're overriding it, and then we're going to return a string value now. So instead of printing out the object and it looks like this, whatever you return now is what it will print out there. So I'm going to say return. In my subject, I've got a subject code and a subject name. So let's say subject information. We'll say subject information, and then let's add a new line character there so that we go to a new line. And then on the new line, I'm going to say subject code and display the subject code. Then I'm going to go to a new line again. And then we'll have, then it's a subject name. So we're going to call it subject name and display subject name. And then maybe, I think after that one we can leave it open. Okay, so this is now the toString method. So if we run this again, it's exactly the same coding in the driver class, but we changed some coding in the subject class. So if you run it now, you can see it prints out whatever you type there as the return statement in your toString method. So the toString method is basically a method that describes your object. So normally in the toString method, we will print out all the fields that we have at the top to explain our object. Right, so let's go to the student class. The student class is a class that I've created now, which you can also go and create by just right-clicking on the package and say new Java class. And you create that class called student, and then you can add these two fields. So we've got two fields, a student name and then a student number. So let's first create the constructor. So there's an easier way in IntelliJ to actually generate your constructors. So I'm going to say generate, right click there, then you go down to generate and you say constructor there, and choose the two fields that you want your constructor to actually accept as parameters there. So you can see that we're basically setting those fields again like that we did in the subject class. We're saying student name was passed in, so we change our student name to the student name that was passed in, and our student number to the student number that was passed in. So let's see if we can create a copy constructor quickly. So a copy constructor will be the exact same name as your class. So again, it will be student, but instead of accepting both these values again, we will accept a whole student object. And remember that student object also has got those two values. So it's just another way of passing in values to a constructor. So let's call this one student as well. So how does the copy constructor work again? The object that you will be creating now is referred to as this keyword, or this keyword is referring to it. So we're going to say this.student name should be the student object that was passed in's student name, and the object that you're currently creating's student number should be the student that was passed in's student number. So now we're making a copy of the one that was passed in. All right, so after this one, let's quickly create the equals method. So it's going to be public boolean equals. And remember that the equals method returns a boolean, and also it accepts a student object there. So let's just call it object. And then how does the equals method work again? Let's do a simple if statement first. If this is the calling object, dot student number is equal, so we're going to use let's just have a look at the student number quickly. You can see the student number is along there. So to compare this one, I'm not going to use an equals method, but the double equal sign. So if this dot student number is object dot student number, which means the calling object's student number, is it equal to the object that was passed in's student number? That's now only testing one, so we need to test student name as well. So we're going to say and this dot student name. Now student name is a string, and you compare strings with the equals method. So if the calling object's student name is equal to the object that was passed in, that one's student name. Okay, so if both of them are the same, then we return true. Otherwise, the else there, we will return false. Right, so remember also, this is the long way of doing it. Actually, we should not do it this way. So I'm going to remove that. I'm going to add my semicolon at the end, and I'll just return this part. So that is then returning whatever this Boolean equation or this Boolean expression will return. We will return as well. Then let's just create the getters and the setters quickly. So you can right click and say generate there, and you can say getter and setter, and choose your getter and setter for those two, and it creates the getter as well as the setters for us. So there we've got the whole complete class. So the only thing that we still need to do here is actually the toString method. So let's just quickly create the toString method. So it's going to be public string toString. And because we're overriding this, we add the @override tag there, and then we return basically information about this object, which is the student name and the student number. So we can say return student information, and then going to a new line, and let's add then the student name and a new line character so that we have the information on a new line, and then we're going to say student number and show the student number. Right, so there's a complete class with the copy constructor, with a normal constructor, with all the getters and the setters, with an equals method and a toString method. Okay, so the subject class and the student class are now done. That takes me now to the next part, where we will look at the exam paper class and a concept that we call aggregation in Java. Okay, so what is aggregation? If you look at this class, you can see we've also got 3 fields in this class. But the funny thing here is that 2 of the fields, one is of type student, which is my student class, and one is of type subject, which is my subject class. So aggregation occurs in Java when we've got fields in one class that are in fact objects of another class. That we call aggregation. So now I'm going to create a constructor in this class. So if we create the constructor, it's actually easy to do, to just right click and say generate and create the constructor for you. Now you can see that the constructor, or the auto-generated constructor here, sets our student to the student that was passed in, sets our subject to the subject that was passed in, and set our marks to the marks that was passed in. So one thing to remember here is that in Java we actually do not set the values directly, but we rather set copies of the values. For example, if I'm passing in a new student object here, then this student reference variable will hold the memory location of the object. Also the one that you passed in here will hold the reference. Because remember, what you're passing into a method, if you're working with objects, are actually the memory locations. So now what happens here is that the variable that was passed in will hold the memory location. This student variable will hold a memory location, as well as this student will also hold the exact same memory location. So you've got 3 reference variables now referencing the exact same object. So this is where they say we should have some security, and instead of just accepting this student object as it is, let's make a copy of it first. So we make a copy of it by using the student class's copy constructor. So if you go back to the student class, you'll remember that we did the student copy constructor there. So we're using the copy constructor to first make a copy of the one that was passed in, and then assigning it to our student reference variable. So the same for the subject there. The subject gets passed in, but instead of taking it as it is, let's create an exact copy of that one that was passed in, and then have our subject refer that one. Okay, so it can't be new student, should be new subject. Right, there we go. So the student, our student variable there, should reference the one that was passed in, but a copy of the one that was passed in. And our subject should refer to the subject that was passed in, a copy of it. Now, because marks are not, well, it's not a string or an int, or it's not an object type, which means I can directly assign it. No problems there. Okay, so then let's look at the getters and the setters quickly. So I'm going to create getters and setters there. So there's get student, there's set student, there's get subject, there's set subject, there's get marks, and there's set marks. Okay, so now in this object, when we get a new student, or we get the student of this object, again, we do not want to send back our original student. So when we send back an object, if I'm talking about marks there at the bottom, I can just send through the marks. Get the marks, send it through, set the marks, set the marks. But if we're looking at an object that we're passing back, it is best to pass a copy of that specific object again. So you can see again I'm using the copy constructor. So instead of sending my own student object, I'm sending a copy of the student object. Will it still be the exact same data? Yes, for sure. If your copy constructor is set up correctly, you'll have a copy of our student object. And then to set the student, the same thing. Instead of setting that value directly, we will set a copy of it, just as we did in the constructor. Same for get subject. Instead of just passing the subject, we will have a copy first and then pass through the memory location to that object or that copied object. Now if we say set subject, the same thing again. We will have new subject there to send back, or in this case, to set a copy of the one that was passed in. GetMarks is a normal primitive data type. You can take strings also as normal primitive. You don't need to make copies of strings as well. But for any other object type that you've got in your class using as an aggregation type of object, then you must remember to return copies and set copies. Now let's quickly look at the toString method. How will this one work now? So I'm going to say public string toString. And let's just add the @override notation there. And now what we will return is again information about the three values that we've got here. So now we can start off with saying exam paper information. And then just go to a new line. Now the next part, you'll see that we've got a student object and a subject object. But our student class has got its own toString method, and our subject class has got its own toString method. So the nice thing here now, because we already created those, I can actually just call student and then go to the next one, which will be subject. And then I can just add some more information. Let's put a new line there, some more information for my marks. So I'm going to say marks and then show marks. So let me just show you how this works now. Basically, it's going to print out exam paper information, go to a new line, then we print out student. So when we print out an object, it will automatically call the toString method, which means it's going to say exam paper information, go to a new line. Then when it prints out student, it goes to the student class and print out student information, student name, student number. Then it goes back. It says, okay, the next thing we need to do is to print out the subject object. It goes to the subject class, prints out subject information, subject code, subject name, go back to exam paper, print out marks, and then print out the marks variable. I'm not sure if this is going to work now. Let me just add a new line. Maybe it's not necessary for that new line character. I can't remember. But we'll check it if it prints out now. Okay, so that is the toString method then of the exam paper class. So let's go back to the driver class quickly and add some other values here. So I'm going to remove this now. So we've got a subject there. Let's create a student quickly. So I'm going to say student equals new student. Maybe we can name the student also student1. And if you look at the student constructor there, it accepts a student name and a student number. So let's say the student name will be Chuck Norris, and then the student number will be, well, some sort of number there. I'm just going to type any number there. And now you will see that my exam paper needs a student object as well as a subject object in the constructor. So that's why I need to create these two first before I can create now an exam paper object. So I'm going to say exam paper equals new exam paper. And you'll see that this exam paper accepts now a student, a subject, and then a mark. So the student first, I'm going to pass in student1 there. That's the student object. Let's say, look at that one again. First the student, then the subject, then the mark. So let's make sure we do it in that sequence. First the student, then the subject, then the mark. So the student is in, The subject is next, so it's subject 1, and then the mark, let's say, Chuck Norris will always get 100%, so it must be 100. Right, so exam paper, paper equals new exam paper, student 1, subject 1 as the second argument, and then the third one is your mark. So there we have created an object that contains fields which are objects in other classes. Okay, so now there's the paper, exam paper object. So if I just say system out print line and I print out this paper object now, I will get a whole lot of information by just running that. So if I print out paper there now, it's going to run the toString method automatically of the exam paper class. So it will run this toString method, which will give us hopefully all the information. Let's look at how the information was printed there. You can see there, nicely printed out. It's got the exam paper information, student information. Chuck Norris, there's the student number. Then we've got subject information, there's the subject code, there's the subject name, and then lastly, we have the marks of 100. Okay, so that's how the toString methods can really help us to print out information about a specific object. Okay, so now for the next part, let's see how we can use this paper object now in order to get some other information. So let's say I want to get the subject code, only the subject code, and basically not running the whole toString method, but just getting the subject code out of this object. So remember, this object is made up of 3 parts. It's the student object, there's a subject object, and there's marks. So marks is easy to get. But if I want to get, let's say in this case, the subject code, how will I do that? By just using or referring to the paper object there. So I need to go to the paper object, and on the paper object there's 3 methods that I can call. There's get marks, get student, and get subject. So the subject code will obviously be part of the subject object. So I'm going to call get subject, which will give me the subject, and then on that object that's now called subject there, on that subject object, there's again methods that I can use. So there's get subject code and get subject name, and the one that I want is subject code. So if we run this now, you can see that I only have printed out the subject code. Now the same thing, we can do exactly the same thing for, let's say, the student number. If I want the student number, how will I get it? By just using the paper object there. So again, the student number is part of the student object or the student class. So I'm going to say get student in this case, and then on the get student, on the student object, I'm going to call, in this case, the student number. So I'm going to call get student number. So you can see that paper is the exam paper object. But if I call paper.getSubject, then that whole part there will be the subject object. And on the subject object, I can call its getters or setters. Whereas in this case, paper is referring to the exam paper object. Paper.getStudent refers to the student object. And then I can call getStudentNumber. Right, so this is a simple example on how you can use aggregation also in classes. Welcome to the world of Android. In this video, I will explain what Android is and what makes it so compelling for both developers and device manufacturers. So what is Android? Android is a mobile operating system that is based on a modified version of Linux. Android was originally developed by Android Incorporated. As part of Google's strategy to enter the mobile space, Google purchased Android in 2005. Google wanted the Android operating system to be open and free, so most of the Android code was released under the open source Apache license. This allowed manufacturers to use Android operating system as the operating system of their own phones, as well as add their own extensions to Android and customize it according to their own needs. You can see from this graph that Android has a very big market share and thus very compelling for developers in the mobile section. The main advantage to adopting Android is that it offers a unified approach to application development. Developers only develop for Android in general, and their applications should be able to run on numerous different devices running the Android operating system. Since its first release, Android has gone through quite a number of updates. Android uses letters of the alphabet and something sweet to eat to give names to their versions. For Android, there's no fixed hardware or software configurations. However, the base Android operating system supports features such as storage, which include SQLite as a lightweight relational database, connectivity like Wi-Fi, Bluetooth, and LTE, messaging like SMS and MMS, media support such as MP3, MP4, JPEG, and PNG, hardware support like the accelerometer, the camera, and the GPS. It also supports multi-touch functionality on the screen. Android also supports multitasking applications as well as tethering or sharing the phone's internet connection as a wireless or a wired hotspot. Android is roughly divided into 5 sections in 4 main layers. Firstly, the Linux kernel contains all the low-level device drivers for the hardware components. The libraries layer contains the code for the main features of the Android operating system. This would include, for example, the SQLite libraries. The Android runtime is located in the same layer with the libraries and provides a set of core libraries to enable developers to write Android apps using Java or Kotlin. The application framework exposes different capabilities of the Android operating system to application developers to make use of in their own apps. The application top layer will be the installed apps on the phone from the App Store or from third parties. Android devices comes in all shapes and sizes and includes smartphones, tablets, e-readers, smart televisions, car consoles, and smartware like the smartwatch. Getting apps is very simple in Android. Users can simply use the Play Store application pre-installed on their phone to directly download applications to their devices. In this video, we're going to see how to install the Java Development Kit as well as Android Studio. So just go to Google and search for JDK. I'm going to go with the Java SE Development Kit 8. So if you go to the Java SE Development Kit 8 downloads, you'll see that you need to accept a license agreement there. And then you can have a look at the newest update. So maybe this one would be a better one to go and get, is the Java SE Development Kit 8U172. So it's update 172. Okay, so you can try and get the newest version then. So by installing the JDK, you're essentially installing Java, which is the programming language we're using in these videos in order to program Android. Okay, so what you'll need is for your specific operating system, you need to basically download this JDK and install it on your system. So if you're using a Mac, it will be this download. If you're using a 32-bit machine, Windows machine, it's going to be that one. If you're using a 64-bit Windows machine, it's going to be this one. And then also there's Linux and Solaris and whatever type of operating system that you have on your system. Okay, so just make sure that you download this, one of these links for your specific operating system, and then install this first before you install Android Studio. So you can go and do that now, and then after that we can go back and we're going to install Android Studio. So you're just basically typing in Android Studio there, go to the very first link there, and you can see it opens up the version for your specific PC. So you can see that I'm running on a Mac, so it gives me 3.13, that's the newest version currently that I need to download. So if I click on this now, I can download and I can install Android Studio. If you're looking for some other versions to download, let's go down a bit. You'll see that we've got Windows 64-bit there. You can download directly from here without the exe installer to just download a folder there that you can run it from. You can download this file, or if it's Windows 32-bit, it's going to be this one for a Mac, for Linux. So you can choose your specific operating system file that you want to download here. So just make sure that you install the JDK first before you install Android Studio. And when installing Android Studio, you'll see it goes through a lot of setup steps that you need to take in order to get that up and running. But it's straightforward. one of the first things it will try and do is to get you the software development kit of Android Studio or of Android, and then from there on you should be fine with Android Studio. So please go and install the JDK first and then Android Studio, and then we'll come back for the rest of this video. Right, so when you're done installing Android Studio, you should get to a window that looks like this, and you can see the version 3.13 is the version that I downloaded here for my Mac. Okay, so now this is Android Studio. This is the first window that you'll get, and you can see on this window you've got an option to start a new Android Studio project. You can open an existing Android Studio project. You can check out from version control, profile debug. You can import a project from Eclipse or Gradle. You can import an Android code example. Then also, if you go to configure there, just move this up a bit. If you go to configure, you can see there's the SDK manager, which we will talk about now. There's also preferences, plugins, import settings, export settings, settings repository. There's checking for updates. You can check for updates frequently to make sure that you're running the newest Android Studio. Also that all of your libraries are up to date. So make sure you check up this frequently, although Android Studio will also notify you of new updates. So what we're going to go to now is the SDK manager. So you can click on the SDK manager. It will open up this window. And then this window is very important for you to keep updated. So you can see that you can check the show package details there. And then it gives you a list of all the platforms that you can install. So now you'll see that I did not install everything. You can see it's not installed and some of them are installed. So you can see that, for example, the Android API 28, I've installed the SDK platform. So this is one of the things that you should have for every type of platform or every operating system. So it's Android API 28, which has not yet got a name there. It's Android P, but you can see there Android 8, which is Android O for Oreo. I've also got the platform there. So make sure that for every operating system or every platform that you've got the Android SDK platform installed so that you can actually code for that platform. So you'll see that on every one of them, I've got at least the platform and some sources on them, but it's up to you for the sources. Then also the Google APIs, make sure that you get them if they're available for that specific API. So you can see basically what I'm taking there is the SDK platform, the APIs, and if needed, some sources for the Android SDK. The rest of them, you can see that it's system images. So we'll look at this in the next video where we will create a virtual device. So the system image here is basically just an image for a virtual device. So that's a virtual phone that will run on your computer. So it's up to you how many of these you want to download. Obviously, if you've got a very big hard drive, then you can download a lot of these, but it's not necessary. If you're using your own phone to test also, then you don't need as much of these system images. Okay, so it's up to you how many of these system images you want to take. For example, if you want to test your application running on a phone that is running Android 8.1, then you'll take one of these system images. So this is very important. Go and choose a few of them. I would recommend you take the one that says Google Play. That includes the Play Store and some support for maps and so forth. Also, the Google APIs is a nice one to take. Okay, so you can go through them and you can see I've checked a few of them there that's running on my system, but it takes up quite a big number of gigs on your system. Okay, so go and make sure that you at least download the Google APIs and the platform for every API, for every Android version. Okay, so this is the SDK platforms. If you go to SDK tools, make sure that you check everything here. This is important to take everything here. Well, not really everything here, but I think it's the best if you can take everything here. It's not that big as it is with this side. So just make sure that you take everything here. One of the most important ones here is the Android support repository, the Google repository, the constraint layout, and maybe the Google Play services. And also the tools and the platform tools. So there's a lot of things here that you should actually take. I'm having trouble installing the debugging tools, which doesn't give me a problem really. I just can't install it, I don't know why. But try and take everything under SDK tools. Okay, so if you're done with that, just let your Android Studio run and do all the updates and make sure that you've got all the platform tools and everything installed. And then we can start with the next video where we will start a new Android Studio project. Right, so we are at the very first window of Android Studio that says welcome to Android Studio. Hopefully by now you've installed Android Studio and you're ready to go. So we're going to click on the first one there to start a new Android Studio project. So you'll see the first window that you get is to create a new project or create an Android project. So in this window you will actually be able to create your new project, give it a name and so forth. So in this case we're going to give our application a name. Let's just call it my test application, just to give our first application a name. We're not actually going to build something, but just going to go through the basics of the IDE. Okay, so for your application name, it can contain spaces there. So just note that you can add spaces there for your application name, or you can have it one word or whatever. It doesn't really matter. But this will ultimately become your application's name. You can change it later on, but think a bit about because it becomes your package as well. So just think about your application name beforehand. Okay, then your company domain. This is basically just a domain, a website address that you can add in here to make your application on the Google Play Store, to make it unique. Every application on the Play Store must have a unique package name. So it depends on your specific domain. Obviously, if you buy a domain online, that domain is unique, and that is why you can use your domain here and it will be unique. If you do not have a domain, you can just start typing maybe your surname and a few other characters there with your application name. It should also be unique. But to make sure it's definitely unique, try and use a domain name there. Okay, so this is the domain. You can do anything there for now. Then if you go down, you can see your project location. So my project is on the desktop, Android projects, and it's going to be called My Test Application. You can also go to the three dots there and choose a different location for your specific application. Okay, so then the next part, you can see it created your package name for you automatically. You are able to edit it, but it basically takes your domain backwards. So you can see it's za.co.programme.whatever. And then it adds your application name, all lowercase, without any spaces. So this will then become your unique name for your app in the App Store. Okay, so for this page then, do not include C++ support, also do not include Kotlin support unless you know how to work with Kotlin. We're going to use Java in this project, so then we do not include Kotlin support. We're going to go next. In this page, you can see it's still creating a new project, but now we need to select which devices will we target with this application. And you can see there's a few devices that you can program for, which is the phone and the tablet. There's Android Wear, there's a television, there's Android Auto, there's Internet of Things. So it depends on what device you are programming for. So in this case, we're going to use phone and tablet. So if you click on phone and tablet, you must have actually one thing clicked there. You must be able to create an application for something. So we're going to click the phone and tablet, should be automatically clicked. And then the next step here will be to go and choose your operating system that you will support. You can see that it says there some devices require additional SDKs, low API levels target more devices but offer fewer API features. So you need to choose your version of the operating system that you will support carefully. So in this case, let's say we're taking Android. Let's take the newest version there, 24. And then it says by targeting API 24 and later, your app will run on approximately only 8.1% of all devices currently on the Google Play Store. If you've got an internet connection, this will be a correct estimate of devices that's currently running apps on the Play Store. Okay, so it's only 8.1%. But if you go to a lower version, for example, KitKat 4.4, you can see that it runs on 90.1% of all devices. So if you know that you're only going to create apps for basically that supports Android 8, Oreo, then you will know, well, you can see there for Android 8, it supports actually less than 1% of all devices. But if you're creating an app for a company and all of them has got Android 8 on their phones, then you can choose this one. But if you're going to place it on the App Store for a lot of users to use, I would recommend going for a lower version. For now, we will, in our applications, probably use 4.4 or 5.0. 5.0 is also targeting 71%, but I think you can go lower. Ice cream sandwich, then you know it's 100%. That one is 100%. 4.1. Okay, so if you want to get 100% of all the devices, you should go for Android 4. So in this case, I think let's just go with 4.4, which is KitKat, and we're targeting 90.1% of all devices. And then you can just say next. In this page, you can see we're still creating the new project, and now we need to add an activity. And an activity is basically a screen that the user will see. So what this window is basically telling us is basically saying, choose a template that you want to start with as the very first activity or the very first screen of your application. So you can see there's a basic activity that's got this yellow button there. There's a bottom navigation activity template. There's an empty one that we're going to use most. There's a login, maps, and so forth. You can go through these templates. So if you, for example, want to look at the navigation drawer that opens up a drawer from left to right, then you can go with this template, and this template will help you with coding on how to do the navigation drawer. But for the most part, we will start with an empty activity and then add everything else to that activity. So if we start with an empty activity, we are also able to actually do the navigation drawer activity. We're just not going to start with coding that's already predefined or pre-made by Android. So we're going to go with an empty activity and say next. And now you need to give your activity, and remember, an activity is a screen that the user sees. So we need to give this activity a name. So you'll see there's two parts here. There's an activity name. This will become your Java file. And there's a layout name, which will become your XML file. So the two files works together. So for one screen that the user sees, they see the layout file, which is your layout name here, which will become the XML file. This is what they see, but what happens in the background encoding is done in your Java file, which will be called main activity. So I'm going to leave it as main activity, and normally what we do is to give these two descriptive names and names that basically go with each other, so that we know that this file, this Java file, belongs to this layout file. So I'm going to name this one main_activity, and then just remove that. So you can see the two are basically now the same. This is main activity and that's main_activity. For your layout name, just make sure that you have everything lowercase, no spaces in between, and that you have, or you can use, the underscore. For the activity name, that's normal Java convention, Java coding on how to create a class. So we start off normally with a capital letter, no spaces in between, and every subsequent word will be capitalized. Okay, so this will be your class name, your Java file, and that will be your XML file or your layout file. Make sure you check also backwards compatibility, so that you make sure that your app can also support lower versions. Then we go to finish. And now we wait for Android Studio to quickly build this project. And when it's done building, we'll come back and have a look at the IDE. Right, then Android Studio is done building the project. And you can see there's the name of your application, My Test Application. You can also see the destination where it's saved, and it's called My Test Application. Okay, so I'm going to close down these files quickly that's currently open. And then we're going to go to the left-hand side. So you'll see at the left-hand side, if you click on project there, maybe you've got something that's this, nothing open. Then you've got project, structure, capture, favorites, build variants, and so forth. We're going to get to these later on throughout the course, but for now, in the project tab is where we're going to work most. So if your project is closed like this, you can open it up by just clicking on it. Within your project tab, there's a few other tabs that you can also choose. So we're going to work with project and Android. So if you go to project, you can see that here is where we basically will add some other libraries and stuff in our libs folder, but we'll get to that later on. So the project one is where we're going to work in some cases, but most of the time we'll work under the Android tab. So it's going to be under project, and make sure it's under Android. So if you get under Android, you'll see two folders there. So folders, first one is the app, folder. The second one is the Gradle script. We'll come back to Gradle scripts later on. You can also add libraries in your build.gradle file, but we'll talk about that later on. So forget about Gradle scripts for now. Just do not edit anything in here. You should know what you do when you're editing here, otherwise your project will not work. Okay, so if we go into the app folder, you'll have three folders: manifests, Java, and the resources folder. So if we go into the manifest folder, you'll see that there's your Android manifest file. Now this is also a very important file, and you should not change this file unless you know what you're doing. And you can see this file indicates what is the package for this application. It also tells the operating system what's the label, what's the theme, how many activities are listed inside of this application. You can see that for now we only have one activity, which is called the main activity. It will be the main activity, and it's the launcher activity. So this will be the activity that opens up when you start your application, and it's called main activity. So in the manifest file, you'll see as we start adding new activities, it will also be listed here. So we'll get back to the Android manifest file when we get to later applications. So you can close down the manifest file. Now the next folder is basically your Java folder. So if you go into the Java folder, you'll see there's three other folders. So there's two that's got some sort of Android test or test in brackets, and there's one that's got nothing in brackets. So this is the one we will use mostly, and you will see if you open up that one, there's the main activity. So this main activity is now the Java file. If you open up that main activity file, you can see it's called mainActivity.java. It's got a package declaration at the top, which is the same package as the one that you've got there, the one that you defined right at the beginning. It's got some import statements, normal Java convention, import statements at the top. And luckily with IntelliJ, by the way, Android Studio is based on IntelliJ. So in IntelliJ, you've got import statements added automatically as you type, which is quite nice. Okay, so in Android Studio and IntelliJ, you've got the same functionality. Right, then you can see there's the normal class declaration, public class, main activity. It inherits from the app compat activity. You remember app compat to make compatibility for lower versions of the operating system also possible. So make sure it extends app compat activity, and it should do so automatically. And then there's the onCreate method that is like the normal main method in Java, and this is where your activity will start. But we'll get back to this. So that's the main activity Java file. Now, if we go into the resources folder, the rest folder, you'll see there's drawable, layout, mipmap, and values. So your drawable and your mipmap folders will hold images that you're going to use inside of your application. So under drawable also, you can see there's your launcher. That will basically be the icon that will show when the user installs it on your phone. That will be the icon for the app. The second one is the layout, where we will keep all the layout files that corresponds with our Java files. For example, this Java file main activity is connected to mainActivity.xml there. We'll get back to that now. So this is the layout folder. It will have all the layout file. Also other layout files that's not connected to activities will also be listed inside of your layout folder. So the mipmap folder also, you can see there's part of the drawables of the launcher icon is there, also some of them here. So your drawable and your mipmap folder is for images. If you go to your values folder, you can see there's a colors XML where we'll have all the colors for our app. A strings XML if you want to do some translations later on. We're going to use the strings XML, and also styles if you're going to use different styles for different things in your application. Okay, so now let's just go back to the main activity. And you can see in the main activity, one of the first lines there after the call to the super onCreate is set the content view. So we're basically telling this Java file that the content view, or the file that goes with this main activity, is called main_activity. And you get there by saying R, which is resources, then layout, going to the layout folder, and then called main activity. And there it is, mainActivity.xml. So we're linking up the main activity Java file with the main activity XML file. And remember, this is the layout file. And we'll open it now to see how it looks. Luckily, Android Studio, whenever you create a new activity, creates this and sets this up automatically. You must just make sure that then you name the two the same so that it is easy to go and see which Java file goes with which layout file. Now let's close down the Java file and open up main activity XML. Now, depending on the speed of your computer, this could take a while to just refresh the layout. But you can see now we've got a whole new set of options available to us. So before we get into the main activity, let's just go through the top there. You can see that you can open up a new project, you can save, you can sync, you can undo, you can copy, paste, and cut. You can build. There's a run option that we're going to get to in this video still. If you want to run the application, how do you do that? There's debugging. Then this one is to attach a debugger. There you've got your AVD, your Android Virtual Device Manager, that we're also going to do in this video still. And then there's your SDK Manager that we talked about. Right, so let's open up the main activity quickly. And you can see in the main activity, there's the XML file, the layout file. There's two tabs at the bottom. One is for design, one is for text. So if you go to text, you'll see the XML version of your layout. And you go into design, you'll see the design editor. So some people like to only use the design, some people like to only use the text, and normally we use both. So I'm going to go into the text one, and I want you to change the constraint layout. So that whole part, just select it and type in linear layout. So don't type the whole thing, just let it autocomplete there for you, and you can see it's the linear layout. And then just make sure that you add an orientation property there. So just start typing orient, and it will give you the orientation property, and you can select it to be vertical. So this is just to make this very first app a bit easier. So if you go back to design, you can see that Hello World is now at the top. I'm going to click on it and delete it. You can just use the backspace or the delete button on your keyboard to delete all the components. And now you can see we've got a blank screen. There's some zoom controls that you can zoom in and out. And then we're going to get to the palette there. So you can see this part there, the palette is basically all the widgets that we can use on the screen. So if I, for example, want to go, and you see the common ones is like the button and the text view and so forth. So if I want to drag in a new button, I can do so and drag in the button and just leave it there, and there's the button. Now I can also drag in, let's say, a text view there to show some text to the user. I can also ask the user to enter some text by just adding what they call an edit text there. Okay, so these are all of my components that I can use on the screen. Now, very important, if you click on any one of these components, you can see that there's an attributes window there on the right hand side that's open, where we can set a lot of properties for that specific component. So for a button, you'll have some properties. For a text view, you will have some of the same properties, some will be different, and so forth. And we're going to look at that in the next video. So make sure about the attributes. We should use this one a lot. This is your attributes. If you click on any component, we can set some settings for it. For example, just as an example, I can set the text for the button as click here or whatever you want to do, and it changes the text there. Okay, so that's the properties or the attributes window. If you go to the component tree there on the left hand side, you can see that this gives you an overview of what you have on the screen. So you can see our root component is the linear layout that's vertical, and then there's a button, there's a text view, there's an edit text. So if you're having trouble clicking on a specific component on the screen, it's also easy to just go to the component tree and click on a component there to edit. Then at the top there, you can see that we've got design, blueprint, design, and blueprint. So if you're using a constraint layout, just use the zoom controls. You will probably look at both of these, which is the design and the blueprint. But if you're using just the normal linear layout, the normal design will be fine. Then you can also set the orientation to portrait, authored, landscape. I can make it landscape there. I can make it portrait again. You can also set the UI mode, the night mode, and some other settings you can set there. You can also set the specific device that you want to code on. So let's say you're developing for a television and you want to see how your app will actually function on a television. Then you can go and select a television here, and it shows you how will it look on a television screen, for example. Okay, it will look something like this. Right, so let's just go back to, let's say, Nexus 5 there. Then you can also choose the operating system to see how it will look. So for example, 19 there, if it refreshes, you can see in 19 we did not have the colored notification bar there at the top. So this is how it will look on API 19. On 28, we've got it colored the same theme as your app, which is quite nice. Then you can also choose the app themes there. You can play around with that. You can also edit your translations, which goes along with your values folders, strings XML, but we'll get to that also later. You've got your zoom controls and so forth. So this is the basics of Android Studio, the IDE, and when we develop our first application, we'll get into this a whole lot more. So the next part that we want to do now is to just click the play button there. And when you click the play button, it's like running now this application on a phone. But now if you have your phone connected to your PC and all the drivers installed and so forth, then it will show also under connected devices. But if you do not have a device to test it on, you can create virtual devices. So you can see I've got a few there, but probably if this is the first time you're running Android Studio, you won't have any devices there. So you need to create a new virtual device. And then it gives you an option of devices that you can create. And I would recommend taking these with the Google Play Store icon there. Okay, so let's go with the Nexus 5 there, for example. And you can see that it gives me, I've only got, for the Nexus 5, I only have one image that is Android 8.0, the Google Play one that I can actually use, or also Nougat. So those two I can use right out of the box because I've installed them inside of my SDK. But if you need another one, let's say API 28, you can download it right from here. So I'm going to select this one, the Oreo one, and just say next. Then you can give your virtual device a name. I'm going to leave it as it is. That's the resolution. That's the operating system. You can choose whether it should always, when it starts up, be landscape or portrait. There's some graphics options, so you can go into the advanced options and make some other changes if you want to. You can set the RAM, for example, if your PC has not got a lot of RAM. You can change the RAM on some of these devices and the SD card and whether it's going to enable a keyboard and so forth. And then you can go to finish after setting up everything. And then after you've set up your virtual device, it will be listed here. And now after it's been listed here, you can now go and select that device and say OK. And now when you click on OK, it will start running that device on your phone. Oh, sorry, not on your phone, on your PC, running your application. Well, it will automatically start running because we clicked on the run button. So let's just wait for the virtual device to get up and running, and then we'll quickly look at it. Right, so we can see that the device is basically up and running now. It's a brand new device, so then it takes some time to actually set up. So you can see that mine is busy trying to install the APK at the bottom. So it's still waiting for the device. Okay, so there's the APK now, and you can see that it has been installed on this phone. And you can see there's the button, there's the text view, there's the edit text where the user can type something. And then that's basically it for this virtual device. You can see it's got the hardware buttons where you can go back. You can use, for example, if I click that button, it takes me to the home screen. If I click on this button, it will give me a list of all the applications. I can remove that application from memory, and then I can go back to applications. I don't know where that is now. Let's just use that one. So there's the applications, and I can search for my test application, and it opens up my application again. So it's a normal phone. You can actually install your Google ID on this, your Gmail address, and then you can download apps also and run it on this device. Your browsers will work, your mail applications will work, your Maps application will work, depending on the internet connection of your specific device that you're running it on. Okay, so this is basically the virtual device. You can also see you can switch it on, off. You can set the volume. You can set the orientation for the phone. How will your app display when you turn it to landscape or portrait? If you've got a webcam, you can also use the camera. You can zoom in. This 3 buttons there is the same as the buttons there. And then there's some other options that you can also select. For example, setting your battery not to 100% but to 67%. Just to indicate that it's busy charging or whatever. So Hopefully you've learned something from this video. In the next few videos, we'll create an application and then you'll get used to this environment. In this video, we will have a quick look at the activity lifecycle. So we talked a bit about the activity in the previous video, and the activity is basically a screen that the user sees in front of him. So for example, if you launch your application for the very first time, your very first launcher screen will appear, and that we also call an activity. So what happens with an app that's may possibly just have only one screen, for example, one activity, or any other activity that it goes to? What happens to that activity? What is the life cycle of that specific activity? So this picture that I got from the Android developers website is basically a nice indication of what happens when your application runs and when an activity gets launched and you move away from that activity. What happens to that specific activity and which methods will be run? So when your activity first gets launched, it goes to the onCreate method. Goes to onStart, it goes to onResume, and then you see your activity running. So the green block here is your activity is actually running and the user is looking at the screen. So then something else could happen. It could be that another activity comes into the foreground, then it goes into onPause. If the user returns to the activity, it calls onResume and the user sees it again. But if the user does not go back to it and the activity is no longer visible, it calls onStop. If it's in onStop and the user navigates to the activity, it goes to onRestart, onStart, onResume, and the user can see it again. But if it's on stop and the activity is finishing or being destroyed by the system, it goes to onDestroy before the activity is shut down. Also in onStop, if there's apps with a high priority that needs memory, it will also kill the process. And then if the user navigates back to the activity, it calls onCreate again, onStart, onResume, and then the activity will be running again. So we'll quickly try and demonstrate this in an application. So you're going to create a new application, and we'll just call this one Lifecycle Events. And then let's keep the domains and so forth the same. We can just say next there. We will keep Android 4.4. We will keep the empty activity. We can leave it as main activity and activity main, that's fine. So let's just create a new application, wait for it to finish, and then we'll come back to the video. Right, so when your application is done running, we're going to get into the main activity. So normally it opens up the two, but if it's not opened, you can go into Java, into your project folder first, or your first Java folder there, and get to the main activity to open it up. And you can also go into Resources, Layout, Activity Main XML to open it up. But for now, we're not going to use the activity main XML, so I'm just going to close that one. We're just going to work with the Java file. So you'll see the very first method that we have here is in fact the onCreate method. So what I want to do here is to use a class called log, and that's from android.util, and you can just click on it. And you can see by clicking on it, it automatically adds the import statement for you at the top. So I'm going to say log.d, and you can see this log.d gives us in the log cat at the bottom, gives us a log as soon as the application comes into the onCreate method. And you can see it gives, we need to give it a tag and a message. So I'm going to start with a tag for all of them the same that will say, let's just say life cycle event. And then we'll have the message as, in this case, in onCreate. Right, so log.d will basically log it inside of the logcat. We'll look at that now with the tag lifecycle event and then the message in onCreate. Now, this is sometimes you can use the log for error correction and to see where you are at a specific time in your application when it's running. So in this case, we want to see the methods that is actually run if we run this activity and we move away from this activity. Now, if we quickly have a look at that picture again, you'll see that the onCreate's the first method that runs. Then there's onStart and onResume. So let's see if we can get those two methods quickly. So in order to get these other methods, we're just going to right click and say generate, and we're going to say override methods. And you can see there's onStart, onStop. So the methods that we want now will be first the onStart, then onResume. So let's go to the onStart method. You can just double click it, and you can see there's the onStart method. So I'm going to copy this log so that we can use this log again. Paste it there, and instead of saying in onCreate, I'm going to say in onStart. Now let's go to the next method. So the next method there is the onResume method. So let's do the same thing. We're going to right click, say generate, override the method, and we're going to search for onResume. So the onResume method, there it is. Paste that log again, and we're going to say there inside of the onResume method. Then go down a bit. Let's see for the next method. After onResume, we also got onPause and onStop. So we're going to right click again. Search for the onPause. Double click, and then let's paste it again. And in this case also we're in the onPause method. Now the next method again will be after onPause, we've got onStop. So let's try and get that method quickly. Right click, generate, override. There's the onStop method. And let's paste it again. And just to say we're here in the onStop method. Let's check again. There's also an onDestroy and an onRestart. So let's search for onDestroy. There's the onDestroy method. Also just paste that log again. I just removed something there, so I'm just going to go back. The call to super must be there, and that should be onDestroy. And then the last method will be the onRestart method. Let's just check if we can get that onRestart method. Generate, override methods, onRestart, and there we go. And then we can paste that one also and say this one should be onRestart. So we've got the onCreate method, the onStart, onResume, onPause, onStop, onDestroy, and onRestart methods. It's basically all of the lifecycle event methods of an activity. So what we're going to do now is to run this application, and you can choose any one of your devices that you've actually set up. So I'm just going to take any one of those and start running it. As soon as this device is up and running and our application is running, we'll see how these methods actually gets logged, because we are calling this log.d inside of the logcat at the bottom. So you can open up the logcat at the bottom, and you'll see that it's busy loading the emulator still. So as soon as the device is online, we will start seeing something happening in the logcat at the bottom. Right, so my application is busy running right now. And if I go just a bit up there inside of the logcat, you can see this is the bottom of it. If I go a bit up, you can see that there's my first lifecycle event. The activity went into the onCreate method, then into onStart, and then into onResume as soon as it started running. So if you look at the picture quickly, you can see in this picture that when we first launched the activity, it goes to onCreate, onStart, and onResume, and that's exactly what happened here. So let's go back to that virtual device quickly. If I click on the back button, let's see what happens. So if I click on the back button, you can see there's the next lifecycle event. It went into onPause. So when we clicked on the back button, it went into onPause, then into onStop, and then into onDestroy. And now the activity is basically shut down. Okay, so now if we relaunch this activity by just going to the lifecycle event, clicking on it, you can see from the onDestroy it went into onCreate again. So it's basically launching the application again. onCreate, then onStart, then onResume again. Okay, so that's the life cycle if we click on the back button. If I click on the home button, now you see in the home button, it goes from the onResume to where the user is seeing it to onPause and then onStop. So it went to the onStop, and now it's waiting either to be destroyed totally or for the user to navigate back to the activity. So now if we navigate back to the activity by clicking there, clicking on lifecycle events, you can see that from on stop, it goes to on restart, and then again to on start. So it's on stop, on restart, and then on start again. So these are the life cycle events that we're talking about when we're talking about an activity, and you can use these methods in order to do some very important stuff depending on what your application will be doing. For example, if we're playing music in the background and the activity gets destroyed, in the onDestroy method will then be a nice place to go and actually release all the memory so that we don't have that memory still running on the phone. So in the onDestroy, we can normally get rid of every piece of memory that we're still using somewhere else. You can also do that in onStop and maybe reinitialize stuff in onResume again, or do something in onPause. So it's up to you in your applications where you want to include some of these methods. Please remember that these methods will run no matter if you are actually including them in your application or not. They will run. If you're not including them in the application, it will just basically run super.onStart and super.onResume and destroy and so forth. So if you want to add coding to it, then you can override these methods. So just a note, you do not need to have these methods in your activities for it to actually work, but it's good methods to implement if you want to get rid of some memory used or reinitialize stuff. So please look at this activity again, run a few examples of it on the phone, do a few things with it, click on the back buttons and so forth to see which methods will actually run when you do certain actions on the phone. Welcome back to this video where we will actually start designing our own application. Okay, so the application that we will look at today will basically ask the user to enter a South African ID number. So we're going to add or enter a South African ID number, and you can see that this picture that I got from the web that basically explains the South African ID number and which digit means what is the one that we will use in order to create this application. In this application, the user will then type the ID number, and we will show the user what is his date of birth, whether he's male or female, and whether it's a South African citizen or not. So basically, we're going to use this picture. You can get this picture online as well by just going and searching for South African ID number explained, and you'll get something like this. So we're going to look at this picture later on. So let's create a new application. So I'm going to go to Start a New Android Studio Project, and we will call this project let's just call it Magic ID Application. We're going to leave the company domain as it is. We will not include any support there. And then we're going to develop for phone and tablet. Let's use it as 4.4 there. We're going to use the empty activity. We will leave it as the main activity there. We can go and change that one to main_activity without any spaces. So I'm going to change it to main activity, make sure it's backwards compatible, and we're going to say finish. All right, so let's just wait for the project to sync and get everything up and ready for us, and then we will start with the application. Right, so our application is ready, and we will start building the app. So for now, I'm going to leave the main activity and just close down the main activity Java file, and we're going to work on this video in the main activity XML, basically designing how the app will appear to the user, or how this first screen of our application will appear to the user. Now, first thing that we need to do is to go into the text tab at the bottom, and then just change the Android support constraint layout. For now, we're going to work with a linear layout. So make sure that it auto completes there, and you see as you're typing there at the top, it's also typing at the bottom the closing tag. So just make sure that your opening and your closing tag are exactly the same. So we're going to say linear layout, and you can see at the bottom and the top it's the same. And then for this linear layout, we need to add an orientation. So you can just start typing orientation, and we set the orientation to vertical. I will get to that now. So let's just remove this text view also, so that we basically just have a blank linear layout as the root layout. Then go to the Design tab, and you should have nothing on the screen right now. In the component tree, you should see the linear layout that's vertical. Now, vertical linear layout means that every component that I place on the screen now will be vertically aligned and will be linear, which means that if I place a button there, it's going to be the button. If I place another button there, it's going to be directly underneath it. So it's going to stack them vertically. But there's a few changes that we can make in the linear layout. Okay, so we're going to start off with this application, and we're going to go to text there, and we're going to use a plain text, or let's just use a number there. So we're going to use a number field there, and the reason why we have different types of edit text now, these edit texts are basically a space where the user can enter some data, and we can get some data from the user. And remember, for this application, we want to ask the user for the ID number. And because it's going to be a number only, that's why I need to take this one that says number. And the reason behind this is that if I would choose a plain text one for the user to just type the number, that will also work. But when the keyboard pops up for the user to type, it will show the full keyboard, where in fact we only need the number keyboard. So in order to make this easier for the user, it's better to use the number one here, so the number edit text. And this number edit text will then only pop up the number keyboard. And this also make error correction a bit easier. So at least now you'll know that the user will only be able to enter numbers. He cannot, for example, enter his name and then we try to extract something from his name. Okay, so we're going to use a number edit text. So you can just drag in the edit text to the screen, and you'll see it becomes the very first item inside of your linear layout. Now it's going to give you some problem there. They say it's missing accessibility label, provide either a view with a label for that reference or whatever, or we should have a hint there. So we're going to do the hint property. So we'll get to that part now. So this is the first component that we want to have, and if you click on the component, you'll see that we've got attributes that we can set for this component. So for this component, if you click on it, we want to go and set the margins a bit so that it's not totally against the sides there and also not against the top. So we're going to go into the layout margin, and I'm going to set the left margin, let's use a 15 there, as well as the right margin 15, and you can see it's a DP, device pixels. And then also I want to have one at the top. So let's make the one at the top also 15. So it moved down my edit text, or where the user can type some data. You can see it's called an edit text in Android. Right, so there's the edit text now. That looks fine. We'll get to the hint property now. So let's just first drag in a button. So I'm going to drag the button from there, also just underneath that one. And you can see in the linear layout that's vertical, as soon as you start dragging and dropping, it will vertically place them into your layout. So in this case now, this is a button. You can see it's called a button, just a normal button. So for this button, let's do the same layout. Now for this layout margin, we had 15, 15, and 15. So let's try and do the same thing there. On the left, 15. On the right, 15. And let's make the top 10. Okay, so you can see they're basically now the same size because they've got the same margins. Okay, so now this is the edit text where the user will type something. When he clicks on the button, we want to show him now some information. So for now, to just show simple information, I'm going to use a text view, and that's basically what you call a label in some other programming languages. So this is just a normal label, which we call a text view in Android. So for this text view, we can also go to the layout margin property. So make sure it's clicked. On the left, we can also have 15 again. On the right, 15 again. And then at the top, let's make it 10 again. So that text view will then be what the result will be after the guy has entered his ID number. So now if you zoom in a bit, this is how your layout should look like. Okay, so for now, in order to change the text that I want to display here, and that's mostly why we have these comments here. And remember, these comments is not a real error. You don't need to handle them for your application to run. If you run it now, you'll see the application works. If there's red errors, yes, then we have some trouble and we need to handle those errors. But for these are just hints or comments for you to better your application. Okay, so we're going to address this in any case. So let's get to the edit text. Now, remember when we ask a user to enter something, we either need to have a label at the top or a text view then in order to tell the user what to do and what to type here, or we can have a hint property. So if you click on the edit text and go to attributes and you scroll down a bit, you can see that there's a hint property. So in the hint property, I can go and type, please enter ID number. Okay, don't click enter there because it's going to take that one. So just make sure you out of the autocomplete there, and then you can enter. And you can see it says the hint now, please enter the ID number. But still, it's got a problem there. It says that this is a hard-coded string. So we're gonna fix that problem also now. Right. So now that we have the hint, let's try and center the hint in the middle of the screen. So for this, we need to go to the gravity properties. So you can see that there's a gravity, a normal gravity, and there's a layout gravity. So now the layout gravity basically moves the component inside of the layout, whereas your normal gravity moves the text inside the component or whatever you have inside of the component. So just to illustrate this quickly, I'm going to set you see the width for this component is to match the parent, which means it's the same width as your linear layout, which is basically the whole screen's width. So now we can change that width to wrap content. You don't have to do that now. I'm just trying to explain something now. So you're going to set that to wrap content, which makes this specific component as small as possible, that it still contains everything that's in it. So you can see it's a lot smaller now. But now let's say we want to center this inside of the layout. So for that, we'll need to go to the layout gravity. And if I now say center it horizontally, you can see it's centered horizontal inside of the layout. So it's the whole component that moves to the center. So what I'm going to do next is to just go and change this back to matching the parent. So we have the whole thing. So if I just want the content that's inside of the edit text to be centered, I will use the normal gravity property. So there's the gravity property, and I'm going to set this to center horizontal, and you can see now it's centered horizontally, and that's what we want to do here. So it's up to you how you want to set up your layout. So the normal layout gravity one, this layout gravity moves your component within the layout, and your normal gravity one, this one that just says gravity, it's the one that we actually use now, will move whatever is inside of your component to be centered horizontally or vertically or to the left or to the right. So I can move that and say, no, I want this whole thing to be on the right hand side or whatever. So for this example, we're going to keep it as centered horizontally. Right, so now the ID number is fine. If we zoom in a bit, you can see please enter the ID number. We've got the button, and then we have the text view. So for the text view also, if you want to have it in the middle of the screen, you can just also say go to the gravity property and set it to center horizontal, and it will be like that. So I'm going to leave this one on the left. That's fine. So now for the next part, we're just going to have a quick look at the string resources that they are moaning about here. They on all three, they say it's hard-coded strings. Please do not do that. And the reason behind that is for every hard-coded string that you have, for example, this one, if I go into the text property quickly, or the text tab at the bottom, you can see that I have the text there hard-coded as please enter ID number. So for that, or for Android, that is a problem because it cannot translate hard-coded text. So if you want to use a translation, and that's why I say you can ignore this if you really do not want to reuse this, or you do not want to add this to your translations, then you can ignore these hard-coded string comments. But if you want to go and apply this, you will see that there's a strings XML. So under your resources folder, under values, you'll go to strings XML, and you can see this is where your string resources will lie. And basically this strings XML file will be the file that you can use to do your translations. So I'm going to go into the main activity again, go into the text part, and if I click on my hard-coded text and you use Alt-Enter, or just Alt. Let me just see. Alt Enter. If you use Alt Enter, you can see that it says extract the string resource. So if I click on that, it gives me what should be the resource's name. So let's just call this one hint underscore ID. The resource value, this will now be the hard-coded text where we said please enter the ID number. You can see it's automatically typed there for you. The set must be main, that's fine, and the name must be string in the strings XML, and its values, we're just going to say okay. So what happened now is your text gets replaced by an @string and then the ID for that string. And you can see now in your strings XML, that's the ID for your string or the name for the string, and this is the text that it will contain. So another way for us to actually do this is to go and hard code it here also. So I'm going to, let's just call this one hint ID, let's say 2, and then close it. Please enter ID number 2, just as an example. So I can hard code it here as well. I can directly come in here in the strings XML and type it here as well. So now in the main activity, if I want to use that, I can go to design. You can see now in the hint, we've got this. So I can click on the 3 dots there, and you can see there's my 2 IDs. There's hint ID for the name and hint ID 2. So if I choose that one and say OK, I'll have the second one's text. So for this example now, I'm going to remove this, and we will just keep this one that says hint ID. So I'm going to go back there, click on the 3 dots, and choose that one again. Right, and now you can see that that hint or that comment is gone because now it is inside of your strings XML. And if you do a translation, copy this file into another translation, you can just go and change the text, and the text will be used wherever you use this name. That's called hint ID. Okay, so let's do the same for the button. We can just say something like submit there for the button. So what I normally do is to go to the text property of the button. That's the text that's on the button. And I'm going to change the text to, let's just call it submit, and click away. And you can see there's the text is now submit on the button, but still it wants this hard-coded string submit to be also in the strings XML. So again, you can just go to your text tab at the bottom. Wherever you've typed the hard-coded text, Alt Enter, extract the resource, call it whatever you like, and please remember that everything inside of the resources folder, whether it's a layout file, whether it's a picture file, doesn't matter. Everything must be lowercase, and you may use the underscore. So the resource name will be submit, the value, that's the text it will display, it will actually be submit, and the rest you can leave as it is. And you can see now it replaced it with an @string submit, which means it goes to the strings XML, and there's a name called submit, and it will show this text submit. So now if you go back to design, you can see that the comment there to the hard-coded string is now gone. Android Studio is happy. Now for this last text view, you can see that it also says hard-coded text, but I do not want to translate the text view there. We're going to set this one with new text. So I'm not going to change any text there. I'm going to leave it as it is. What you can do is to have a default value here inside of your strings XML, and that will show. But the user will not ever see text view there. We will change it in coding to whatever the result will be of the ID number. Right, so hopefully you're fine with the strings XML now. So please make sure that in all your applications you try to add as many of your text inside of the strings XML by just Alt Enter. So the next thing that we want to look at before we complete this video is to quickly have a look at how can we do a colors scheme or something that will help me with my colors in my application. So you can see that we've got this blue type of template here. So where you change this is in your colors XML. So again, under resources, values, colors XML, you will see your different colors. So they gave us here the color primary and the primary dark and the color accent. And you can see that your primary and your primary dark is the colors then that we use here. Your dark color there at the top, and this is your primary color. So if you change the colors in your colors XML, you are essentially going to change how it looks at the top there also. So let's quickly do this. And for that, I'm just going to open up Firefox there. You can go to the following website that will help you with colors. So it's www.materialpalette.com, and you'll get to a page that looks like this. So here you basically choose 2 colors. So I'm going to go with 2 colors. Let's go way out here. Let's take a blue there, and I'm going to take, or let's take indigo. Let's take indigo and pink, for example. So you'll see it gives you an overview of how your app will display. Let's remove the blue there totally. Let's go with a deep orange. That's too much. Let's take a normal orange and a lime. Okay, so this looks good. So we'll have an orange at the top, a darker one. This is the lighter version, the normal primary color, and this is an accent color then. This is how your edit text, if you remember, or well, when we run the app, I'll show you. But basically when the app runs, you can see that on an edit text, this little line there underneath the edit text will be the accent color. So choose your colors carefully. Right, so now we have a list of all the color codes there at the bottom. So you can see this is the dark primary color, that's the normal primary color, the light primary color, the accent color, the primary text, and so forth. And if you go to download, you can download the XML file with all the colors. The easiest way is to just go into this part at the bottom and copy your colors. For example, if I want to get the dark primary color, I just click on it and it's now copied to your clipboard. So now let's go back to Android Studio. I'm going to go into the colors XML and I copied the dark color. So I'm going to change that hash code there with a new hash code, and you can see it changes to the orange. So let's go to the normal primary color, which is this one. Go back to Android Studio, and there's the primary color. Paste it, and you'll have the orange. Let's quickly do the accent color as well. Where's the accent now? This one. And we change the accent color also to the new accent color. Right, and now if we go back to your main activity, you'll see that it looks a bit different now. So we changed the color scheme. Okay, so let's say that we want to add some more colors here now. So you'll see in these colors, we've also got a primary light color. So I'm going to copy that color as the primary light, and let's add that color here. So I'm going to say color, let's call this one, you see their naming convention will be primary, dark, primary, whatever. So I'm going to say primary light, change it off or close it off, and then you'll have the light color there. And so you can go and add all of these colors if you want to use them. Let's say you want to make your text this text color and your secondary text must be this color and so forth. So you can go and add all of these text or all of these colors and use them in your application. Okay, so for now, let's go back to the main activity. So you can see my colors are listed. And what is the reason also behind the colors XML and the strings XML? It's basically for code reuse. So every time I want to use a color, I can use this exact color that is basically the theme of my application. So if I use the primary dark everywhere, I know it's going to be the same color. Right, then the strings XML also, this is code reuse. Every time where I want to ask the user for his ID number, for example, I can just refer to this hint ID. Right, so if we go back to the colors XML, we called this one now primary light. So what we can do then is to go and change some of these colors. So let's say we want to have the background now here, let's say the primary light color. So go into the text tab at the bottom, and we're going to add the background property there. So we're going to add background, and you can see there's your colors. It's color accent, primary, primary dark, primary light. So I'm going to go with primary light. Go back to design, and you can see now it nicely fits into the other two colors. Now let's say we want to make this this color for the button also to be, let's say, the primary color or the primary dark color. So if you go into the text tab again and you go to button, you can do the same thing there. Set a background color for your button, and let's use it color primary. See how it looks. So there's the primary color, and you can now see the button is orange. Okay, so now let's say you wanted to have the text color on the button to be actually a white. So if you go down to the property, you can see that for your button, there's a text style. So for the style, let's make the style bold. And then you'll see there's a text color property. So for the text color property, you can also just click on the three dots, or you can start typing your color. So I'm going to use a hash 1, 2, 3, 4, 5, 6 Fs, which is a white. So that's the white color, and you can also change or add your white color inside of your colors XML and then refer to that color. So now the button looks a bit better. The text and so forth will still just display the normal black, but that's fine for now. Okay, so you can see then that you can use your colors XML in order to have your application look nice. Right, so this is basically it for this video. We've done the layout for this application that we want to use, and now the next step is to actually go and code what this application should do when the user types something in the edit text and clicks on the submit button. So I'll see you in the next video. Right, we are now on part 2 of this ID application, and if you remember from the first video, we just created the layout files and we set all the color schemes. So what we want to do next is now to connect these components to coding so that we can get whatever the user typed there, and then when he clicks the button, he interacts with the button, we want to show the results from the ID number that we gathered. So for this, we need the connected Java file. So we need to go into our Java folder. So make sure you're here under Android and then go into the app folder there, go into Java, open up your first folder and then open up your main activity.java. Now you can remember that we said for every activity, for every screen that the user sees, there will be 2 files. There will be an activity file, which will be a Java file, and there will be a layout file. So we are now done with the layout part, or basically done with the layout part. So in this part there, we defined how the layout should look, what the user will see. Now in the corresponding Java file, we need to set up the components so that we can handle whatever the user is doing. So if the user is typing a new ID number there and clicks on submit, what should our application do? And that is what will be defined inside of the main activity.java, or the Java file. So now before we connect those components, one main thing here in the main activity, you'll see it extends app compat activity. We start in the onCreate. Remember, the onCreate method is the very first method that runs when your activity starts. So that's why we start in the onCreate. Basically, the first line we get there is the setContentView method, and this setContentView sets the content view for the main activity. So basically we're saying when this activity starts, that's called main activity, we want to show which layout. In this case, we're referring to main activity, which is this main underscore activity XML. Right, so what does this mean again? What does the r.layout.main activity mean? In short, it basically means that in the resources folder, there's a layout folder, and that layout folder, you'll get the main activity XML, which is this one. So our main activity is connected to this file. So when the main activity starts, it will set its content view as this layout file that we just designed. But to get a bit more complicated, let's quickly go to the project folder, open up the first folder there, open up app, open up build, open up generated. Let's open up source then, go into R, and then you'll see that your project folder will be there. There it is. I'm going to open that one, and there you'll see the r.java file. So what we're essentially referring to there is this r.java file. Now this r.java file, you can see it's under the generated folder, which means that you should not change anything in this class. This class gets generated automatically. So I'm going to open up that file, and I'm going to quickly go back to Android. So everything that you basically do inside of your resources folder will automatically be generated inside of the r.java file. For example, if I go up a bit, you can see, I'm just going to go right to the top now. You can see that this class is a final class R. Inside of this class, we've got a few other classes. And one of these classes, if you just go and search for it, search for class layout there and click on enter, it takes you to the layout class. So inside of the r.java file, which is a class, the r class, you find another inner class called layout. Now, if you go to main activity again, so you can see we're referring to the r.java file. Inside of the r class, there's a class called layout. And inside of that layout class, there's a property called main activity. And that is essentially what we're referring to. So what happens with your r.java file? If you create anything in your resources folder, whether it's a picture, whether it's an ID on a component, whether it's a strings XML entry, whether it's a color, whatever, it gets saved into one of these classes as a property. So you can see there's the layout. So everything in your layout folder there will be saved here as a property, and you can see your main activity saved there. You can also see that there's the mipmap class, for example, if you put anything in mipmap. There's the string resources. So every string resource that you create will actually come in here. Also, you can see there's our app name, for example. Everything will go into your strings resources, and your styles will go here, and so forth. So we've got a class for everything that we create inside of the resources folder. We'll come back to this r.java file again, but basically what happens then is we're saying go to that r.java file that's automatically generated, go to the layout class, and in the layout you'll find a layout with the name main activity, which is in fact referring to this whole activity or this whole XML file. Right, so that is just a bit of background on what is the r.java file and why is it there. But basically you don't need to know anything about the r.java file. You just need to know how to reference it. It will automatically be generated. So basically, in short, R means it's in the resources folder. Layout means it's in the layout class there or the layout folder, and there's a main activity XML file. Right, now the next thing that we want to do now in coding is we want to make a connection to these three components. So we've got enter the ID number, we've got the button, this one is called an edit text, this one is a button, and that one is a text view. Now in order to work with these components in coding, we need to give them an ID. So for this one, you can see the ID is just called edit text, which is not a good way of doing it. So what I like to do is, let's say it is an edit text in this case, I will start off the ID with ET for edit text. For a button, I will start with BTN for button. And with a text view, I'll start with a TV, text view. So it's up to you how you want to do this. You'll see in coding that it's a bit easier to do it this way. So I'm going to call this one ET and then give it a description ID. So I know all my IDs that starts with an ET is edit text. And all my IDs that starts with a BTN is buttons. And all my IDs that starts with a TV is text views. Okay, so I'm going to say this one ET ID. This one will be, let's call this one BTN submit. And we call that one TV results. And now you can see on your component tree also, you can see the IDs. ET ID, BTN submit, and TV results. So it's very important that if you're going to interact with these components and you change it on screen, you need to have IDs for your components. Now, just to quickly show you how this generated now in the r.java file, let's go back to the r.java file. I closed it now. I'm going to go into app. Let's go to build again, generated, source, R, go into that one. Okay, so let's search quickly for class ID. So remember we created IDs now. So let's look at the IDs quickly. We should get, for example, a TV at the bottom somewhere. And if you go to the bottom of the ID class, you'll see that there's, for example, TV results. If I go up and we search for ET, there's ET ID that we just created. And we'll also see the other one was for the BTN submit, and there you can see the BTN submit ID. So it's under the ID class inside of the r.java file. Okay, so I'm going to go back to the main activity, and now we need to set up those three components. So the first component is called an edit text. So you'll see that Android Studio gives you some autocomplete functionality. So you can just start typing edit text and then click on it, and you can see it adds the import for the edit text automatically. And then I'm going to call it the same as I had my IDs in the layout file. So for this one, it's called etid. So I'll name it exactly the same here. Why do I do that? Do you need to do it? No, definitely not. It's just easier for me to see that this one belongs to this ID there. So I name them exactly the same, so it's easier to work with. Then the next component was the button. So let's say that you don't choose the button there. Another way of doing this is also to go and say Alt-Enter, and Alt-Enter will also add the import for you if you do not select it. So we're going to say button, and we called that one button btn submit. And then the last component was a text view, and we call that TV results. So just declare your button and your edit text and your text view at the top. Now the next step is to actually take this variable of us that's currently a Java variable, and we want to connect that variable to a component that's on an XML file. So how do we do that? Luckily for us, this r.java file makes it available for us in Java to refer to that specific component in memory. So what we can do now is to say etid should be, and there's a nice method that we can use that's part of activities. So if you extend app-compat activity, you will have this method available to you. So we're going to find a view by its ID, and we're going to go to the r.java file. We're going to go to the ID class, and we want to get that specific etid. Right, let's just do the same for the button also. So we're going to say btn submit equals find view by ID, and again r.id.btn submit. Let's do the last one also. So it's going to be TV results equals find the view by its ID, r.id. That one is called TV results. Okay, so now what we've got here is 3 Java variables connected to 3 different IDs that's on a specific layout file. So the layout file where we will find these must now be on the one where you set the content view. So if I say main activity there and then use find view by ID, it's going to try and find the view by its ID on the main activity, which is this file. So if you do not have an ID there with that specific ID, then it will give you a problem. So just remember that in the r.java file, doesn't matter where in which layout file it is, it will start adding IDs. So you must make sure that your content view is set correctly for your activity. So main activity is this one, and then on this one, we are finding the view by its ID by referring to these IDs. So now after these 3 lines, etid, the Java variable, is now connected to etid, which is this one. And the same for the btn submit and TV results is now connected to btn submit and TV results. Right, so now that we have the components connected in coding, now what we want to do is to go and see what happens when the users start interacting with these components. So obviously when the user starts typing something in there, we don't want to do anything. We want to wait until he's done there and he clicks on the submit button. As soon as he clicks on the submit button, we want to get whatever he typed there. So for this, we need to set a click event on our button. Now this we call an on-click listener. So let's go to the button component, which is btn submit. It's already connected now to btn submit. So then we can say set on-click listener. So just start typing until you get this. Set on-click listener. Click it, and then in the brackets you'll say new on-click listener. Just start typing on, and you'll see it gives you this view.onClick listener. Right, so basically now we've set an on-click listener to the button so that when the user clicks on the button, we will go into this pod and into the on-click method. So when the user clicks on the button, it will go into the on-click method, and we can now do whatever we want to do. So now if the user clicks on the submit button, what do we want to do? We want to get the ID number from the user. So now in order to get the ID number from the user, let's just start with a variable, and we can call this ID, or let's just call it ID number equals. Now we're going to refer to that edit text, which is this one called etid. And from that etid, we want to get the text that the user typed. So I'm going to say etid, like I declared it there, dot get text, that gets the text, .toString converts that text to a string so that we can use it. And then if needed, you can also use the trim method. So the trim method also belongs to any string in Java that takes away any leading and trailing white space that the user entered. So it's up to you whether you want to use trim there. So let's say, if, for example, you're asking the user for his email address, and you know that most keyboards adds a space after the email address, and that could give you some problems. So by using the trim method, you are removing the space at the back and at the beginning of text. Right, so this is an important line of coding where we go to the edit text, whatever the user typed, we get it, convert it to a string, and then if needed, you can trim it. Right, so now we have the ID number and we've got the full ID number. So you remember this is the ID number. If the user then types the whole ID number, what do we want to extract from this? So I'm not going to make this a lot complicated. I just want to get the date of birth, and you can see the date of birth is the first 6 characters basically in the ID. It's those 6. So if we want to take a substring as in Java, we will take it from position number 0, 1, 2, 3, 4, 5. So remember that strings are numbered in characters from position 0. So it's 0, 1, 2, 3, 4, 5. So now you're asking, but why am I talking about a string and this is numbers? Well, we want to extract this whole number as a string, as text, so that we can work with all the individual numbers. So in this case, we're going to extract the 880123 just to get the date of birth. So we want to extract from position 0, 1, 2, 3, 4, 5. 0 to 5 is the characters that we want to extract. So I'm going to call this one string DOB for date of birth, and we're going to get that string by saying ID number, that's the whole ID. So ID number will refer to the whole ID number, and on that ID number I want to only extract the first 6 characters. So I'm going to call the substring method where we've got a begin index and an end index. The begin index will be at position 0 and the ending index will be at position 5 actually, but the substring works in this way that you say it's going from position 0 up until position 6 minus 1. So this will extract position 0 up until position 5. So if you look again at your picture, it's going to go from 0, 1, 2, 3, 4, 5. 6 is not included. So that 6, the last one there, is not included. Right, so now we have the date of birth. We've got the ID number. From the ID number, we have the date of birth. So the next thing that we can extract from this will basically be the gender, whether you're male or female. And they say it's the next 4 digits are used. So 1, 2, 3, 4, 5, 6. It's the next 4 digits. Those 4 digits will tell us whether it's female or male. But you will also see that male will be from 0 to 4,999. So basically we can just look at the 5 there. If it's a 4, a 3, a 2, a 1, or a 0, we know it's female. If it's a 5, 6, 7, 8, or 9, we know it's a male. Okay, so we're only going to extract this one character, and that is at position 0, 1, 2, 3, 4, 5, 6, at position 6. So let's just quickly extract that one. So I'm going to use that as an integer because I want to compare to see if it's less than or greater than 5 or whatever. So I'm going to call this one, that is for the gender. So I'm going to say int gender equals, going to the ID number again, dot character at, to get a character at a specific position, and the position where we want the character is at position 6. So let's just go to that one again. 0, 1, 2, 3, 4, 5, 6. Position 6 is the character we want. Now you'll see that we do not have any errors here, even though we're extracting a character and we're receiving an integer on the other side. That's because characters can also be represented as integer numbers in ASCII code. So unfortunately, the value that we will get there will not be correct. So what we want to do is to first convert this character to a string and then convert that character back to an integer. Right, so the easiest way to convert anything to a string will just be to add a double quotation mark there. But that could in some cases it could give you some problems. So what we will do here is to use the character class. So I'm going to say character dot toString, which converts any character to a string. and then I close the bracket. So we will basically say get the character at position number 6 and convert it to a string. And then what we want to do is to convert this string now to an integer. So I'm going to do the following: integer.parseInt, and the parseInt method takes any string and converts that to an integer. Right, so now we've got the character at position 6, which will be a number. First we convert that to a string, and then we convert it to an integer. So now we've got the integer value there of the value that was at position 6. So in this case, it's an integer value of 5. So let's quickly do the check there. We're going to say if this gender value, if we just quickly look at the picture again, they say if it is 0 to a 4, which means if it's less than 5, then we know it should be a female. So let's just make it less than 5. If it's less than 5, which means 4, 3, 2, 1, or 0, then we know the gender should be a female. So let's just declare a string value here. So I'm going to call it sGender for the string version of the gender. Let me just check that again. So if it's less than 5, it's female. So we're going to set sGender here to female. The else part there will be that sGender should be male. Right, so that's basically the gender, that value that you receive. If it's less than 5, it should be female. Otherwise, it will be a male if it's 5 or more. Right, so the next part that we need to extract from this picture should be your citizenship. So the citizenship will be this character there. So if we just quickly have a look at the characters again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is position number 10. So let's just do this again. I'm going to use an integer again. Let's call it nationality. Again, we can do this whole thing there that we did. So I'm going to copy that part, paste it. But instead of extracting character number 6, we want to extract character number, or position number 10. So now we've got the nationality as an integer, but ultimately we also want that nationality as a string. So I'm going to call it sNationality, and we're going to do the same thing. So what do we need to compare here? If it is a 0, then it's an SA citizen, else it will be a permanent resident. So we're going to test if the nationality is 0, then sNationality should be SA citizen. The else will be sNationality will be permanent resident. Right, so 0, SA citizen, permanent resident is if it's a 1, if it's not a 0. Okay, so now we've got the full ID number, we've got the date of birth, we've got the gender, and we've got the nationality. So now we've got all the information, and we need to show this information now to the user. How do we do that? So where do we show the information to the user? We want to use this text view. So this text view is called TV results, on the left hand side, TV results, and we linked it up with this variable called TV results. So the only thing that we need to go and do now is to go and say TV results dot set text, and that sets some text to that specific text view. So what do we want to set now here? We want to show all this information. So the first thing we want to show here is to go and say, let's start with the date of birth. So we're going to say date of birth, and then show our DOB variable. So there we had the date of birth. So we show the date of birth. Then I can go to a new line character and then show the rest. So after that date of birth, we will show the gender and show our, well, in this case, our sGender. And then go to a new line again. And then the last one we want to show is the nationality. and then because it's the last thing, we're not going to add a new line character again. So basically we want to set the text as date of birth, then show the date of birth, the gender, then show the gender, and the nationality. Oh, we must remember to show the nationality as well. And that will be S nationality. So remember that S gender is the string version, male or female, and S nationality is the string version, SA citizen or permanent resident. And that is setting the results on your screen for the user to see. Right now you'll see that Android Studio is showing you something like this that says do not concatenate text with set text, use resources with placeholders and so forth. So if you okay with this, you can carry on using your application just like it is, without any problems. But you remember that in the strings XML file is where we should basically place all of our text. So if we want to get rid of this error, what we can do is to go into this date of birth, use Alt-Enter, and extract the string resource for it. So I'm going to call this one, let's say DOB, date of birth. And now in my strings XML, you'll see that there's DOB, date of birth. So now in my Java file, how you refer to it is by saying get string, that gets your strings XML. And in that strings XML, there's an ID called DOB. And that's the one that you're referring to. That's the DOB. Okay, so we can do the same for the gender. Alt-Enter, extract the string resource, call it gender. The same for the nationality. Alt-Enter, extract the string resource, call it nationality. And you can see that it still gives you a problem, so we can do the new line character as well. Alt-Enter. Extract the string resource, call it new line, say OK. I'm going to copy that one for the new line because that one is exactly the same. We're going to use the new line character there again. Okay, so this is then the text that, and you can see even though you've added this now into the strings XML, it still gives you a problem because it doesn't like you to concatenate using the setText method. So to overcome this, you can go and say string text should be, and then you just copy everything that you had in that setText method. Copy it, or let's cut it, and we paste it there. And just put your semicolon at the end. And then we send in the text property there, or the text variable. And then Android Studio is fine with this. It's got no problems further on. You can also do the same for this female there. Alt-Enter, extract the string resource, call it female. For that male there, Alt-Enter, extract the string resource, call it male. For SA citizen, the same thing. Alt-Enter, extract SA cit. Same for permanent resident. Alt-Enter, let's call it permanent. And then you've got everything now in your strings XML. So if you do any translations, everything that you translate from here will then be translated in your coding as well. Okay, so that's basically getting rid of all the errors there. Let's run this quickly and see how this runs on our device. Right, so if your application is running then on the phone, should not be any problems. You can see, this is now the first time we run it. You can see that in my colors XML, my accent color is this green or lime color. So you'll see in my virtual device also, that's the lime color there that I have underneath my edit text. So you can see one problem here is that we do not want to have the user see this text view there. We want to only have the user see this as soon as he clicks on the submit button. So we'll fix that now. So we can add the ID number there. Let's take something like 74 01 27. Let's say something like that. So if I click on submit now, you can see it gives me the date of birth. Okay, so now we can see that /n did not work very nicely with my strings XML. So we will get back to that one. So there's the date of birth, there's the gender male. So that 5 there is a male. If I make it a 4, it should be female. The nationality is an SA citizen, but if I make that 0, let's say a 1, it should now be a permanent resident. So let's just quickly fix a few things here. Let's go back to the main activity. Instead of this new line character there, I'm going to add a new line character there. And the same there. For this new line character, we will add a /n there for the new line character. Now we can test it quickly to see if it looks better now. Okay, so let's just add the ID number again. Let's say something like this. Click on it, and now the date of birth, the male or the gender, and the nationality is shown to the user correctly on a new line, and that's what the new line character is doing for us. So now the next thing that we want to change is that text view right at the beginning. So when the user opens up the application for the first time, we do not want him to see this text view. So this text view is declared as TV results. So just after you've initialized that variable, we can go to TV results and we can set the visibility on it to view.gone. And that will remove TV results from the layout totally. Now, as soon as the user clicks on the button and we've set the results to it, we can set that visibility back. So we can say, sorry about that, let's just say TV results dot set the visibility, and I'm going to say view dot visible, and that will make it visible again. So right from the beginning, it will not be shown, it will be gone, but as soon as we click on the button and we worked out everything, we show it to the user. So let's see if that works. All right, so you can see that the application starts without any text view there. So I'm going to try and add an ID number again. Let's say something like this. Click on submit, and as soon as I clicked on submit, you can see that these values appeared. Okay, so that's it for your very first application. It's a very important application, this. It teaches you a lot of things about the Android operating system, or how you need to code in order to create your applications and connect components. So make sure that you go through this video again and you understand the concepts. Now that we are done with both explicit and implicit intents, this is a very nice challenge to make sure that you understand what we've learned. So you'll see on the main activity, what I want you to do is to create an app with a text view there and a button that says create new contact. Now on this activity, there's a few components that I've hidden so that when I start the next activity and I come back to this one, I will only start displaying it. So see if you can do that. I'm going to click on create new contact. I'm just going to add a name there. You add a telephone number there, so we're going to use implicit intents here as well, and a website, let's say backendless.com, and a location, I'm going to say 5 Nelson Mandela, let's say Bloemfontein, and then you can choose one of these pictures, and whichever picture you choose here will also be shown on the next activity. So if I click on the red face there, it's going to go back and show the red face there. So this is again the activity where we started. We started with this activity, but I've hidden these components. So now they are showing, and you can see the exact same face I clicked on the other side is showing now. Also, if I click on call, I'll have exactly that number I typed on the other activity. As well as if I go to the website and I say open up with Chrome or whichever browser, it will open up that web page that I specified. And I specified backendless.com. Also, if I click on the location, it should go to Nelson Mandela Drive in Bloemfontein. Right, and that's basically then the app that you need to create. So see if you can create this. This will be a nice exercise, a nice challenge for you to see if you understand explicit and implicit intents. Good luck.